All right. That's a little quiet. I guess that's normal. Seems a little quiet. Usually I'm just about at peak. I guess that's okay. All right. Weird. I didn't change anything. Didn't touch anything. There's salt all over the desk. Let's get the salt out of here. I'm currently 3D printing a bunch of stuff. Trying to get the printer to get all the different layer weirdnesses correct for the overly tactical bug assault. The bug assault rifle. Got parts coming in for like every project, all the parts, all the time. Every day, every hour, every minute. So much salt. Everything is covered in salt. Now I'm covered in salt. The salt, oh God. My only problem is my printer is really bad at printing stuff over support. The layers all get destroyed. So, had a couple attempts here. Get things right. Currently, it is printing the bottom piece, because you can see the one there is lifted up a little bit. But, you know, I got the test piece in. A vertical foregrip really changes the character of this thing. This salt launching apparatus. It's actually pretty funny. Look at this. It's like, it's so tactical. The only problem is this doesn't grip the front peg, so I narrowed this piece a little bit, and that's what's printing right now. Also lengthened it, because at full cock, this should now come all the way back to here. So that'll come all the way back when it fully cocks, and this will give it a little stability when you're pulling on it backwards like that. It'll be able to hit up against this area and pivot on the metal peg. Yeah, see, I got all that extra space. So I utilized it. But yeah, getting these things designed, the block pieces at the front and the back are just for flair. Fusion 360 assumed that I wanted those there when I lengthened it, and I was like, you know what? That actually looks kind of cool, so I'm gonna keep it. So I got rails on both sides. I could put a flashlight on it or a laser on the cocking handle. I have a license for that. I got the shoulder thing that goes. Guys, I got a special surprise for the buttstock. I already ordered that Nerf part, but I got a special surprise for the buttstock. That'll be in the near future. I'm not gonna tell you what it is. Listen, if I threaten you with this, my stream goes down permanently. All right? So I am not going to threaten you with this. I am not gonna threaten to shoot you in the eye with salt. I'm not gonna do that. That's not what I'm gonna do. I am explicitly not doing that. Very, very explicitly not doing that to you. That's not what I'm doing. I'm gonna fire this into the garbage. Salt. Yeah, I would have to not go to VA to not do that. Yep. That was too many negatives, but I think we'll get by. Yeah, so that's that's the overly tactical bug assault. This, I thickened the sides, but the problem is I had to print it so that these posts would print out clearly. And if we look closer, my printer is not good at printing on support material. So, oh God, it's also not good at looking at red stuff. threemares just subscribed saying, we'll put you up on the board in a minute. We also had an over the weekend stream, or sorry, over the weekend sub. Oh my God, the kazoo is starting to get into my brain. We had SchnedCrabster sub with a prime 3 days ago. It's pretty cool. Always appreciate those over the weekend subs. What they do is they get stored in the board, and then when I go to it and turn it on, then it'll burn up. Yeah, so just for flair, Oh, I work with them? Oh, you know who that is? Oh, that's cool. Oh, cool. Okay, so it's a coworker of yours. Yeah, we'll put him up on the board in just a second here. I just want to catch everybody up with what I've been working on over the weekend. There was roommates had a bunch of people here for Labor Day, so I got to explain my dumb ass to everybody. Yeah, modifying a thing that's used to kill bugs, but just like you shoot the bug with the salt, and so I'm putting like a scope on it because it's dumb. Yeah, that felt great. Being a streamer and explaining your life to people is kind of difficult. I educate people about stuff sometimes. Wait, why is there what looks like a grain of glass on this? Oh, weird. But yeah, so this is printing on the bed, and then there's support material for my little cutouts that are decorative. But yeah, those fit into these pieces up here. And so I had to make them, they actually have a right and a left. Because yeah, see that one's right up against the front there. So that's the one that fits right up near the reservoir. And then it crosses over this area. And then I made a Picatinny rail for it so that I can mount a $60 red dot sight. Now the thing is, on the ones that I've seen where they've made an adapter for this thing, what they've done is they've given it a 3 to 4 degree tilt. 3 to 4 degrees. So I might want to do that with this. And if I have to do that, I have no idea how I'm going to do it. I think what I need to do is I'm going to need to split this into its own object, which is what I did on this one. What I did on this one, and my Fusion 360 files are absolutely a nightmare. I took the plane of the body, the plane of the face of the body, and I split off this piece, and then I cut and pasted to the other surfaces. So I'll need to do that with this one, and then tilt it upwards, and then bridge the material. Yeah, a 40 millimeter, a 40 mic tennis ball launcher on the bottom. No, I mean a flashlight would be hilarious. I think a flashlight would be a flashlight, maybe a laser. It depends on what bugs are scared of. But having the vertical foregrip makes it so tactical. It's so weird. Can attest, having things at an angle in CAD is a pain in the ass. Yeah, it's like I can't extrude it from a drawing because then the drawing would have this angle on it. I wish you could put in placeholders in AutoCAD. Like you could have a placeholder for an angle that's 0. Actually, I probably could do that, actually. If I really like was a stickler for putting together the drawings, you can put in a placeholder for the angle that it's gonna tilt. You have to like know ahead of time that you're gonna do that. So I think the easiest thing for me to do is to take the piece, which is actually this one here. This one lifted because I put it in a weird spot on the bed. Yeah, Deadly Premonition music. Somebody mentioned it recently. Oh yeah, it was one of the people that I was playing. We were playing Deep Rock Galactic, and he was like, "Yeah, I've started kind of playing Deadly Premonition." I'm like, "Ooh, I gotta put that music as the that's the background music." What I can do is I'll take this in CAD, select this face, and have it split along this face. So it'll split the rail off. And then all I need to do is tilt it using one of the lines in the front as the axis. So I'll tilt it 4 degrees using one of the lines in the front as an axis. Boom. And then I can extrude from object, and the object would be the face of this that I've revealed by moving the angle up, to object, and it would be the bottom of this thing. And it'll just bridge the gap. And then in the future, if I want to change that angle, all I have to do is go back to that step and change the angle. Exactly. High speed, low drag bug assault. You got it. Anyway, that's been my weekend is getting all these numbers together and stuff. But it works in the end. It was just kind of annoying to put together. I had to make sure that these had like an offset so I could center them properly. It's funny because the cone of salt that fires out of this thing is just ridiculous. It's a huge spread. So there's no all of the science and technology that goes into making these parts accurate, and the sighting equipment that goes on them is well outmatched. It outmatches this thing by like orders of magnitude. But yeah, that's the fun of this thing. So I'm still printing parts. The red is not doing so well for the support material, by the way. I mean, this one turned out perfect, but it started to show like little gaps. Yeah, little gaps in the print. That warning should be on all guns, not just bug assault. There are actually in the manuals for guns warnings. They put that stuff in the manual. Oh no, I got something special for the shoulder thing that goes up. Don't worry about that. Don't you worry about that. I'll worry about blank. All right, let's put these names up on the board. I got something special for that. I went to my buddy and I said, hey, I can't find this particular thing. And he's like, I got you. And he linked me to exactly what I was looking for at exactly the price that I was hoping. And it's probably a piece of plastic, but it'll do just fine. The other thing that I need to find, as the song crescendos, the other thing that I need to find is a shotgun shell that has like a screw top on it that's for like storing stuff. I would love to have a couple little storage bins that are shotgun shell sized that hold salt. That would just be the icing on the cake. Bum, ba. Silly Russell, thank you for gifting a sub to LebtvLive. Now you're thinking like a shark. No necks. Schned, welcome to the board. Thank you so much for the weekend sub. Oh, we're going over to the threemares sub. I'll change the music in just a minute. Ah, my hand. Ah, I need a place to put this computer case. Hold on, I'm gonna try to find it while threemares burns. And I guess I could just put it on this stool here. Oh, that clears off the table. Looks nice. Problem is I'm gonna bump into the computer case and send it into orbit. Threemares up on the board with a total of 36 months. Oh, change that warning, do not aim at humans. I wish I don't have the manual for my my guns no more. I might, actually, you know what I might? Beretta shotgun shell pepper shakers. Are they the size of a shotgun? They look a little weird at the top, but I mean they're too silvery. I want something that's like dumb and plastic. That's LebtvLive going up thanks to Celia Russell. Celia Russell, thank you for gifting LebtvLive all the damn time. That's so nice of you. Bum, 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 bum. Bum, bum, bum. Bum, 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 bum. It's printing. I don't know, you guys probably can't see that very well. There's like no light on the printer. Once this ends, I'll find new music. I'll put up, we'll do like FTL music. All right, let's see here. A model one for you this week? That could be good. Yeah, I could print those just fine. That would be good. Get some small flip-top pill bottles. Paint them to look like shotgun shells. Yeah, that's one. And then there's the pepper shaker. They're all online. Yeah, I wonder if I can Thingiverse one. Leb has done a lot. Leb is the guy that I go to when I want to do something weird. He's helped a lot with the production of this. Oh, the manuals are online. Oh, yeah. Don't they? All right, so let's just take a look here. Just some randomly chosen. I love how it's like a data sheet. It's like a general data sheet for like 600 different guns, because they're all the same platform. Certain states require by law their own specified warning notices. Unlawful storage of a loaded firearm. There's salt on my table. I'm gonna brush the salt off of everything. Yeah, known to cause cancer in the state of California. Maryland. Children can operate firearms. Massachusetts. This handgun is not equipped with a device that fully blocks the use by unauthorized users. Okay. New Jersey. Just don't even. New Jersey is just don't even. New York. Locking device. Don't even again. North Carolina is like, I don't know. Whatever. So yeah, they all have, you know, this kind of stuff, which is, you know, the cardinal rules of owning a gun, obviously. That is a good rule. I didn't know there were 12 of them, but you know, locking device. It's literally, we are at page 7 and we're still in warnings. None of this has shown you how to operate it. None of it's shown you really how to, you know, put a lock on it. There we go. We're finally into the actual thing. Oh, but we've got more warnings. I mean, as a device, like, this garners a lot of warnings. Let's be fair, you know? I think we get off easy with the bug assault saying don't shoot it in people's faces. Do not shoot in face or eyes. Like, it's the Kids in the Hall sketch, don't put salt in your eye. Like my mom always said, don't put salt in your eye. Don't put salt in your eye. Don't put salt in your eye. Don't put salt. Put salt in your eye. Put salt in your eye. Put salt in your eye. Do not alter any firearm. Don't do it. Don't. Yeah. Lot of crazy stuff here. But anyway, like I said, they all have warnings on them. You'll put your eye out. All right, there. Let's get out of this hellish. No, don't start again. Let's just do FTL. I can't listen to the whistling anymore. It's too much. Let's go like deep into the FTL soundtrack. What do we get? There's like 40 minutes of ambient noises and then there we go. This kid had a BB pistol that was made in China. Had a warning on the side: do not shoot today humans or animals. Human! I need to get my seltzer. There's so much salt on the desk. Oh my god. It's never going away, is it? It's never going away. It's just always, there will always be salt. So much salt. Let's see. We're doing Arduino basics, so we're gonna be using an Arduino Uno today. An Uno. I really could use like some prototyping board. I guess we can break down the motor testing board. I guess that's what we can do. Oh, this power supply's still on. What a waste of energy. I'm guilty of energy wasting. DrPlugger, hey, 26 months. There's a 10-hour version of the whistle song. There's a 10-hour version. Well, I'm in a situation right now where I'm waiting on so many parts for, where I'm waiting on parts for like everything, and they're coming this week. I'm coming. Is that, what's his name? Meme. But no, I got all the parts coming in the mail this week, so I gotta do something, and I think the best thing to do is just to go back to our roots and do something very simple. So I'm gonna try to find something cool in the shop, some component that we can then work with an Arduino. Twisted Sister gifting a sub to Scott361. What happened? What happened to the other 360? What happened? DrPlugger, welcome to the board. Somebody got shot. What happened over there? Oh, I don't really know where it is. It's somewhere around here. I don't see any bops. Damn it. Oh, wait. Ooh. A near miss on Drunken Bear Gaming. A near miss. Pretty good. So we got Scott361 coming in thanks to twiztedsister, and then Mahalo also gifted one to Shunned Ones. Don't worry, Scott says, don't worry about the other 360. I'll worry about blank. Oh my god, oh my god, oh my god. Guys, don't mention it. Something bad's gonna happen. We don't want to mess with that. Here we go, Scott361. Thanks to twiztedsister. Going in, oh god, it's a collision. Well, destroying Neurotic Nerd for some reason. The collision code, not up to snuff. I don't know why. It did well for so long. There were a couple ones that were like, I don't know. And now a collision is like every other name that goes into the board. Don't know what happened. Maybe a power outage hit the database somewhere. Database is still going strong. It's too big for me to upload to GitHub anymore, unfortunately. Unless I split it into parts. I guess I could add it to like a RAR or something, but RAR. I could ooh-woo roar it into multiple parts, and then maybe it would be able to go up there. But hentai ruined my life as a new friend, and it's Shunned Ones, which makes sense. That all adds up. Thank you, Mahalo, for the gift sub. Hey, Proteus. 100 bits. Thank you for the 100 bits. Rip this board. There's not much life left in the board. Yeah, it's Mahalo, but I interpret it as Mahalo, as if I'm saying hello. Mahalo! You are indeed on the board. That's what happens when you subscribe around here, is you get your name lasered onto a board on my wall. It's not that big of a board. There it is. When that thing fills up, twiztedsister gifting a sub to Proteus. Oh, we'll put that up on the board. Looks like we jogged all the way home, so nobody got blasted by lasers. But yeah, when you sub to this channel or you gift a sub to somebody on this channel, their name goes up on this board. It's all interpreted through the Twitch API by a Raspberry Pi that's running a lot of Python. Now, I probably at this point forget how to code in Python. I remember it being very intuitive and quick. It was good for rapid prototyping. It is, however, rather slow on the Arduino, or sorry, on the Raspberry Pi, because it's going through actual written language instead of being broken down into machine instructions. But what those threads do is they are going through and creating a virtual board in memory. They're vetting out the name that gets sent in. So if you gift a sub, the giftee goes up on the board. That's why there are a lot of ridiculous names on the board. I didn't exactly get Ninja to find my stream. I think Ninja's like somewhere over here. They gift a sub, it goes into the board, it's turned into text. All of the database is then turned into text on an image, and then it's broken down into ones and zeros in terms of brightness, and then it's compared to itself at random locations. So Proteus, when in a random location, it had happened to perfectly center itself between the F and the D of FunkDev. That's pretty cool. That is a random occurrence. That is Raspberry Pi's Python 3 random number engine doing that. Water cooling hoses on your Raspberry Pi, yeah. So when we tested this thing, it, this big motor over here, back here, that big motor, the X motor, that's powering 2 belts for the entire X axis. Oh, we got another sub that's coming in. We can watch the LEDs. Each LED represents a thread that's working on the name. But yeah, when we were testing that big motor, the drivers overheated and it skipped steps. So in my fear, I actually found Raspberry Pi water blocks, and I bought 3 of them because we have a Raspberry Pi and an X and a Y axis. And so we've water cooled the drivers, which we're not going to be water cooling the drivers in the new one. That'll get a fan. But it'll also, the new one might actually water cool the motor and the laser. The motors and the laser, it depends. See, there it goes, a little cascade of LEDs that represent all the threads, placing things. I need to change out that reservoir. It's getting a little gross. There's still technically liquid in it, but this doesn't really need to be water cooled. It's just a little bit memey, and at the same time, our theoretical testing did not line up to real world testing. So we put the motor under a significantly larger load than I think it gets while moving the axis here. All right, I wasn't able to read that because it was all the way across the room, so we'll see who's going up right now. I'll come back over here. This is Molequles. Welcome to the board. You're by Professor Melko and Melbell12. There's some old school names around here. It almost looks like it's on the same line, but I think it's up a little bit from where it was. So did you try overclocking it all? Why? If control board V3 isn't fully immersion cooled, I'm unsubscribing. Listen. That Granite Devices controller was like $1,000. I'm not putting it in oil. I'm not doing that. Twiztedsister, another gifted sub. This time to Sergeant Pyroman. Not gonna be able to sit down today. And there goes the level 1 hype train. Everybody missed it. Goodbye, train. Goodbye. It is 20% off subs this month, by the way. I think I'm like obligated to advertise that to you guys. When those lights come on, when those LEDs come on up there, that means that little high temperature like coffee maker pump turns on and it barely moves water through the pipes. And that's all that's really needed to keep this thing cool. There's an additional Arduino that's monitoring temperatures. That was an add-on for version 2. We could have had the Raspberry Pi managing that. I just didn't feel like adding a thread or anything to this. So in the future, I'm hoping that we're gonna have just one central processing unit, possibly a Raspberry Pi. Ooh, that's a lot of, hold on, hiccups. Ooh, trying to talk and my diaphragm's like, oh, wait a minute, you're moving around? Hey, stomach, why don't we burp like a lot? Why does it do that? Well, bastard. But yeah, I'm not gonna do like I'm not gonna meme it up and do Raspberry Pi 4, you know, on this thing. I think a Raspberry Pi 3 is all it needs. And if I do Raspberry Pi 3, that means I've got one to swap out in case it dies, which happens. Sergeant Pyroman, welcome to the board. Thanks to Twiztedsister. That is a lot of gubs. That's a lot of gift subs. Gubs. What is my brain? What is happening? Thank you for the follows as well. I miss saying thank you to a follow. Nothing personal, kid. Yeah, I mean, I want to play with a Pi 4, but I just can't justify it. The Raspberry Pi in and of itself, like, I saw a post the other day that was that meme of the guy waiting around in the various locations, and it was like me after getting a Raspberry Pi 3, like trying to find a project for it or something like that, and it was just the guy standing around. That's me. I have since the inception of the Raspberry Pi, I've been like, what am I gonna do with it? What do I do with it? Detorq! Thanks for all the informative and interesting streams. Well, they're over. I'm done doing that. We're no more information. No more information on this stream. We're done. Sorry. That's just where we are. I'm just gonna show a camera of my face as I read a book. That's it. And I'm not even gonna show the title of the book. I'm just gonna read the book, and it'll just be a close-up. It'll be a close-up of me just reading a book. Every now and then I'll go, Maybe I'll do a little bit of this. I'll cough. That's it. That's the whole stream. Let's put you up on the board. Thank you, DTorq, for subbing. Oh, the drums ended. No more drums. Drums have been taken away too. They were too much like information. I'm gonna be sweating today. It's already very humid in here. It's probably 80 degrees. Drums are back. DTorq, you're right by Chode Lyoko. It all costs money. It certainly does. Better be the Great Gatsby. I'm not telling you what book. I already told you I'm not going to tell you what book. You managed to run Wine and WoW on Raspberry 4. I don't care. It's none of this. I'm not gonna run games on my board, you know? Listen, I'm an embedded programmer at heart. Everything with a purpose and no excess, you know? I'd like to say no excess, but there's always excess, but whatever. It all costs money. 2 months. Eventually, the API is going to pick up on you. Pub sub or whatever the hell we're using. I got a Pi 400. Use it for Atari and Amiga emulator. Huh. Man, you guys all make fun of my code. You glass house living motherfuckers. All commenting on my code and how horrible it is. Oh bother codes like it's ladder logic. Oh bothers, this code's a war zone. Fuck off. Glass houses, I say. As if you guys learned Python live on stream while trying to partner your channel. Glass houses, all of you. Which is really awkward because it's, you know, the bathroom's glass. So it's like, what do you do? You know, the neighbors are like really disturbed. People walking their dogs in the morning. It's horrible. I don't know why you guys moved into a glass house or who even built it. Who even built that? I don't know. It all costs money. Time is money. Everything is money. Monetize everything. Every single human action and emotion should be monetized. Your side hustles will now need to be side hustles. Everything, every camera's all the time. Cameras watching you. People watching you through their computers all the time. Everything monetized. It all costs money. All right. Reading an O'Reilly book? Wait. No, that's not. I learned Python reading a Chilton's manual about a VW. 1984 VW. Assembly is the reverse of disassembly. I think I'm on the board twice. Yeah, when you resub, you get on the board again. I want to see if I wonder if I could have used these MOSFETs. This is a protection board for a battery bank. This is for a lithium-ion battery. This thing is designed to, well, I mean, the fact that it has a very low ohm resistor on it means that it's monitoring current. So this is a current monitoring MOSFET cutoff. I wanted to see what these are. 4409 BA15. It looks like they have P's and N's on it. 4409 BA15P. All right. I want to look that up real quick. I think I got that out of order because I've got some guy in tights. No, it's some girl in tights. Traveler Health Coordinator. All right, let's go back. Let's go back. What is this thing? 4409 BA15-1P. BA15-1P. Okay. 4409, split it. Steering system equipment. Let's add transistor to it. Why am I sure it's transistor? Because it seems like something that would cut off current. Get rid of the 4409. That might be a lot number. BA151 datasheet. There you go. Battle music. Panasonic. That makes sense with those Panasonic logos on it. BA151, BA1514. Or BA151, 7 results. HBA151, blah, 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 blah. General purpose PNP, Expedaglaxel. Okay, planar transistor. What is this word doing? This word is fighting me. Expitaxial. Oh, did it cut off the text? Oh, come on. I wanted to zoom in just on that. I need a screen zoom. All right, anyway. Expitapable. Expatable. Expulatable. That is not what we have. Oh, it might be a little bit of an enigmatic part. Expitable. Expitable. Aluminum cap. Yeah, none of this stuff seems to be the right part. Data sheet. P1. Card number. Broken. God damn it. I don't want to download the data sheet. I just want to open it. Now, I don't know. It looks like it's going to be harder to find. Do you think 4409 is it? That's probably it. A4409. 30 volts VDS. Is it expedable? Expedable. Expedable. Demagogle. Negative 30 volts. Plus minus 20 volts. Continuous drain, 15 amps. I could have used these in the RC car circuit. They would have been a little large. 30 amps avalanche. Yeah, that would be fine. 5 amp RC car motor would be fine. Junction to ambient. That's pretty good, actually. I probably could have used these. These have about the same specs as the ones that I wanted to use. The ones I used are much smaller. So, I mean, if I really wanted to only use stuff that was on hand, I should have looked at this thing, because these are pretty good NPNs. Then again, running the NPNs as a low side driver, I would have still probably needed something in order to kick up the voltage in order to get them to pop off. This thing is probably a battery safety circuit or a microcontroller. I'm guessing it's a battery safety circuit. I'm guessing it's an ASIC. Otherwise, you know, this board would be really expensive. And it doesn't have programming headers on it. But yeah, there's a big resistor there to function as a current monitor, because you view the voltage drop across there. And then, oh, the magic search string. Yeah, thank you for giving me that, because when chat gives me answers, I like them to show their work, because part of what we do here is not just, we don't just get the solution, right? If you want that, go to YouTube. You want that, go to YouTube, everybody. And then I ordered parts and waited 6 months for them and worked on other videos while I worked on this video. No, we're fucking live. And part of the knowledge that I'd like to impart to you guys is knowing what to search in order to find this stuff. So sometimes chat gets a little triggered at my noodling around on the computer trying to look for a data sheet. They don't really like that. And so smarter people obviously will go and use their own search terms and then just link me to where I need to go. And so a thing that I've been doing lately is like, show your work. What did you search in order to get it? So Twisted knows that, and I forgot it. But his magic search term was 4409 MOSFET datasheet. So my assumption, my first assumption, and I think everybody probably agreed with me, is that these are MOSFETs, because they have a lot of pins that are doing the same thing. That's been a thing lately with higher powered MOSFETs, is putting them into DIP packages, or packages that have more than 3 pins in order to get all the current out. So this has 4 pins for the source, and then the drain has 3 pins, and then there's 1 trigger pin. So that distributes all the current for the whole thing. And so if we see that pattern with a multiple pin device, generally we kind of assume that it is a FET. So adding that top number, because BA151P is how the manufacturer tracks all of the parts that they're sending out into the world. And that way, if they have a defect, they can inform buyers, generally like, you know, distributor buyers, that they've got a bad batch and they need to send it back. So 4409 is the part number, which we did not know. And then whatever that looks like, a fly catcher or something, or like a bug catcher, like like a windsock. I guess that must be a Panasonic logo or something. Oh no, sorry, it's Alpha Omega Semiconductor. Of course it is. It's an A with a little bit of a circle around it. Kind of weird to see there, but 4409 is apparently the part number. So we found out this is a 30-volt FET, that's pretty beefy. That's actually a pretty damn good FET. I could have taken all 4 of these and put them to the RC car. That would have worked. I wonder if I could have used this board. It's a pretty small board for what it is. The part numbers generally break down, so you'd have like a... That's why I thought BA151P was part of the part number. It might not be a lot number because there's more information to these things. Sometimes they make different packages, and that'll give you parts of the part number. This isn't the type of data sheet that gives you all that information, does it? Maybe it does it up here? Nah. I don't know. They're calling it the L4409. Excellent words on and ultra-low gate charge. Device is suitable for use as a load switch or in PWM applications. So yeah, that could work for motors. That could work for motors. But yeah, 30-volt P-channel FET. Oh wait, it's P-channel, not N-channel. The N-channels were the ones that I wanted. Why would they only use P-channels on this thing? Weird. I guess they just wanted to cut off positive power to the... Because it's a battery safety device, so they just wanted to, like, fully cut P. Alright. Storing the balls. Yeah. I guess we should get started. I mean, what I wanted to do today is sort of off the cuff. It's actually pretty off the cuff. Let's get rid of the start soon, and then I'll explain myself. Explain yourself! Who goes there? Pay for your crimes! Oops, I just hit the wrong button. I meant to do the Oblivion thing, the Oblivion line, while actually just zoomed into my face, but I accidentally hit the wrong button because I was in the wrong folder of the Stream Deck. Anyway, help me. All right, so what are we doing today? I want to do basics with Arduinos because I'm waiting on parts. I've got several fires burning and several projects going at once, and they're all waiting on parts. I should have probably gotten my circuit boards. I think they come today. The circuit boards for the RC car come today. Parts for the bug assault are literally printing right now. Hopefully they don't screw up. There are some other like groups of parts that are coming in the mail, so I'm just waiting on stuff. That's all I'm doing. That's all I do these days is just wait. So once these parts get here, we can plow forward on a couple things. Seems like the bug assault is just literally going to be a little bit of 3D print assembly, and then that'll be done. So maybe we could do like a little bit of CAD with it if I need to angle that site. With the RC car, we can do a full assembly of the circuit boards. I'll probably use hot air, even though the parts that I'm using are so small that I think hot air is not going to be a good idea. These parts are 1.2 millimeter by 1.2 millimeter, and I tried to solder them previously with hot air, and it just blew them away. This is the part that's going to trigger the MOSFETs to run. You don't need to get one that's this small if you're doing a H-bridge motor project. You can look for a MOSFET that uses CMOS, but the fancy schmancy specialty ones that I bought need this driver in order to go to fully conduct, right? So, because remember, we found that the motor wasn't very powerful when we used it. So I need to use these tiny little things. They have 4 pins on them, and oh my god. So yeah, that'll be interesting to get onto a circuit board. I mean, why the RC car project? I don't know. It's just been kind of fun to do. I got a little distracted. It was supposed to be a Mario Kart thing, but it didn't really pan out. I took too long on it. Had to strike while the anvil's hot. These Mimi internet projects. Anyway, yeah. So I'm waiting on stuff. So we're gonna do some basics with the Arduino. I figure that it's a good time for us to just kind of kick it back, take a step back, and look at what this device is that I use for so many different projects. I mean, I literally. RC car project used an Arduino, but I put it in a weird 8-pin microcontroller, which made it really strange and hard to explain to people. So I figure getting back to basics and just doing something simple today would be really good. Now I'm not going to go total 101 level basics on you guys, because I think we're all a little bit smarter than that. And there's about 10,000 blogs that'll take you from step 0 to step 1-ish in like, well, plug it into USB and then connect this pin to this pin, do this and do that. I think those have been covered ad nauseum. Those are very easy to find and probably better explained by other people. We will be using, if I can find it, I don't know where it is, my Arduino Uno that I keep waiting in the wings. I got it somewhere around here. I don't know where it is. What I'd like to do is actually get to using some weird parts that I have. I have collections of strange parts that I kind of keep. I kind of curate them. Not really so much curate, it's just keep in a bin. But I've got, if I can find them, where did I put those? Uh-oh. I think they're like back, like deep in the storage over there. But if I can find those parts, we should play around with them a little bit. I want to do some 7-segment display stuff. We can bust out the 7400 series logic chips and get them hooked up and see what we can do. Bop, bop, bop. Let me catch up on don't sneeze. Yeah, right? Commodore 256. I got into soldering, made an FM radio kit that half works, and it was fun. Messed up a lot, soldered the wrong polarity and wrong electrolytic cap, but I double-checked before I powered it. Did some hackery to patch the contact legs. Hey, there you go. That's why you always stop, you know, before powering something up, stop, check it over, get the multimeter out, do a couple little continuity checks, make sure everything's good. Yeah. No backseating today. I'm going to not be reading chat a lot when I get into it. That's on me. That's on me, because everybody and their dog is going to be backseating, because we're dealing with basic programming and we're dealing with Arduinos and stuff. So this is up everyone's wheelhouse. So I need to just, like, part of today, and you guys should know this, is making mistakes. I will make mistakes, but I will correct those mistakes. That's worth showing. So chat is going to be very backseaty. I'm not going to be reading you guys as much today. I'm not going to be looking up at chat as much today. I need to do that for me. I can't control sort of the, what do you call it? The entropy of chat. That's just what's going to happen. And I'm hoping we get more viewers, because I've got just like a basic Arduino subject up there. twiztedsister, gifted a sub to LordSqueak. Let's put LordSqueak up on the board. Thank you for the gift sub. Thank you for the gift sub. Yeah, people are going to get so belligerent that they're going to start setting off farts in order to warn me about stuff that's going to go wrong. But just like Commodore 256's comment, you know, I made mistakes, but I found them and corrected them. That's working with electronics, and I'm super proud of that. That's a great comment, Commodore. I'm happy that you got that radio working, and it can be a big struggle, to the degree where you need to step away from it for a little while and then come back to it when it's fresh. And that's where a lot of projects die. A lot of projects die when you get to the point where you're finally testing it and something goes wrong, and you just, all of your motivation just dies in that moment. But you should know that if you persist and allow it to be fresh again, hopefully you're not under a deadline, if you allow it to be fresh again, then it'll pay dividends. You'll learn a lot about what your own personal hang-ups are in terms of getting stuff together, and in terms of like what you need to look for in terms of mistakes. LordSqueak, welcome to the board. We got Commodore 256 being gifted a sub by twiztedsister. He's just firing them off one after the other. This should be illegal. We'll see if we bop anybody with a laser. Who's he gonna kill on his way home? twiztedsister's out for blood. He's out for blood. Where's the dot gonna go? The API takes a long time to catch up, but once it does, we're gonna get a little bop. Bah! Who dat? What did it hit? I didn't even see. That's the end of the Y over there. I'm terrible at this kind of stuff. I don't know where it is. You guys probably saw it directly. Didn't step away, did in an afternoon. Hey, there you go. You should put that info into the stream title. Yeah, I probably should. I could put those weird little like ASCII characters and tags and stuff. No backseating, first time playthrough. Nah, it's okay. It's all right. It is what it is. I can't avoid it. People just gonna be doing what they do. Programmers and the like. They're just like that. Filth. It's tough to watch somebody do something that you know about and make mistakes that you clearly see. Because you're like, I want to help. Oh my God, Twisted Sister, you're going to keep me from sitting down today, aren't you? Dreamwastaken, getting a gift sub by Twisted Sister. Thank you so much. Commodore 256 going up on the board right now. Right near Balls in Your Mom. Oh, great, what a name. Did I mention that you can gift subs and the giftee will go up on the board? Keezer6 also getting a gift sub from Twisted Sister. We're just going back and forth today. We're doing shuttle runs with the board. The board is doing shuttle runs. Bop! Oh my God. You almost killed Ninja. Actually, who's in this area? Wasn't it Dr. D? Yeah, Dr. D is up there. Who's now on YouTube, so I don't know if I'll get my channel banned for even fucking mentioning the guy. Isn't that, like, really weird? You're not even allowed to mention banned streamers. I hope they've walked that policy back a little bit, because that's a little draconian, isn't it? That's a little bit draconian. But I guess they want to give a wide berth to whatever slander laws exist. Just give it a wide berth. There's one of those streamers that I think like Adam Plays like wanted to play Fall Guys with, and he had to just like end his stream in order to do it. Couldn't even mention who. Crazy town. I'm under contractual agreements though. Ba-da-bop-bop-bop-bop. I'm in a unique situation where I don't know how many of these names have been banned post board. It certainly would be useful for some Twitch staff to come in and just read the board and be like, wait, we allowed that name on the platform? What the hell? Dreamwastaken. Welcome to the board. You're by Pilot Budisha, Pilot Boudica. Oh God, I forget how to say it now. There's so many different versions in my brain. Yeah, the Lone Star's over there. As well as Asshole Casserole. There's a Robots too. Wayne Johnson gifting a sub to Yodadog. I think Keysor6 is going up right now. Looks like we're headed to the name. Yodadog. It's going up in just a sec. You're the man now, dog. Walking, we're walking, we're walking. Kezor6, or Keysor6, or Keysor6, or Kzor6. Hereby, Mr. Don't Care. And Barch Bread Crisp Sandwich? Batch Bread Crisp Sandwich. What? Yeah, the names are pretty small. You don't have a lot of characters in your name either. Welcome to the board. Names will get pretty big when we flip boards. Unless I want to have a board that has all small names. Oops, all small names. The new bother board. Ah! I gotta fix the freaking camera. Hold on. Let's twist her around a little bit here. The handle is getting in the way. It goes like this. Oh, I gotta lock it down so we can film the name. There we go. Yodadog! Welcome to the board. I recently got some stepper motors working with my Arduino. Spent a whole day before figuring out it had an enable pin. Oh my God. What? The shrimp substitute ban on Twitch. Every time I've heard it used in negative context, instead of being a shrimp in the streets, not in the... What? I don't know any of that. I'm not looking at that. An ancient Fadanon. All right. So, I need parts. And we need a perforated prototyping board. So for anybody that doesn't know what perforated prototyping board is, what are you doing here? Perforated prototyping board is a plastic board with a bunch of little holes in it that are spaced with the centers being 0.1 inch apart. And that 0.1 inch is important because it's a standardization that was invented 1 billion years ago when America invented electronics. And we decided that English standard would be it. Actually, none of that's true. But yeah, the de facto standard is 0.1 inch, which in a world of meters, even in science and technology, we do meters. It's annoying, but that's what it is. If you start out in electronics, you're going to start with stuff that's larger and older and easier to handle and easier to work with. You're not instantly going to go down to metric standard surface mount tiny little parts, right? So what we have is a legacy of like 100 and some odd years of inch standard parts. So that's what breadboard helps you work with. Now, this is typically called, I'm just calling it breadboard, but it's also solderless breadboard is kind of an important nomenclature of what this stuff is. Solderless is really the key word. You're working with electronics, you want to create an electrical connection between things. You've probably messed around with repairing wires and soldering a wire to another wire. That soldering is really good for creating an electrical connection. But when you are working with a circuit and you're trying to vet it out and you're still making newbie mistakes, which everybody will do, you make all these mistakes trying to actually get your idea out onto the board and get it working, then having no solder there and being able to quickly reconfigure things in order to try stuff out is super important, and it'll keep you engaged in the project instead of just engaged in numbers and calculations. It's a really important facet of the typical design process with projects. And also, if you need to do something like once or twice, you don't have to commit to a full fucking device for this thing, right? You can just plug stuff in and you go, ah, well, I'm done with that. Now I can get rid of all the stuff, which is where this one comes in. We're gonna get all this stuff out of here, and we'll make this our test bed for the day, because there's a lot of room to work on that. These are cheap. These are a little cheap. Basically what exists inside the perforated prototyping board, actually this isn't perforated prototyping, this is a solderless breadboard. What exists inside the solderless breadboard are rows of 5 pins. Now you've got rows of 5 pins going, we'll call this vertically, but you also have rows of 5 pins going horizontally as well. So the rows of pins here are actually one solid clip. Keys are, hit refresh, man, that's you. Jesus, one guy. All right, so what exists inside of these things are, I'll peel up a little corner. I put gaffer's tape on the back of this because it did have an adhesive backing, and I didn't have anything to adhesive it to. So, trying to peel up this corner. So what exists inside of these are just rows of little metal clips. They're very cheap. They can only handle about 1 amp of current, although I've pushed it further than that many different times. But these are just little clips that run the length of 5 pins. So they manufacture about 600 gazillion of these things, and then they put them into the plastic. The other thing, Crescent Moon Deaf. Thank you for following. So the other thing that they do with these is have horizontal tracks, and these horizontal tracks will connect the whole length of the horizontal track. So you can see they're still split up into 5s, which is baffling to me. I do not know why. Crashing Rivers, hey, thank you for following. I don't know why they split these stupid things up into 5s. It's really annoying, because generally when I'm trying to like line stuff up, it'll, you know, hold on. Yeah, I gotta remember a name. Yeah, it'll mess stuff up because like I'll want to plug something in these two. filter in the app crash. See, one guy. Oh yeah, those are the circuits for the motor test. Ugh. That was grueling. That was grueling stuff. You guys don't have to worry about that today. But yeah, these run the whole length, and they allow you to run power and ground to everything. So you can organize stuff a little better. Now, we have run into problems where if we have like a noisy circuit and it's spread out amongst us the entire board, it'll create interference just for the length of the length that the current has to run can get kind of messed up by all the switching stuff on the way, right? He can't hear you, so we type things for him. We're gonna have interpreter chat. Bother's saying something that is wrong right now. Okay, so anyway, I'm gonna get these tiny RC car parts out of the way. The tiny RC cars are super duper duper cool, but we'll move everything out of the way. Whoa, whoa, whoa! Wait, no, let them. Oh. That was fine, Fat. What was that? Well, Fat didn't like it, so it's not allowed. Okay, so I'm going to move these little tiny parts out of the way. We're going to get all the junk off of the board. And then we'll pull out the Arduino, and we'll see what we can get going here. I've got LEDs. I've got all kinds of different stuff that we can play with. Hello World is a little bit beneath us, right? The highlight didn't clear? I mean, I don't know what you guys mean. So let's just move everything off to the side here. Oh, that line broke on the radio, huh? This is not the best way to attach a radio to the breadboard. By the way, like, hello universe. We'll go hello TV station and hack into an ISDN line. Hello radio. When you're not perfboarding, when you're breadboarding stuff, it's like, you know, any port in a storm, right? If I need to hook up something non sequitur to the pins, you can just solder stuff together. I keep wire wrap wire around. Wire wrap wire is a very, oh, Jesus Christmas. Oh, look at that. It's a mosquito hunter. The fuck is it doing here? That thing scared the shit out of me. Hold on. I've got just the tool for this. Where did it go? How did it even get in here? What the fuck? That's oh, that made the hair on the back of my neck stand up. Yeah, they don't actually eat mosquitoes. I heard that before. Why is there one in here though? I don't have bugs. That's the first bug we've seen in like a year. I don't know where it went. I don't know where it went. Nuke it for more of it. It's the only way to be sure. Game over, man. I don't know. I have a fan on me. Usually that prevents that kind of stuff. That's a mosquito. No, it's way too big. That is not a mosquito. That... Alright, well, I'm creeped out. That thing's just going to be waiting around. Probably going to lay eggs in my belly or some shit. I'm going to keep my piece close. Keep my piece close to me. I'm not even done building this thing yet. And that was a giant bug. Jeez, probably all the rain. I'm jealous of your meal. Yeah, man. The mill actually came about because of, what? They long legs are experts in finding openings, but suck at finding a way out again. Yeah, I know. Yeah, so the mill came about because of what was called the Reddit Millionaire Makers Contest, which was basically a shower thoughts thread where the guy went, hey guys, it would be really cool if we all just like donated $1 to somebody and then they'd be a millionaire. And so they decided, Redditors in their infinite wisdom, that they would open a thread that was completely open and people just entered into the contest, and then at their own discretion, they would donate money to that one person that was chosen. So they used like blockchain to make randomness super duper, and they had like a live stream where they'd choose the person. And all you had to do was comment in the thread. So, here it's starting. Basically, all you had to do was comment in the thread. And so I commented in the thread, and then I was about to go to bed. It was one of those nights where I was awake till like 4 a.m. And I checked the thread, and they said, hey, you won. And I'm like, what? So I just set up all these other accounts and stuff. That's where Workverb Design came from, my business email. Then use the Bitcoins to buy a mill. Dude, I had almost 1 Bitcoin out of donations from that. I now have almost 0.1 Bitcoin because there was a leak of Reddit accounts. And so I didn't realize that they had done 2-factor authentication, and I didn't enable it. So India, some people in India hacked into my account and siphoned off all the Bitcoin, and there's nothing I can do about that. It sucks. Yeah, so I have 0.9. I could have had, like, what, $45,000 just, like, sitting? I hate talking about that because there's nothing I can do about it. There's literally absolutely nothing I can do about that. And it was, so annoying. That was free. Anyway, with the Reddit Millionaire Makers contest in just cash, people donating $5 at a time, I wasn't a cute girl, so I got about $1,500 in cash from random people on the internet, which is pretty crazy. So that $1,500 of random cash, I was like, well, I could, you know, like I could pay bills. Like it would pay for maybe, like, at the time I was on Cobra health insurance, and I was like, I could pay like 2 months, and then I'd have $200 left over of my Cobra health insurance. It's like, that sucks, you know? Like, you could pay rent with it, but like, yeah, remember that one time Reddit paid for your rent? That's dumb. So what I decided to do was actually get a physical object, and that mill was a drill press, and it still is. That actually is a drill press, but it's a drill press with a pretty nice decent XY table on it, right? And you know, maybe someday I can do a little CNC magic with that thing. But trying to lip read, but your top lip is, why is everybody having audio problems? This is not my fault. There's plenty of audio coming out right now. We'll just do this from now on. From now on, this is the only view that you get of my stream. There we go. All right, so anyway, yeah, so I spent the $1,500 on a mill. And so that mill has actually been the star of the show for a couple streams. And it just continues to be a very useful thing in the shop. I don't know if I would suggest everybody go out and buy the Sieg X3, because I don't know how good of a mill it really is, but it fit my price point. That's the thing about it. It fit my price point, and it fit the usage that I would have for it in the shop, right? Because I don't do like insane milling, and it's not like I'm doing like professional super duper stuff. I tried to build dice on it. I made some pretty cool dice with it. Like you know, like here, check out this D20. This D20 almost has 20 sides. I think if I worked a little harder, I would actually get 20 sides out of this thing. Yeah, it's like a toddler's drawing of a D20. Actually, this is the D20 attempt. This is my first D20 attempt after figuring out how I would do it. And there's a lot of errors in it. There's a lot of errors, a couple apprentice marks on the different faces, but it's almost there. If I had worked a little harder on that, I probably could have done machined D20, and I was coming up with a method for using round stock in order to machine out the D20, and you'd probably have to do the last steps either by hand or with a jig. Anyway, that was before I started streaming. But yeah, so that mill came about because of a random happenstance. I happened to win a weird ass internet thing, and got a lot of. That's where all of my my Doge comes from too. I don't know how much Doge I have, but I know it's worth quite a bit right now. Let's see. I'm gonna move some of this stuff over to just like a holding place. I want a clean breadboard for this stream. But I don't want to lose sight of all these parts that I have going here. Because like here's a diode. This is a surface mount diode that I put onto a pin header. So yeah, with the perforated prototyping board. God, I keep calling it that. I keep calling it the wrong thing. With the solderless breadboard, there is a gap in the middle of it, and it's accumulating filth because this board has been being used for a long time. This is actually a gift from chat, this board. But there's a trough in the center of this thing, and this is a This is a holdover from the 70s, maybe even 60s, of a through-hole integrated circuit has a particular spacing between the through-hole pins. This is an adapter board that takes a through-hole spacing and puts it to a surface mount chip. So I use these a lot when I'm perforated, when I'm breadboarding. I'm gonna put that electric dog collar on, and every time I say the wrong term, I'm just gonna give myself a mild electric shock. Yeah, this is for a cooling, water cooling. Who makes this board? It's I covered it over. Hold on, let me get stuff out of the way. I can answer that question. Yeah, this one is huge. This one was bought by chat for me. So I don't know. Oh no, I used VHV, I used VKB or VHB tape on it. Ow. I don't remember. Maybe if Dewey was around, he'd know, but I think he's dealing with hurricane stuff right now. Fucking hell. Okay, yeah, so this right here is it's a chip locker and unlocker. You guys don't need to worry about that, but I did cover up whoever makes this board. Excuse me. You can probably look up perforated prototyping boards and find the larger ones. I don't know what chat spent on it. I don't know what utility it has. I mean, I like having the larger board. It helps me, do projects like this where you can spread out your circuits, and that's an important thing too, especially when you're starting out, is to spread out. It's something that an art teacher of mine would always try to tell us to do. It's like, use more space, make your art larger. It gives you more room to work. You can get all that detail in there without blowing your eyes up. You can actually friggin', do stuff if you expand beyond your comfort level in terms of the size of the medium that you're using. And so the perforated the solderless breadboard, if you get a larger one, it'll help you do that. I don't know. I mean, like, if I were just to look up one, we could just do this. Amazon. Jeff Bezos. I want a perforated no! Electric shock. I want a solderless breadboard. Solderless breadboard. Huge. Well, that made them smaller. Huge is not the right term. But, I mean, you scroll down and you can pretty much just find it. Here's one that's branded for Makotronics, as if they're the ones manufacturing it. It is literally the exact same board that I've got sitting in front of me. This is a whopping $36. So $40, but it is an investment into your ability to prototype things. This is a good investment, I would say, because you can spread out and you can have power tabs for your things. If you're looking to develop something larger, or even, I would say, like, if you're getting into like audio stuff and you need like a lot of different breadboard space, if you're going to stick to digital things and you're just trying to use like a couple little components and vet them out and see whether or not you can build a circuit board around them, you may not need a perforated another electric shock. You may not need a breadboard that's this big. This is probably above and beyond the people who are trying to do one project. But if you see yourself doing like several things, or if you're adding a lot of modules to a microcontroller, then maybe this is the way to go. A lot of digital stuff you can put onto this and have a lot of fun with it. Yeah. Anyway, DigiKey has one for $89. Listen, $36.90, just Jesus Christ. DigiKey suffers from industrial pricing. They have started carrying stuff from like SparkFun. SparkFun's a little bit more expensive, but it's a lot easier to find the stuff you're looking for because they vetted out a lot of the parts. DigiKey is just a smorgasbord of things, and some of them are still kind of affected by the pricing of things that existed 30 years ago. So... $89 for a perforated prototyping board. No. Yeah, Amazon, $40. That'll do you just fine. And those pins will carry about an amp. before they start heating up. So for most intents and purposes, this will probably be a pretty good perforated prototyping. Solderless breadboard. There are other brands though. Don't get locked into a brand on that. Yeah, you can buy them directly from Adafruit or SparkFun as well, but I think they're going to charge a little bit of a surplus, a little bit of a surcharge, whereas this is being like pennies on the dollar. So if you feel like supporting an operation like SparkFun and Adafruit, which is an honorable thing to do, you can go directly through them. That's $20. Oh, but it's smaller. This is smaller. It still does have 3 rows and 2 verticals. It's a little bit smaller though. Oh no, they've got a lot of verticals on this. Wait a minute, 3 rows and all the verticals, and then they've got a long horizontal. Is that smaller? Am I crazy? Is chat crazy? What's going on here? Yeah, maybe they just don't have 2 rows on the top. Is that really worth $16? Oh, this one has 4, right? Okay, 4 rows. Okay, 4 versus 3, $20, $40. Okay, you get that extra top row. Yeah, whatever you feel like doing, right? Right. So anyway. So I'm just going to move all of these modules over to here just to store them for now, because we don't need to worry about those. We don't need to worry about all this. This is a H-Bridge advanced H-Bridge motor controller testing. Cool stuff going on over here. This is a fun project. I'm waiting for circuit boards. Circuit boards get here tomorrow. Actually, today maybe? Might be able to take a look. I got matte black circuit boards, which were much more expensive than the normal ones. So much more expensive. Oh, God. But, yeah, they should be pretty cool. So anyway, this is going to be our canvas for today. This is going to be our canvas for today, and then what we'll do is I'm going to go find a cool component. Now, I would like to say just whatever I can find, but I have something in mind that I would very much like to use. So I'm going to find that cool component, and we'll get it running off of an Arduino. And this is just like basic, you know, how do I do stuff with this technology kind of stuff. For somebody who knows a little bit more than 101, right? I go a little bit higher than 101 level. But I will explain things in you know, plain language, and hopefully y'all can follow along as I go. All right, so now is the part where I get to go find that component. Now, what I'm looking for is a 7-segment display, but I put them into like a bin of components. They're from like a million zillion years ago. Thank you for the follow. Chomlin, and I am JL, and Hugh fucking knew it. And Crashing Rivers. Yeah, so, all right, so what we're going to do is I'm going to try to find a 7-segment display. I've got a couple of them, and I've got a couple different flavors of them, and they are from, like, the early 70s. They're very cool-looking ones, maybe 70s to 80s vintage. Back when display technology wasn't as vetted as it is now, or as cheap as it is now. There's some cool stuff out there if you really look around for cool components. I typically would get on eBay every now and then, but actually these came to me by stealing them from a shop that had closed down at University of Pennsylvania. So it was an old electronics lab that was working on non-invasive brain monitoring probes. But I guess somewhere along the way, the engineers were like, we need to display numbers, which I don't really know why that device needed to display numbers, because I think it started out with a bunch of number displays on it, but then it went to computer data acquisition later on. So, but anyway, they found their way into my shop, so I need to find them first, and then I'll show them to you guys, and we can try to get them running. I think with 7400 series logic, which is in. Uh-oh. Where did all my 7400s go? I think they're in that bin. So, okay, I gotta go across the shop. Give me 1 sec. I gotta go across the shop. Find these displays. I think I crammed them all the way back here. Did I just I think I just punched that fly. Just in walking, it just brushed up against my hand. That's gonna be like, oh god. From now on, every single thing that I feel, every errant hair twitch is going to make me think that this bug is about to kill me. Even though it's a completely harmless bug. It's totally harmless. It's just like a... just kind of a big bug to get in here. I've never seen one that big get in here. All right, let me see here. I think they're in here. Let's take a look in here. Come on. I've got power cables around the bin, and then I've got the 3D printer right next to my face. My ears are filling up with water. What's going on there? All right, get this thing out. Ugh. Got it. You ever do that where you bend over and then your ears fill up? I don't know what that's all about. That's the exact brand. Yeah, you don't have to buy the exact brand. Don't get that brand loyalty stuff. It's just a generic product. All right, laser diodes. This might not be where the displays are, huh? These are just like random old laser diodes. Okay, so maybe that's not where all the stuff is. Nope. Wrong bin. All right, wrong bin. Some of these parts are going to go towards the new Burn the Subs eventually. At least the emergency stop. But, okay, not that one. Damn it. All right, where else would they have gone? Let me think about this for a second. It could be in the project bins, the miscellaneous project bins, these little things that I've got sitting around. These, like, sewing kit bins that I use in order to store all the stuff that I have sitting around here. They could be in there. They could be sitting out on this table. I don't think they're up. I don't think they're up here, are they? And there is a lot of miscellaneous stuff up here, and I've actually cleaned it out before, which is probably where that bin ended up, because I think it used to be up here, and then I cleaned off the top deck. What is, oh, I was scooping salt with that. Why is it even there? Then I cleaned off the top deck by shoving it all into a bin, and I think that's probably where those parts are. This is the problem with having like eons of part storage. It's like generations upon generations of part storage. And so what I'm doing is looking for something that I know exists in this space, but I don't know where. But it'll make this so much more interesting of a stream if we're doing old parts rather than just like, you know, whatever. You guys know what I'm talking about. You know what I'm about. They're not there, are they? It's all headlight stuff. We still need to get back to that headlight project. Computers, Burn the Subs 3. I've got all these like cardboard trays of stuff. That's the best way to describe it. Cardboard trays of stuff that I've sort of pseudo-organized my lab with. Raspberry Pi stuff with displays. A couple of modules down here, including a stepper motor driver. Uh-oh, hacksaw fell. There's the Arduino that I was looking for. I could just act like I meant to do this. Ah, Jesus Christ! All right, a couple things fell. Burn the Subs is still on. Yep, okay. my hacksaw has taken to ruining my day. All right, there we go. My hand drill fell down off of the wall and put it in there properly. All right, Arduino, but at what cost? So Arduino Uno, that's what we're going to use today. And then I need to find those LEDs. I don't know where they went. Probably put that back, but they might be back here. Show you guys where I'm looking. Sounds like you meant to do that. No, that was not. I don't fashion myself as somebody who drops their drill on the ground constantly. Thank you very much. All right, try to find those displays, what I did with them. And I've got some vintage displays over here. I don't know if they're in here though. This is mostly like Nixie tube stuff. So we'll look through there to see if we can find it. Yeah, it's one of my favorite little exercises, going on eBay and finding some old stuff and then trying to get it working. I haven't been able to do it in a long time because we've been streaming. All right, let's see. Yeah, there is. It's an IBM Selectrix ball. I had nowhere else to put that, so I put that there. They're the 7400 series chips. I know where those are now. Let me think about this. If they ended up where they should go, I can just get down here. Hopefully I'm not too far on the way. This is an experimental camera shot. I can't vouch for this one. Oh boy, there's a lot of, apparently I threw stuff to the side over here. Try to get it out of the way. Let's see if I can't find little tiny displays. All kinds of stuff that I've ordered. Vacuum tubes, I need to make sure those are safe. Let's put them in the bins and then they'll be safe. I'm trying not to crush the microphone too while I'm doing this because you guys will get bad audio out of it. Got circuit boards over here. What are these doing here? All right. I'm uncovering a lot of detritus. Oh, that's where that went. That's that infrared laser. Get these. Oh, those need to go in the bins. All right. I guess I got to clean up this area a little bit more. Let's see if I can find all those vintage numerical displays. I don't know if they're in these. I think they're in their own little like special bin, and I think it ended up. It might be outside of the shop. I might have to duck out to try to find them because they're really cool. Like I've got some pretty cool little displays that I would love to show off to you guys, and I have in the past. But I'd love to get one actually like counting numbers today. I think that would be a cool display of kind of what you can do with an Arduino. Like display numbers or, I don't know, display numbers, I guess. I guess that's it. I want to put those vacuum tubes away so I don't break them. Those are important. Those are spare tubes for stuff. My audio amp. This is what happens when you guys hear me rifling around through all the bins and like crashing noises and stuff. It's me just like picking these up, taking a peek, and then putting them back down again. Just to see if what I'm looking for is in a particular bin. It is a restrictive area. I don't have a lot of space in this corner. It's an unfortunate result of not having a lot of shop space. Although I'm sure everyone can relate to that. It's like makers are like goldfish. They'll expand to the size of the arena. Those are some old microcontrollers. There's a parallax microcontroller in there. Let's see. Before my legs fall asleep here, just make sure that what I'm looking for is not here. And I don't think it is. Doesn't look like it is. Put those bins in backwards or something. Nope, there's something down there. What is down there? Yeah. Oh, yeah, these are something that was sent in a million years ago. All right, so anyway, those aren't there. Where else could they be? Segment displays, I mean, I would put them in LED stuff, but I don't think they're in with my LED stuff. They are not. These are just raw LEDs. So yeah, I need to find what I did with this little container that has a couple of these things in it. And I think it's in a different part of the shop. Whoa! I'll just quickly do a squat on stream. It's a restricted area, yeah. Restrictive area. I played bass for them in high school. Marching band. Let's see. Wires, other wires, more wires, additional little circuit board adapters that would allow me to put wires against wires. Put that away. I think a lot of our time today is me just rifling through stuff. Is it gonna be in there? No, it's not. These are from like 2 shops ago, 2 redesigns of the shop ago. So these are gonna be very much, they're gonna be in that like disintegrating foam that you press electronics into. Nope, not behind this. Oh boy. Remember this stuff? I don't. A memory of a goldfish. All right, I need to pop into the other room to see where these things are. Because what I think, my theory here is that they're in the other room. Where would they be in the other room? Let me search my memory quickly to see. Because they're in a little bin, and that little bin was shoveled into another bin. So what I'm going to do, I'm going to put the FTL music back up. I'll put a BRB, and I'll try to find this stuff. We'll go back a little bit in the soundtrack there. Too actiony. Hold on. All right, I'll do a BRB, and then I'll actually BRB. Overlays, BRB. I didn't do my homework. I didn't get everything together for the stream. Hold on. I'll be right back. Success. They're in the bins that time forgot. These are the bins that I forget about sometimes. There's like a pillar of bins that sits by the mini fridge in here, and I forget that they're not a table surface. They're actually bins of parts. So I did find everything that I was looking for. Gone with the BRB. Down with the music. Pause that. Need to find more games that have inspirational music to me. Like FTL and Deadly Premonition is like the limit. All right, so this is one of these miscellaneous bins of stuff that exists within my shop. You know, it's just various crap that's accumulated throughout the years, and there's nowhere to put it, and I need to go through it one day and figure out what is crap and what isn't. Like, this Xbox controller is not really crap. Same with the Steam controller. not really crap. It's actually, the Steam controller is actually a really nice controller, to be honest. Everybody was a little disappointed in it at first, but the support for it has grown 7-fold. I don't know. I like it. I just never got around to using it. I found the DualShock, whatever the, not the most recent, but the one before that, the previous DualShock was probably the best. I was super happy with that. You're saying they might make a new Steam controller? What, to like complement their release of the Steam Deck? Steam Deck's gonna be pretty cool. I'm gonna be honest about that. Oh, this is the Turbo Touch 360. I don't know why back in the 80s when I was a 10-year-old, back in the back in the 90s when I was a 10-year-old, all these parents were perfectly fine getting their kids something called Turbo Touch. That's a little weird. But anyway, the Turbo Touch was always the controller that your buddy gave you that had soda spilled on it like 5 days ago, and everything was just a little bit shticky. They stopped selling the controllers because they were getting sued due to the back buttons. These? There shouldn't have been buttons on this controller in the first fucking place. This controller was a travesty of compromises. I'm really pissed off about it too. It wasn't supposed to have buttons. It was supposed to, I mean, you know, buttons are great because you can actually feel where they are and press buttons. Let's not get it twisted. I'm a big fan of physical buttons because they've been getting rid of them in cars, and I think that's super dangerous. But for this thing, it wasn't supposed to have buttons. It was supposed to be super touch, you know? Not the actual back button? Oh, because of these? How do you get sued because you put buttons in the back? Is that like, were they directly reminiscent of a design that had the battery door as part of the turbo back buttons, or turbo touching the controller? We took this apart in previous streams, and that's actually something that I want to get back to. We may take apart this stuff again, because I mean, I've got almost a complete, like statistically, I've got almost a new audience. And so I think we can take apart some of these controllers and like get into them a little bit. But what we did previously was we took apart this controller and we took the touchpad, and it's from a company called Cirque, not Cirque du Soleil. It's just like Cirque or something like that. I don't know where they're from, but anyway, this touchpad, this high density capacitive touchpad, had pins on the back that we could solder wires to, and we hooked up an Arduino. We got code on their website for the touch controller, and we were able to run an Arduino with, I don't know, whatever, I think it was like a processing sketch or something, and we could see where the touches were. It was really cool. Really worked out nicely. It was very great. But yeah, I wish they had done, you know, no buttons on this thing, especially not with this stupid little bastard right here. I hate these things. These analog sticks, they're very, ugh. But anyway, the Turbo Touch 360 was an interesting one too, because this actually had logic chips in it. This is from like the 90s, right? So in the 90s, I mean, they had surface mount technology and stuff like that, but for cheaper things like kids' toys, they were using and I keep mentioning 7400 series logic. 7400 series chips are notorious. They are famous in the electronics world because they are logic chips. And so if you want to have logical operations happening in your device, well, microcontrollers didn't exist. What you had were OR gates, NOR gates, NOT gates, XOR gates, XNORs, and ZORs, and double ORs, and quad NAND override, double XOR, and Xerxes. Half of those terms were wrong. Anyway, so these logic chips allowed you to do smart things with the controller. Now with the Nintendo, your inputs are what's called a shift register. And so each of the buttons, A, B, start, select, this is Super Nintendo, wasn't it? Y, X, B, A, up, down, right, left, those are all basically pulled at one particular point in time. You change the logic level on a pin, everything locks in. It knows what buttons are hit at that moment. Then you send a clock pulse in another pin, and out a third pin comes the state of all of these pins. So these exist as a binary number that is serially sent back over to whatever is polling it, right? The thing is, that binary number is pretty much agnostic of the fact that you might press 2 of these at the same time. And if you've got a turbo toucher, you should call the cops. But if you've got a turbo touch 360, if you've got this many turbo touches, and maybe that's what happened to all of the other 300 and what was it? Was it 381? What was that one from before? Hold on, I'm scrolling through. Crescent Moon, Twisted Keysor, dreamwastaken. Not Commodore. Damn, who was that? Anyway, somebody was 361, and I was gonna make that joke, but I'm too dumb. Anyway, so with this had a flat pad that had 4 capacitive sensors on it. So those are the sensors, the capacitive sensors. Or no, was that? I don't know, somewhere around here. No, these are the switches and those are the buttons. There's another pad on this that's somewhere in this bin. It's basically a touch sensitive pad. And so as a kid, I mean, you could potentially hit up and down at the same time. Now you could force a Nintendo controller or a Super Nintendo controller to do that too. You'd probably be hurting it a little bit doing that. But that is like, I think speedrunners use that strat of hitting up and down for like a tool assisted, because it does weird stuff to the console, because you're not supposed to have those up and down pressed at the same time. It's not supposed to be possible. In this, it's very possible. So what they did is they used logic chips to say, if this is pressed, this one cannot press. Or if this one's pressed, this one cannot press, and vice versa. It makes it so that you can have the diagonal directions pressed, but you cannot have up and down at the same time. And that's done with basic gate technology. So if you've got a 1 coming from one location and a 1 comes from the opposite location, it's interpreted as like nothing, or it'll cancel it, or it'll do something weird. But what we're getting to in this bin is the EL wire. EL wire works by, no, I'm not gonna go into that right now. This is EL wire that I never got to use. I was gonna sew it into a fur coat. No, what we're gonna get into are some of the derelict parts that I seem to have sitting at the bottom of this bin. Like a fully gyroscopic camera rig. No, we're not gonna get, no. I got this this electronics conductive foam. This stuff lasts about 10 years and then it starts turning into dust. It's not good stuff to have around. Generally, I don't like using it. They love to put that into they love to put your chips into that so that you don't harm them, but... Oh, this is from that camera. Man, I got a lot of memories in this bin. And a Wiimote. Here's another fun thing that we might be able to play with today. We'll see. But this is a milliamp meter, and it's old school. This is like Russian helicopter level milliamp meter. I don't know where I got it from or what the vintage of it is, but it's a pretty nice one. I've never really had a good project to put this into. It'd be kind of cool to, I don't know, putting that on the front of the computer that I built would be neat. But that's going to get Nixie tubes, so... Nuclear, you're saying it wrong. Okay, so let's put that aside just as an aside. Glow-in-the-dark powder and a stepper motor driver for the 3D printer, what I've replaced. I don't know why I keep that. All right, controllers, go back to your place. There's a bug in here. How did you get in here? Nope, seal your fate. Looks like a cave bug. Why are there so many bugs lately? What's going on? Maybe it's because I got the bug assault, like I'm starting to identify targets more. Like, yeah, that's a violator. No, it's too small. It was too small to hit with a bug assault. Too small and not worth the cleanup, right? These are all Nixie tubes and stuff, and I happen to know that what we're looking for is not in here because I just found what we're looking for. One day we'll get to the electroluminescent segment displays that I can build into something. I need to get back to that. Bugs got in during the party. Might as well have, I don't know, I had like a giant, what's called a mosquito hunter in here. It was like a big bug. It was not a small bug. These are, oh, Magic Eye displays. I want to actually get to these someday too. These are Magic Eye displays. I just discovered them and I ordered them and now they're sitting in this bin along with all of the other broken promises that I have. Lost Algorithm, 3 years, 36 months. The little one turns 3 today. Thanks for all the content. Hey man, I appreciate you sticking with me for 3 years. That's ridiculous, man. I don't know, maybe you should move on. Thank you so much, man. I really appreciate that. I don't really consider what I do content. Let's be honest. All right, let me turn the board back on. It's like the machinations of a weirdo working on his own projects for his own benefit has been my stream for like 90% of the time. Going all the way over here, LostAlgorithm. By the way, that print from before is starting to really take shape. Actually, it looks like a rail. Can't see it. Oh, no, hold on. Back to LostAlgorithm. Sorry, getting distracted. Light-themed IDEs attract bugs. Listen here, you little shit. I have a lot of lights in my eyes. I need the light-themed IDE. LostAlgorithm. Okay, ignore the freaking out camera. That's just the way the camera is. It does that. It's not broken, but it's near enough as makes no difference. Stop it. I have to like subtly move it so that it doesn't. Yeah, the 3D printer is working on that. I don't know if that's in focus. I can't get the camera closer. The cable's caught on something. And it's hard to show. All right, whatever. Well, it'll be done soon, and then I'll be able to actually show you guys the thing. All right, anyway, back to this, back to this, back to this, back to this. Back to this. Thanks, Avalanche. Hey, Seagull Rush. All right, wrong view. We'll just go to this one. So, we can put the vintage displays away because these require like 60 volts to run. So we're not really gonna mess with those at the moment. 60 volts is a little bit more of a little bit more advanced. Would it be possible to use tiny mirrors on actuators to create high definition 3D images using a single laser/light source? Anything is possible. The amount of cost and technology is what's really going to get into it. Nick SHW, thank you for the follow. So what is it precisely, this question? Tiny mirrors on actuators to create high definition 3D images using a single laser/light source. Yeah, I mean the 3D displays with lasers are kind of a thing of a little bit sci-fi, although they do exist. You have to have a cloud chamber in order to have it run properly. It's the intersection of two infrared lasers creating, I don't know, maybe heat in order to create plasma to trace out an image. So getting into high definition three-dimensional stuff, I don't know if they can do color yet. Maybe in some research labs they figured it out. Doing high definition means you're going to move a lot of lasers very quickly. It's possible. I don't know if anybody's done it. It's certainly something that can be done. It's just a matter of refining the technology that already exists. What the hell are these? Memory maps? I don't think we need a memory map. What the hell? What does that even do? Ah, it's back! Huh. Die! Oh no, the safety went on. Oh, I completely missed and I got salt everywhere. Ah! Missed again! Damn it! Stop it. Stop fluttering. It's behind them. It's behind the oscilloscope. I probably could have just swatted it. This doesn't work very well because it's loose. Damn it. Okay, I'm gonna put the safety on and leave this thing locked and loaded. And then I'm gonna brush all the salt off that I just got all over everything. This fucking bug. So I need a scope. I had a friend of mine showed me that he bought one recently, and what he did is he moved to a place in Westchester that was near a brook, and they had too many flies around. So he went outside, which is where this thing probably should be used the most, is outside. He went outside and he just went around just sniping all the flies with it. When you do programming, this is Peter Nerlich, by the way, there's a new software and game development category on Twitch. That might be useful. I mean, I don't know. I think my titles hold up for themselves. You make holograms with parabolic mirrors? Oh yeah, that's a little different though. I have a setup for that. I want to make a oh, what's it called? That thing where you view like subtle changes in air density. That kind of viewer out of it. Bitter Nerlick, thank you for the bits. Appreciate it. Okay. Oh, the 3D printer just finished. We might be able to do the revisions to this thing yet, so that I can actually kill that bug that's behind that thing. Now I got salt all over the place because I had to do the bit. You know, you got to do the bit. I don't know if you guys saw it land on the tool bin, but it landed on the tool bin. Yeah, Schlerslingen. Okay, so anyway, there's salt all over everything. I see a vacuum in my future. How did that fucking thing get in here anyway? Oh boy. Going on a shooting spree of a derelict bug against all of my lab equipment is probably not the most advisable thing in the world. If things stay dry over here, at least the salt won't get into anything. No, the window has a screen on it. We're in the Northeast. Windows have screens. I know that confuses a lot of European people, but we got a shit ton of bugs around here. So it's beneficial to us to actually have screens on every window. It's weird if there aren't. Yeah, I imported the bug from Europe just for the bit. Okay. So. Crunchy mouse. God damn it. The worst. Okay. Got a bunch of displays here. Let's take a look at some of them. They're in weird condition. They're a little ratty because they've been at the bottom of a bin. And they're partially covered in salt now, which is always fun. But I've got a couple of these little vintage displays from mid-80s, probably 70s, some of them. These things were featured in maybe like one or two like pocket actual digital calculators. Probably use logic level stuff in order to do basic calculations. And other things like that, like scientific displays and stuff like that. These things are thick. Look at the dumpy on that thing. That is a thick dumpy. So these things are pretty cool. They got these little like bubbles in order to magnify an actual silicon like chip, an actual substrate that has the LED stuff deposited on it, and then you've got your bonding wires coming over to the actual LED. These are a little different. These use traces. They look cooler. This one's scratched, unfortunately. But those have their own driver chip, it seems, that we may be able to get going in order to display stuff on this. Now, I think these are fairly famous at this point, and I could probably look them up in order to figure out what the pinout is. I don't know. These are probably originals. Ah, Jesus Christ. Fucking God damn it. That scared the shit out of me. Stuff is not supposed to hit me in the hand while I'm streaming. All right, you guys ready to see the bug assault in action? There it goes. Wow, that thing is really effective. Wow, that bug assault was a good purchase. Jesus fucking Christ. Stupid thing. All right. Anyway. Glad I got the bug assault. That really helped me kill that bug. All right, so that thing's done fluttering all over me. The reason it probably ended up on my hand was the same reason that solder smoke ends up in your face when you're soldering. You're creating kind of like a vortex around your body, and that creates a natural updraft. And that the bug, basically is fluttering around, and it gets caught in that draft and ends up right in your face. And that's where it hit me in the... It basically was like, blah, 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 and I'm like, blah, 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 and then what you saw just occurred. Anyway, that chapter's over. That thing is still locked and loaded. I'm going to shoot it in the garbage can. Unless there's more than one of them, in which case I will be horrified. All right, anyway, so these are, this is like a trip back in the past for displays. The stream is freedoming hard. Well, once the part cools on the bed, I guess I can try to put stuff together to see if I need to do any tweaks to this, because like this is not acceptable. So when I was using it, I had to be sure not to like rip it apart. Basically, it stabilizes here and it can hit on the back here. There's a metal peg that goes through that part. So I'll be able to support this thing fully. And I don't think I'll have room for a light. The light will have to go on the side. And then I'll, you know, the top rail's kind of ready to go too. It's been just a stupid weekend project to keep me busy while I've been waiting on parts for the RC car stuff. But I think it's kind of hilarious to fully sporterize a bug assault. I got more cool stuff coming for it, though. Yeah, I may put the green laser sight on it. The more comical that it looks, the better. Because, I mean, the spread coming out of this thing does not garner any of the types of sighting stuff that I'm putting on it. I'm putting a sight on this that costs as much as the rest of the thing. Anyway, so vintage displays. Back to that. Now that the... have you seen the CO2-powered revolver yet? I've seen all kinds of different revolvers. There's a Redditor from the gun subreddits that has a revolver. He does IT work at like people's houses, and he's got a revolver that's gas powered. And what that does is when he fires a round, the gas will kick a round out and then pull a round in to the drum. So he's shooting and the drum's going, and it's basically like in a movie where you've got somebody who's got a revolver and they have like 18 shots. That's what this thing does. It's got another tube that has rounds in it. And so when it kicks the round out with a puff of charge, it will pull around in some kind of weird mechanism. It's like a real steampunky looking affair. It's pretty crazy. I'm extremely excited for the RC car project. I'm hoping those circuit boards will work. I don't have it in me to do more revisions on that thing. All right, so bugs on my hand aside, the bug assault got its first kill, and it was through me just crushing. It was a crushing blow. So the question is if these were authentic displays of the Korean counterparts, and I have absolutely no idea. I mean, these are old. You can tell by the oxidization on the pins. 7320 is literally written in pencil in somebody else's handwriting on the back of that one. This one, or these ones are HP parts. Looks like we got broken pins on this one though. I wasn't always good with electronics, but I've always had these. 5082 7414. Is that what the person was talking about? I gotta scroll back up. 4 bits power and ground, can't remember, blah, 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 blah. Call an old bug which turned 2D monitors black. You had to swap monitors around. Primary, secondary, that's fun. TIL 314. That's not what these are. Top left. Yeah, so these are the ones that I kind of want to drive today because these are the cool ones. These things are like super retro cool. Let's take a look at them. I'm going to get tweezers because my fingers are not presentable. as has been commented in the past by mean people. I don't know why I'm surrounded by mean people. I don't know when that happened. 5082 7300 HP logo on them. 34 340S. So not TIL 314, but these are original HP. Luckily, they've got a wonderfully large part number on the back. So again, we're doing Arduino basics, but we're trying to do something cool as well. So let's try to get a 3-digit display going with these things. I think that would be kind of cool to do. So what I'm going to do is transfer. Okay, now every time a hair twitches in the wind, I think that there's another bug crawling on me. I got that going on for me. It's great. It's great. I'm going to have to constantly do this, and there's salt everywhere. I think the bug assault might not be the best thing to use indoors. Maybe I go outside and start using this thing and then get shot by a cop. America. All right. Anyway, let's get these things out of here. And I'm going to very carefully put them into this board because these pins are old and I've used these things before. I have not wired them up all simultaneously to an Arduino before, though. I've had them waiting in the wings for a project, and you can see my storage of them was not exactly the best. I'd probably buy some new ones on eBay that are in better shape than this because, you know, this kind of stuff kind of, I don't know, people buy up stock of stuff like that. You can probably find them. I don't know if they'd be cheap. But anyway, these will go into the the breadboard. Ooh boy. These have been repaired badly. Ew, these have been repaired. I approached a salty citizen. The threat was dealt with. Pin 1 up there. All right, so let's just put them over the gap, all in the same orientation, and hopefully that doesn't damage them. So pin 1. Did that switch sides? No. Okay, it was like that. So these are cool. You can get them real close to one another, and they display a 7-segment display. Now we just need to take control of them. Let me not plug that one in, because I need to look it up. So this one is 5082. Let's try 5082, 7-segment display. I did not mean to open a folder. Hold on. Bring that over here. This mouse is extremely light. 5082, 7-segment Broadcom. No available image. LED 7-segment display is designed for viewing distances of 5 meters. I don't know if this is the right thing. Life cycle. Active? No. HP 5082 for sale. $15. Oh my god, I'm sitting on a gold mine. These can do hex? Wait a minute. Plot thickens. Oh, cool. Okay, well, we'll have to see what we can do with this then. Let's do HP. We'll add datasheet to it. $7,300. So 7740, 7730. This one is a 7300. Ooh, look at how old this datasheet is. They couldn't even afford color. Back in the day, when everything was black and white in real life. All right, numeric, 5802, 7300 to 7302. Hex is 7304. So we've got numbers on this. We've only got numbers. Atomic Haggis. Oi, oi. How's it going? Solid state numeric and hexadecimal provides 7.4 millimeter and a bunch of display digital information. Okay, cool. So we've got our stuff. As long as you got the money, we got the stuff. Five and a half volts. We're dealing with TTL voltage, which is 5 volts. So, all right, so we got our 3 numbers sitting next to one another. Hopefully none of these are broken throughout the years of me pooping around with them. But yeah, see, through-hole stuff can just be plopped down in the middle of this trough. And now I've got these rows are of five holes are basically connected to one another. And they're isolated from the other side, and I've got horizontal rows here. So my natural inclination is just in the first one, I put these 3 things down. We'll hook it up to an Arduino Uno, just because that's more of the beginner kind of stuff. Typically with perforated prototyping boards, I like to have something like a Pro Mini. Well, Pro Mini is too old. You can get cheap Arduinos that have USB on them that plug into the breadboard, and that organizes stuff a lot better. We'll deal with the Arduino Uno today, just because basics, right? But if you're going to be doing stuff like programming stuff that's automated and things like that, it helps to spend a little bit of money, get one that can plug into the breadboard, right? I've just started my journey to not make things explode. Oh man, Godspeed, Godspeed. It's okay if things explode as long as you learn the lesson from what caused it. All right, so let's see here. We got our inputs. Decimal point, blanking control, latch enable, ground. All right, how do we input to these things? The other thing is, what is a good way to get into programming for the Arduino? Get a basics kit and do it. Just do it. Just get out there, sit down with a pot of coffee on a Sunday when everyone's gonna leave you alone. This is important, right? So Chat is going to try to talk to you about this, and you could listen to them, or you know, I could answer this question. It's very simple. You buy a kit, and there's tons of different starter kits out there, depending on what you feel like you're going to do. You probably have a project in mind. If you don't, that's even better, because then you can just go through like a basics kit. You can look on sites like SparkFun, Adafruit. You can just Google it a little bit, and then buy the kit. The important part is sitting down with that kit on a day when nobody's going to bother you for a little while and going through some of the stuff that they're going to try to teach you. Digital electronics is fairly easy. You hook up power, you hook up ground, you hook the thing up to the other thing, and then you put code into the thing and run it, and you get a basic display of what's capable on that hardware. So like, if I were to go through and be like, I want to do something wireless with a random radio module that I found, and if I have 2 of these, I look up the radio module, and then I add Arduino to the search, and somebody's going to have a project where they've done this. And it's like, cool. All right. So now that I've got this radio module and I know how to hook it up to the Arduino, I've followed their steps and I've gotten it working. That's science, right? Science is following steps and getting something working that proves a point. So in this case, it's like, here's this radio, here's the other radio, hook it up to 2 Arduinos. I push a button, the light comes on the other end. Cool. Now, what can I do with that? So what you can do with that is then add stuff to it. When I push the button, I want it to tell me what temperature it is at the other module. Well, okay, find something that reads temperature. Find a basic web page that tells you, oh, this is how you read temperature with an Arduino. And you're like, cool. Now I can put that into a variable. I can put that variable into the radio module somehow. That little connective tissue is what makes or breaks, you know, the big projects. That's essentially how you do it. You take a bunch of little projects, staple them together. Boom, there you go. So that's a little bit, that's kind of a, you know, eventually what we're getting at. But what I'm trying to do right now is just run vintage displays. And we're going to find out exactly how covered this is. There's probably somebody that's done this. I'm going to guess. Everybody's already done everything. That's kind of my experience. And if you find, you know, if somebody hasn't already done something, then, you know, either it's a project to put aside for later when you're more skilled, or something that you need to break down into small bite-sized component parts. But as a very beginner, if you have something in mind that you want to do and you can't find a basic how-to, I think you mentioned I have a GPS module that I can't find info for. That's a tough one. You want to start out with the basics. You want to learn how to get digital communication running to Arduinos, and maybe look up info about that GPS module to see how it speaks to stuff, and then learn those protocols in little bite-sized project chunks. That's the only way that I can recommend you do that, because you need to build your skills up to the level of being able to reverse engineer something. And in order to be able to reverse engineer something, you need to know a lot about it. It takes a little bit of like an intuition and experience that you only gain from doing stuff. So, you know, you could buy a cheap GPS module and run that off of an Arduino, and it'll give you a little bit of an idea about how these things go together. Because all these projects, man, they've GPS modules and Arduinos, man, they go together like peanut butter and chocolate. Alrighty, so these little things are a little weird, right? They're a little weird. They've got like signal inputs and latch inputs. So we need to figure out how we're supposed to hook these things up to one another. And here's the character layout. So if we need to, we could program this into the Arduino. We've got hexadecimal display, so 0 through 9, A, B, C, D, E, and F. And that's just basic binary. That's basic binary bit numbers. 4 lows is a 0. 4 lows, 1 high is a 1. Okay, that's way easy. It's just a 7-segment display, right? So this is what I was going to use the 7400 series logic chips for. One of the famous things the 7400 series does is a hex to not BCD, it's hex to 7-segment display. That's one of the basic chips for the 7400 series logic, right? So you plop that chip down, you give it those lows and highs, and it'll turn on the LEDs in accordance to that. HP went, oh, why? What the fuck? Let's just, whatever. Let's just put it into, so they just put it into their display, which is why, boop, which is why we have a little chip. Yoink. Wow, that is dusty. That's why we have a little chip there sitting on these things. That little chip right there is a, it's a binary coded, no, damn it, it's a 7-segment, it's a binary to 7-segment display driver, whatever, get out of my face. All right, yeah, it's salt everywhere. I tried to kill the bug with a bug of salt, and it turns out I had to do it like a caveman. All right, so we got a decimal point on that too. Plus minus decimal point, DDD 1D. All zeros, huh? 1, 2, 3, 4, and 8. All right. Studley Ham, thank you for the follow. Wait, they want transistors in here? I don't think I'm going to provide them with transistors. I think what we're going to do, I think I'm just going to do Arduino directly into this thing. I mean, I guess they want the transistors because of the amount of current that the LEDs draw. Oh no, this is the internal driving circuit. We don't need to worry about this. That's right. Okay, sorry. We're dealing with logic level. So everything is TTL level, so it's 0 to 5 volts. But they're giving us individual, for further information concerning electrical and mechanical implementations, blah. Okay, scroll up. So this is how we drive it, this little diagram right here. This is a little bit more advanced, but like I said, we're not doing 101 stuff today. We're kind of exploring cool stuff that we can play with. Now there's a potential for reducing the number of pins that these things take up. You can use stuff like a mux, which splits signals out. It's like a switch that splits stuff out, but I'm not going to do that, I guess. I haven't worked with directly triacs, but it is something that I would like to do. Three, 2, 1, and 8 are the logic drivers. We got an enable, and a DP, and a blanking control, and a ground. Pertains to the 7304 hex indicator only. So the blanking control we don't need. Decimal point input pertains to the 7300, 7302. That's what we have. So we've got the decimal point control. Pin 4. Don't need this. It's not blanking control. So it's decimal pin, 4 pins, VCC, and enable. Oh my God. This might get a little complicated if I want to run 3 of these things. Let's start with 1, I guess. Here, now, okay, here's the thing. I've got this piece of like this is probably copyright 1980, right? Copyright. Where's the copyright? It's always hard to find dates on these things. I would like to know what vintage these are from. It doesn't look like they've got a date anywhere on this. Sometimes they'll have like revision history and stuff. I'm sure HP keeps track of that. If I found the right web page, I could probably find what date these are from. But these things are old, right? These are old display chips. But one of the interesting things is what you can do with electronics like this is you can just go and, oh my God, I'm gonna cover over chat. One of the things with these old chips, what you can do is you can actually just go with the number, then Arduino. There's a possibility, look at that. There's a possibility that the first result, this is basically what the I'm feeling lucky button was invented for. This is a vintage, like, I'm gonna say 1970s, it's probably 80s because it has the it's the circuits integrated with it. So the 1980s level display technology, probably late 80s. And I'm literally just able to go part number, Arduino, and the first result is running display blah 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 with Arduino. So as simple as it gets, right? Oh no, it's only a forum post. 4 of these showing the voltage of a 24-volt battery. So there's 2 projects right there. Project number 1 is what we're working on. Get the displays working. Project number 2 is show the voltage of a battery. And somebody has gone spelunking deep enough to find an actual circuit for these things. Now, I don't necessarily need this circuit, but you know, maybe we could just look at it. So this guy has like character select, and then he's got all of these wired in parallel, which is the way that you can communicate to these things, because they have a latch pin, right? So each additional binary number that you need to send along the way, you can send it to all of them at once as long as you're not latching to it. And so you're going to latch going down the line. So that latch pin is the unique pin that goes back to the Arduino. There are ways that you can actually use things like a mux in order to use fewer pins on those latch pins. Because if you get more than like 4 segments, then it might be beneficial to use like a coded, like a binary number. So you could have 1 1 latch number 1, or 0 0 latch the first one, 0 1 latch the second, etc., etc. So you could do stuff like that with a circuit trickery and the way you kind of switch things and stuff. But anyway, the point is that we got plenty of pins available to us on the Arduino. We're going to need 4 in order to tell the thing what number to display. We're going to need a latch pin per, so that's 7 pins. And then the enables, I think we can always enable them unless we're using enable over latch. It depends on which one we're going to do. I think latch is what we want. Enable turns on the display. So 7 pins, maybe 8. I don't think we need to enable everybody. We can just hard enable everybody, right? I'm an enabler. Yeah, and that's it. So this is something that is basically how do I explain this? This is something that I basically know out of not really studying electronics. They didn't really teach us this in school. It's more like something that I know through using segment displays in the past. Man, it would be cool to have like 15 of these things. I don't know if there's any way to get these things bulk, is there? It was the I don't know, having the letter display on that would be pretty cool. But yeah, according to eBay, the one that we found, $15 for the whole thing. So for one of these, so I don't know. But anyway, these are things that I found in a drawer, right? You know, you hold on to cool stuff, cool display technology long enough, and you eventually end up with a cool project. So that's what we're doing today. All right, let me drag this thing back over and see what chat's saying. It's a wall of Nightmare Joker. Early 80s, okay. Nightmare Joker is trying to remote pilot me right now, so I'm just going to leave that alone. I'm calling it out. What, Agilent and HP? So it was early 80s? Okay. I know, he's not that, no, it's not bad. It's not bad. All right, so anyway. No, it's okay. He's fine. He's fine. I felt the need to point out that I already said at the beginning of the stream that there was going to be a lot of backseating because I am in everyone's wheelhouse at once, because we're doing basics. So everybody understands how to do this already, especially the people who are watching my stream. But we've got massively larger numbers than we normally do on a Tuesday because I'm working on basics, which means we have a lot of new people coming in. So you guys aren't going to let me talk, but it's okay. You guys can do whatever you want. It's okay. Anyway, yeah. So let's get these things running. How do we do that? Well, we need to hook up all of the numerical inputs to this thing to themselves. So we are in this series, the 7300 and 7302, right? We've got input 2, 4, 8, and 1. So 1, 2, 4, 8 is just representative of the binary positioning, right? Low-key preparing to put a piece of paper over chat. I don't still have that piece of poster board. I would love to use, so I have, all right, let me digress for just a second here. It would be hilarious if I printed out like a block or, oh wait. Oh, let me get the part off of the 3D printer real quick. I digress in my digression. Give me one sec. I gotta get the part off of the 3D printer, which involves spritzing it with Windex, like it's a bad puppy. You shouldn't spritz a puppy with Windex, by the way. That's bad. But PETG apparently breaks off almost immediately when Windex is introduced. So you let it cool a little bit, spritz it with Windex, and then you wipe off the print surface with a paper towel, and then you're ready to go for another print. So we'll do a little bug assault a little later on. Okay, so the 3D printer's ready to go again. I could spool up the cell phone holder. Let's see how this print turned out just real quick. I know, we're pretty deep into the digressions here. Okay. We will get there. All right, so this is the bottom rail for the bug assault. And since it's red, the camera's like, oh my God. It really, man, the sensor on this camera, red, I'm all in. And then it's like glowing. But yeah, this is the new bottom rail, and it'll go on like this. So I'll have a little bit more room to adjust where the handle is if I want. I could move the handle all the way to the back, and that might free up the front for a light. But then I'll also have the side rails. So yeah, we'll put that together. Either we'll do that, or I'll do it on my own. Hopefully I get the parts that I'm waiting for, because I got something special for the stock. All right, so my cube mate was fired last week. I'm not sure if I should answer his phone, but it's been ringing a lot lately. Let you unplug it. That's what I'd do. Unplug it, and then when the new guy comes in, you go, oh yeah, I think they left your phone unplugged. You should probably plug that in. Good call. No. You don't want calls. That's the whole point. Forward it to HR. Oh, God. Remember, HR doesn't give a shit about you. All right, we're hooking this thing up to these things. Now, these are a relic of yesteryear, right? But they use the basic principles that this kind of stuff from yesteryear uses. So if you're looking to drive a 7-segment display these days, if you want to have a vintage look and have a 7-segment display, I would actually suggest that you look for something like an I2C 7-segment display driver, because I2C uses 2 pins out of your microcontroller, and it's a serial form of communication that goes very quickly over 2 pins. So you would have 2 pins that would be bused to each individual 7-segment driver, and each of those drivers would have an address. And there are probably libraries for the Arduino for such things that allow you to just print a string or whatever and have it organize itself and go out to all those addresses. So it makes it a little easier on your programming to do it that way. In our case, I am forced to use a binary to 7-segment method in order to display these numbers, because it's baked into the part. So that's what we're going to do. I2C would be a much better choice for my project than custom serial shift register. That's what I'm talking about, man. You don't have to deal with all that lower level stuff. You're just sending out a command to everybody and they respond. That's so much easier to do with something like an Arduino. But anyway, we are stuck using 7-segment displays. So we're stuck using 7-segment. We're not stuck. We're doing it intentionally. But they're baked into there. So what we need to do is we need to go old school. This is like 80s and 90s kind of dealing with electronics. What they would do is they would send those 4 binary digits to everyone at once, and then individually latch the number that they want to display. So let's do that. Oh God, there's just nastiness everywhere today. Hup, up, 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 beep, boop, beep, bop, beep. Hey there. Hey, buddy. Okay, so where the hell's pin 1? Well, first of all, these 3 are upside down. I'll invert the breadboard. We'll hook everything up going downwards to these things. Yeah, I guess I could air compress everything away. That might blow the salt away too. Is there salt on top of my oscilloscope? There is. I knew what I was getting into. All right, anyway. what we need to know is where pin 1 is, and then we need to start hooking them. We need to start hooking them all up, but that one looks like it broke. All right, so in order to get especially super fragile chips like these out of something like this, I need to be very careful. If I were to just pull on these and pluck them out, what'll happen is my fingers would roll on the chip and then bend all those pins in. These pins are made out of the cheapest metal that they possibly can be made out of, because everybody has to complain if their electronics are anywhere above 30 cents a piece. So these are made out of absolutely the cheapest material possible, absolutely possible, right? You got engineers running the show. Of course they're going to make everything as cheap as they possibly can make them. So they don't bend. We don't want to bend them. When you first get a chip, like an integrated circuit, and you want to plug it into this board, you may have to roll the chip on its side very carefully in order to make those pins face a little bit more inward. That's sort of a common practice. It's something that I'm pretty trained on, actually, after many years of doing it and slipping and accidentally bending all of them down. It's bad news bears. You got to be careful. But so when you get a chip that's new with this kind of chip, I would push my fingers on the pins just a little bit, just to narrow them so that they can actually plug into the perforated prototyping board. If you don't do that, then this will happen. One of the pins will bend out because it wasn't able to find the hole that it's supposed to go in. I should have been more careful putting this thing in there. We can repair that. So I'm going to repair that really quick. What I'm going to do is get this thing out of here. Now, there are chip pullers. There are little chip pullers that you could use in order to pull these chips out of here. It'd be difficult to get in between the two on this thing, but I don't really need one. This is only an 8-pin chip. So what I'm going to do is get a pair of tweezers. And you can see that that's tapered, like a little wedge. I'm going to drive that little wedge in here, tilt it a little bit, back and forth, very carefully, and then I'm going to go to one end of the pins. Let's not undo this one. Let's keep that one plugged in. Undo these, and so now the whole thing is bending, and these haven't popped out yet. So push down on that side, and just work it like that. Just basically very carefully pop it directly up. So this one can be fixed, but it might break off. And if it does, it looks like I can probably resolder. I don't have a pin to resolder to it, but I do have something close enough. It looks like these could actually be de facto surface mount parts. But yeah, so this is a very careful operation right now. It's a very careful operation. So what I'm going to do here is I'm going to get a pair of needle nose pliers. Well, in my case, they're wire strippers. They're the thing that I usually use with these things. So what I'm going to do is bend this pin back flat with a flat pinching device. But doing so might ruin it. Now these might be a little rough. Yeah, let's go to the other ones. So look, I don't have stocks of these pins sitting around. So if this breaks off, we'll have to do something a little weird to get it back on. But what I'm going to do is just work that flat. It's probably not in good shape to begin with, but it's not quite there yet. So I may have to bend that again, which I don't like the prospect of. This metal fatigues very quickly, and it may already have a crack in it. All right, here we go. We'll try that. We'll see if that plugs in. It's not worth it to try to like anneal or anything like that. That's kind of silly to do. The Heathen Games. I think you're following. So the best thing that you can do is just know how to rework the pins. I mean, make sure that it plugs in evenly. All right, so that's repaired for now. Lucky for us, which is not typically the case with integrated circuits, lucky for us, you can resolder the pins. It seems at least like you can desolder this. You could actually use this as a surface mount device, which I think is pretty cool. Maybe one day I'll figure out something to do with these that'll be like in a surface mount design. That'd be very cool. Yeah, I mean, if you can find a socket that's going to fit something this wide, I don't know if I have anything like that. All right, so now we got to hook up all the pins that do the communication stuff in parallel. So let's figure out what pins those is. So in order to run logic on this thing, we need pin 1, 2, 3, and 8. Where the hell's 1, 2, 3, and 8? Well, I mean, there's a dot here that's keying in pin 1, and this data sheet is old enough that it's actually telling you how they're numbering the numbers. So this is done like an integrated circuit. So the integrated circuit, what'll happen is, and this is actually backwards. Oh, why do they do this with these? Your typical integrated circuit, something like this. This is like actually kind of a large IC, but no, you know what? It's not back. Well, it is. It is backward. No, when you flip it over, it's right side. Okay, so yeah. This dot right here denotes our pin 1, and with integrated circuits, you count the numbers from pin, and remember, we're not programmers, we're electrical engineers suddenly. So we start at 1. Yes, I got it, everybody. Oh, Jesus Christ. Okay, I'm good. I'm not going to pay attention to the backseaters. We start with pin 1, and we count up going across from pin to pin, right? 1, 2, 3, 4, 5, etc. And then the next pin, when you get to the end of the row, is right here. And then you count back this way. Now, if you have pins on all sides of your device, you count the pins, and then you move over to the next one up the side of the device and then across. If you have a, does this have that? Yeah. If you have a header like this, this is a pin header, guys. Ignore all the detritus, the dust that's on this thing. But if you have a pin header like this, the pins are, this one is 1 because it has the dot on it. The one across from it is 2. And then you go down here to 3, and then 4, and then 5, and then 6. So just to make sure that it's clear, integrated circuit, we go down the row, up and back in a U shape. Or, you know, just anti-clockwise around the chip. With a pin header, you know, pin 1, across from it is pin 2, 3, 4, 5, 6. So yeah, that's wonderfully and amazingly, annoyingly confusing. It always helps to double check what you're thinking about when you do that. So anyway, with these, pin 1 is here, because if we flip it over, we get that bottom view from the data sheet. So this is pin 1, 2, 3, 4, 5, 6, 7, and 8. So 1, 2, 3, 4, we got to run in parallel across these chips. So let's do that real quick. And in order to do that, I've got a jumper wire kit, as well as all the jumper wires that I pulled out of the previous iteration of what was on the thing. So these jumper wire kits, this one was like 15 bucks. Little man, put that shit in my hand. If you don't got the dough, you owe me, oh. Anyway, this is like 15 bucks. I got to get a new one. This is in shit shape. I've spilled it before, so all the different wire segments are different lengths. Some people, the more hardcore people out there, they actually cut their own wires for this stuff. But this is solid core wire, and again, it's made absolutely to the lowest. It's the bottomest of the bottom dollars. Like this is the lowest bidder of all of them. So if you bend these once or twice, they are liable to break. It's just annoying that way. But generally, you can, like, you know, route these around stuff like I have. But it's when you bend that 90-degree angle at the end that things can get a little hinky. So anyway, by the way, one thing. Oh, I freaked your mom. Well, as long as she's having a good time. Subscribe to Tier 1. Let's put you up on the board. Maybe I can get there before the API. It's like I can casually walk over to the board before the Twitch API catches up. Look at that. Look at that. Why are you so slow? Why are you so slow? Come on, man. We'll probably do another Arduino Basics next Tuesday, because I think this is a good thing to do on Tuesdays, is take it back to the old school, because I'm old school, or because I'm an old fool who's so cool. I freaked your mom. Thanks for the sub. Welcome to the board. Oh, it's a Djibouti viewer. I knew it. I smelled it on him. Yeah, it smells like Djibouti. Djibouti musk. It's Pops' salt. Mom, no. Welcome to the board. Oh, God. That camera error is not getting better. Calm the hell down. Jeez. Sort your pixels out. I use DuPont wires instead. I don't like the DuPont wires. They make a big bird's nest above your entire thing. Yeah, it's from Jay and Silent Bob Strike Back, but it's also, oh wee, oh wee, oh. If you have an LED, which pin is the one? What? Anode or cathode? What are you talking about? I've explained it many times. Does IED reverse engineering pay? It did. It doesn't anymore. We're not really dealing with that shit much anymore. Yeah, it's Jungle Love. There you go. That's what it was. I couldn't come up with it. You guys have Google. If you like the colorful bird's nest, I don't like it. I don't like it. I think it's sloppy and they don't travel well when you use what they were talking about when they said DuPont. A DuPont connector is a type of what's called a square header, and a square header is literally exactly what it sounds like. I've said it many times on the stream before. Engineers are extraordinarily they're extraordinarily clever about the things that they call stuff. So this is a JST plug kit. JST, Japanese Standard, I don't know, T connector. I don't know what that T means in that case. But square pin headers are literally, or square headers are literally just square headers that hold pins. So where did my kit go of them? I was going to show you what DuPonts look like. Well, fuck me dead. All right, let me find other DuPont connectors. I think I've got some DuPonts sitting in some of these bins of wires. Yeah. So yeah, DuPont headers are these little square ones that are 0.1 inch and of this particular design. There are lots of subtly different designs, but a DuPont header is this like square pin that has a wire coming out of it. So it's a lot like these similar ones that I have, these jumpers. These jumpers for me are typically if I have to move a connection a lot or if I have an external signal coming into the board. What I'll use these for more than anything else is to connect the oscilloscope to the board so I don't have a big probe sitting right next to the thing and I can, can move around without damaging it. I don't like doing point-to-point wiring with just these things because then you've got 1,000 wires doing this and it makes for an annoying to troubleshoot board. It's all preferential though, it's all preferential. I prefer using these guys. So these will sit flat against the board and we can put together our complex things without making, I mean, we're gonna make a mess, but it'll be a little bit less of one, so. So anyway, our job right now is to connect this pin to this pin to this pin, this pin to the blah, 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 et cetera, et cetera, et cetera, until we're blue in the fucking face, right? So this is going to be annoying, but and it's going to use up a lot of wires. I'll try to find a standard one that I have like 16,000 of. I guess maybe blue is probably too long. We could do it flat on the board. How many? I have 1, 2, 3, 4, and I've only got 3 positions here to use. So I can't do it that way. We're going to have to go down and around to the next piece. So unfortunately, I can't do a pin here that goes directly across to the next one, because then this won't have anywhere. It'll go bop, bop, bop. And then that one is blocked by those 3. So I'll have to go down and over to the next one. Just how it is. It's just how it is. I got all kinds of different colors of wires in here. I just don't know which one I want to use. I mean, the reds I use for other stuff. Reds are probably the right length, though. We'll start with reds. I'll just put a little bend in the bottom of it. And I'll just take it from the bottom. Go like that. Now we're in a situation where I need another line up here to cross over. This is going to suck. This is going to be fun. So from here, I'm going to be blocking a bunch of stuff, trying to get over to here. And then I'll do a long wire from that, because that one will go... Actually, that one is what gets a... that'll get an actual jumper, because that'll go to the Arduino. So where are the lengths of jumpers that I would like for this thing? I mean, yeah, we could use these. We could use these. It helps to vary the color of the wire quite a bit so that you can actually figure out what the hell you've plugged into what. I don't think we're going to have much of that luxury here. Yeah, we're going to have to... That's going to be weird routing. Unless I put the Arduino down here. That'd probably be better. So yeah, I'll put this thing down here. Oh yeah, parallax is your worst enemy. Parallax meaning the view of things in 3 dimensions appearing 2-dimensional. Basically, parallax is what, when you plug something tall into the board, it'll tend to look like you've plugged something into the row you wanted to, but it's actually misplaced and it's on the bad row. That happens quite a bit. You got to check your work over constantly with this sort of thing. You know what? I'm going to move this up 1 pin so all of my connections can be on the lowest row. You see here, I'm just using tweezers in order to move the wire. It just helps give me a little bit more control. This is too blocking. I'm going to use longer wires. Longer wires it is. We're blocking too much of what I'm trying to do here. Maybe these like disgusting... These are a disgusting color. We'll use those. I mean, I'm from Philly. Of course I'm quoting Jay and Silent Bob. What do you think this is? Yeah, teal. What a bastard. Get in there. Okay. Man, this is gonna be weird. I mean, this is where a perforated prototyping board that you solder could probably come in handy, but it's fairly more permanent. I can make structures like this way cleaner in with soldering. Oh yeah, that's fine. Don't worry about it. Don't worry about it, Chad. I got this. Don't worry. Hey. How's your mother? Once again, chat doesn't let you make mistakes. They don't let you realize that you've done the wrong thing, and they make sure that everything you do is correct. Streamer, you've done it wrong. Look out. This isn't the way I would do it. Yeah, that's whatever. You got to deal with it. Let's just switch it up just to make it look weird. More teal. How many of these things do I got? Oh, these are just gonna be gross when I'm done with them. These are just gonna be gross. You know, I think I'm gonna have to plug these into the bottom row, because otherwise they're all gonna block one another. Jeez. Second one to there. Second one to there. Third one. This will only take a second. See, all I'm doing is just bending them with my fingers in order to create a little U. Third one. Well, it doesn't really matter where I plug the wires into these, but... Who's eating Ben? What are you talking about? Maybe we do want consistency. Hold on. That doesn't really, it's kind of triggering me a little bit. I don't like that. I'll bring it back down here. Bring it back down here. Plug that in there. Taking it back to the old school because I'm an old fool who's so cool. There we go. Another teal. Oh, it's looking hideous. It looks hideous. Dropped one. That one doesn't seem fully plugged in, but I think there's enough wire in there that it'll be okay. That goes to there. This goes to there. I need 2 more. Maybe we'll find beauty within the pattern. We'll find beauty within the pattern. The problem is that I don't have enough pins going down this thing. I mean, you know, hey, if I put it in a socket, I could sneak another one under the chip. Then I would be able to get 4 out of the thing, and that would massively clean up this entire assembly that I'm putting together. But for now, it's fine. Fine for now. For now, should be all right. By virtue of working with basic principles, we are going to get a vintage display, early 80s display, running on an Arduino. And it uses old school technology in that it uses binary numbers in order to trigger the different characters that it can display. That is all thanks to this little guy right here. But we need to wire up these in parallel, and then we can run individual enable pins out to each of these. Now, I probably should have done power and ground. Power and ground are up here, though, so we can actually handle that right now before I do the parallel lines. I usually, like, power and ground are the ones that you're not really going to mess with, so you can kind of wire those up, make sure they're correct, and then you can come in and wire all the other connections on top of that. So VCC and ground, pins 7 and 6. 7 and 6, they're right in the middle of the damn thing. That's a weird place to put them. So flip that in your mind. You got to flip that, which is obnoxious. So the best way to do that is just to realize that it's like an integrated circuit, and that lower left-hand pin, as we're looking at it right now, is pin 1. So, because if we get this wrong, we will destroy the chip that we don't even know if it's working yet. So we want to do this correct the first time. So pin 7 is VCC. So we go over to here. I don't know. We'll go back to this view. Pin 7 is ground. No, pin 7 is VCC. Pin 7 is VCC. So 1, 2, 3, 4, 5, 6, 7 VCC. So let me get a jumper wire that's going to do that properly and basically get me all the way to the positive rail. We're running this thing off of 5 volts. I'm moderately sure that 5 volts is what the Arduino runs. Red wire. We don't have to color coordinate these because the colors represent different lengths of wire. No, shorter than red. Shorter than red. Aye. Yellow? That'll do. That'll do just fine. So yeah, we can just wire all of these individually. We don't need to do the jumpery thing that we did before. We can just hit them up to all this stuff. Now, if I really wanted to, if I had like tons of these displays that I wanted to run, if I wanted to run like 12 of these things, I could actually just opt to change this from power and ground. This doesn't have to be power and ground. I can disconnect it all the way up here where I'm busing it to everything, and I could use this I could use these as my individual 7 segments. Or sorry, the binary numbers for the 7 segments. And that would allow me to run lots of these things, and then I would just have to jumper wires up to these guys. That would massively clean up a larger display. I wouldn't have to have this running 1,000 times across the entire board. It would lead to confusion, so if I gave this to my lab partner, they might blow up my circuit. They wouldn't blow it up, it just wouldn't work. I guess if everything is in 5-volt logic, it probably won't blow things up. But yeah, you could do that, and it would help out. I'm sure there are other ways to do it too, but but instead we do this. Because yeah, then you could just daisy chain across to get your power and ground and stuff to everybody. So yeah, anything is possible at Zombocom. All right, I need one more of those yellow wires. Where's the shorter ones? Was that a... Oh, no, that was just something going bonk somewhere in the house. At least it's not a bug landing on my freaking arm. That was traumatizing. I don't have any more yellow ones of that length. Are you kidding me? Maybe there's one in the trash bin over here. What is happening over here in the trash bin? Not quite what I'm looking for. Maybe we could just use this gray one. Spelled with an A or an E, I don't care. Yeah, that'll do. That'll do. All right, so let's see. Grounds right next to power, pin 6. This is like kind of washed out, this camera. I think this camera didn't get initialized, so it's a little bit manky. All right, so we're just, okay, so for those who don't know, what we're doing is we're hooking this thing up to power and ground, and then we're taking the binary numbers that represent the digits, binary to 7 segment, and we're hooking them all up in parallel. What that's going to achieve is a signal to every chip at once from the Arduino, and then they will have individual latch keys. It will be latch key kids. They will have individual latch keys that will enable each segment to display a number, whatever number is on that parallel bus. So what I'm doing right now is I'm hooking it up to power and ground so that I've got those connections established, because what I'm going to do next is that parallel connection of the 8th, whatever it is, the last binary digit. So that's going to cover over this stuff. So I figured I'd do this now because this will pack down flat and be nice and clean. Is that a latch? I guess there's one pin for the latch. I guess they said there was a pin for the decimal. I don't know which one that is. Hold on, wait a minute. Pin 5, which is here, this is the latch enable. So these 3 pins will go back to the Arduino. And then pin 8 is input 1. I guess it depends on what your... Pin 4. Oh, okay. This, all right. So actually, this is decimal enable, which we're not going to use. So I need to get, oh, great. I need to get rid of this one, which is under everybody else. Great. So what you're doing basically is, let's say what you're doing is you're giving instructions to a concert hall full of devices, and then you're pointing, basically you point at one device with an extra pin, and then you give everybody the instruction. So you say, I need you to display the following number, this one, and then you say the number, and then everybody follows. Ugh, get the... Ugh, jeez. That was tough. All right, so pins 1, 2, and 3 are in parallel. Pin 4 is a decimal point enable. We're not going to play with that today. We gotta set our we gotta scope creep this thing, you know. So let's use these wires that I just extracted to do pin 8. I2C is sort of the same thing, only you're sending out a serial signal instead of doing it in parallel. Doing it in parallel is very fast, but it's also a little bit old school. It requires a lot of extra stuff to have it happen. So in I2C, what's happening is you have one singular communication line that you are communicating with everyone over. I'm looking for that pin that I extracted. What happened to it? Is it this? I don't think so. What happened to the one that I... Hello? Okay, all right, I don't know where it went. With I2C, what you have is you have 2 lines. One is a voltage reference, so that would be ground. And then the other one is your communication line. So you have one communication line to what is ostensibly like a concert hall full of devices, right? Or, you know, I guess you could say everybody's listening in on the same line. And so what happens is you communicate an instruction, but you start by saying, here's the speed that I'm going to communicate it in, and here's an address. And then everybody looks at that instruction and goes, okay, that's the speed. Oh yeah, that's my code, or not. And they will respond accordingly as a result. And there's timings for that, and there's like a little bit of collision mechanics. So if two speak at the same time, one of them will hold off for a little bit, and then another one will try to communicate again. Okay, so that would be the last digit. So we've got order of 1, order of 2, order of 4, order of 8 right there. A small number 2, a number 4, a number 6 with no sauce. All right, so this right here is our latch pin, and that's not the latch pin. That's not the latch pin. The latch pin is important because that's how the microcontroller tells this individual device that whatever the state of those lines are, it needs to display. Stop it. Stop it, stop it, stop it. I don't need you guys to tell me that I'm off by 1 pin. I found it on my own. 3, 2, 1, chat is blocked. Okay, so you guys are blocked. All right, so yeah, we need to hook these up to pins of the microcontroller. Now, is it gonna matter what pin is what? No. We're not using pulse width modulation outputs. The microcontroller has, less so with the more modern ones, but it has certain capabilities on certain pins. So if you look up the data sheets on it, and I actually, the data sheet for a microcontroller is such an absolute fucking hassle. The data sheets for microcontrollers are expansive. They're huge, and they assume that you're working with this thing on the most fundamental level. So they've got like chapters and chapters and chapters about selecting clocks and how to use the base microcontroller features. It's actually not a good idea to look up the microcontroller data sheet if you're just starting out. What you need to know is that certain pins of the device have certain functions. That's the important thing to know about these things. If you look them up on Arduino's website, they will tell you that. Or what I look up is just like a pin diagram of it. So if I look up the basic Arduino Uno, and I go with pin out, and I go to Google Images, I can find ones that have the breakdown of what all the pins do. This one's a little complicated, but the point is certain pins have certain functions on them. The older your microcontroller, the more towards this type of Arduino Uno with the Atmega 328, the older that is, the more specifically functional some of your pins are going to be. So if you have an analog signal coming into your microcontroller, you can read it with a certain amount of bit precision. That means that it sees a voltage level between VCC and ground, and it assigns a number to that. And that number is assigned from typically 0 to 255. And you'll use that in your code in order to respond to an analog signal. But you can't do that with a GPIO, just your general purpose IO pin. You need to have an analog capable GPIO. You need to define it as an input. And you can actually define mid-code. You can change your outputs to inputs. We've done that before, and that's how we get like configuration stuff. So in our case, we don't really need any special purposes out of any of these pins. And these analog pins can work as digital pins, so it doesn't matter what pins we use, as long as we're not plugging it into like a reset pin or something like that. Certain pins on the board itself have a little ampersand in front of it, a little squiggle in the upper left-hand corner of your computer keyboard, unless you're using it. But bother, I use a weird keyboard because I have to counterexample every fucking thing you say. I don't care. Anyway, ampersand in front of the pin means that it's also capable of pulse width modulated output. There are helpers in the background of the microcontroller that help you do things like output a signal at a particular frequency. It's a misnomer with the Arduino, because the Italians made it. It's a misnomer. They said analog out. You can type analog out. Oh, look at me, I'm super cool, and I'm analog outputting. People think that you can type analog out and you can output a particular voltage level. That's not true. It is true if you design a resistor capacitor around that, but that kind of sucks. So anyway, it's a misnomer to say that analog out is your way to output a particular voltage level. That actually outputs a pulse width modulated signal from 0, which is just ground, to 255, which is just 5 volts. But between there, you have a square wave signal with a particular width to the pulse. That's what PWM outputs help you do. It's something that exists in the back of the microcontroller in the background, so you don't have to actually come up with your own pulse width modulation engine. It runs at a particular frequency. That's the trade-off, and you could change that, but it messes up a couple timers inside of the microcontroller. It all depends on the architecture you're using too. That's the thing. This is the kind of stuff, and if I get deeper into it, if I get deeper into my knowledge of this kind of stuff, this is the kind of thing that discourages new people from using hardware, from getting into physical computing. So I like to avoid it, and I know chat is probably pulling their hair out at how simplistic my explanation is, but most of the people who use this kind of hardware and are trying to get into it don't need to know this kind of stuff. We'll get into it later. But anyway, the point is, certain pins have certain jobs. Sometimes. We don't need anything complicated because we are using logic levels. So our microcontroller is controlling ups and downs, 5 volts or zeros on those pins. It'll do it very quickly, but we don't need it to be we don't need to use specialized pins for anything. We're going to stick to the digital outputs just because that's good practice. We won't use any of the analog outputs. So the pins that are off limits are these on this side. Back in the day, when they designed the Arduino, they did possibly the most annoying piece of proprietary design that I've ever seen in a circuit board in my life, which is to separate this pin header by a non-standard distance. This is not 0.1 inch spaced. So people were buying Arduinos and they were starting to use this thing and they were getting into the wide world of electronics. And the sky was their oyster. That doesn't sound right. Anyway, the Pearl was their oyster, and they were able to start really messing around with these things and building their own circuits. And so you'd buy a perforated prototyping board, and you would cut it to the size that would fit on the Arduino. Lo and behold, this header right here would cause all kinds of mayhem. And so people couldn't use just a perforated prototyping board with this, and they couldn't plug it directly into a breadboard. And so everybody had to come up with weird adapters in order to build this thing. And this is back when circuit boards were way more expensive to get built. Nowadays, you can spin off $5 for 5 boards, and people scoff at how expensive that is. And it's like, come on. Back in the day, you'd spend $100 for like 20 boards, and you get them in like 3 or 4 months, and then you get to see whether or not you measured this properly. It was annoying. I never really used the Uno very much because I hated that little proprietary thing. The micro, nano, whatever, the breadboard compatible ones are the ones that I would stick to. But anyway, we're going to use an Uno today just because it's your typical Atmega 328. Should have enough room for code. I don't know what the hell's on this thing already. I don't know what I had programmed on it last. But we will plug into these with individual wires. So we need 7 pins. Well, I want to stay away from TX and RX. It's not too bad to use those, but we can just go with pin 2 through 9, and those are all digitals. So we got plenty of pins to play with here, and we can get what we need to get done. I'm going to uncover chat again and see what they're doing. No, the right side pins are all 0.1 inch spaced. These are in line with the ones across from them. These are not. So. Being rebellious little punks. You set up a fixed transistor test logic that just sends the binary number as a test. Yeah, totally. One thing that I would do is because we're using 5-volt logic, like TTL logic is great because you can just put indicators on everything. One thing that I have in my bag of tricks over here are a bunch of 3mm LEDs, not 5mm. 5mm LEDs are great, but they take up too much space. They're super cheap, and they're great for like indicators on stuff. Take up too much space. But I have a bunch of 3mm LEDs that I've soldered to 10K ohm resistors that I can just punch into the board. And so if I want to, I can punch those in between ground and the signal, and they'll light up when the signal comes on. No, it's this spacing that I was circling that's unique. These are 0.1 inch. But this is a non-standard. So they basically are just pushing this down in order to keep you down, like the man. All right, so anyway, I'm gonna punch these things into a bunch of pins, and then we'll figure out what happens in the aftermath. So I need a bunch of wires. You know, I'm tempted to use flatter wires to try to connect this thing, because I'm gonna have a lot of stuff crossing over. Maybe we could just do it like this. I just gotta be careful that that doesn't short out on anything. So if I do, well, I could do this, yeah, somewhere around there. So yeah, each of the pin 4 is decimal. These are the latches. These are the latches first. So I'm going to start with pin 2 because pin 0 and 1 are actually... See, okay. All right. This is an Arduino. Because this is a physical computing device, you need to be aware. Programmers love to start arrays at 0. Electrical engineers start pins at 1 because a 0th pin is not a thing. A first pin is. So this microcontroller starts at pin 1, but according to the numbering of the pins, it starts at pin 0. Pin 1 is not pin 1 on the output of this thing, though. What they've done is they have renamed all of these pins to give them just a number. That's something that's done in the Arduino software for you, so you don't have to worry about pin banks. Because in a microcontroller, those pins and their statuses exist as a binary number in a register. That binary number in a register is given a bank. You don't need to worry about that. They have renamed all of these pins as numerical identities or assignments or what numerical thingies that you will basically just call out in software in order to use them properly. That's all you need to worry about. So what we can do is we can do two things. First of all, we could program this old school so that we are individually controlling everything happening to it and running through a number of numbers. So we can make a function that will output the binary number on the pins and then latch it. And then we could also look for a library that does that for us. It's two different things. If we get a library that does that for us, our code shrinks down to like nothing. That's super cool. But in our case, the way we want to start out so we can learn this stuff a little bit is to write our own function that's going to output the stuff and then input the stuff to that function. That's how we're going to do it. I literally just came up with that now. That's how smart I am. All right, anyway. Listen, no, there's no team here. No, there's not Team Zero. This isn't our programmer humor. This is something that exists in the real life. This is how things are done. Electrical engineers working in the physical world, pin 1 is pin 1. Programmers working in stupid fucking La La Land Unicornville, they start with 0, even though it's just a conceptual thing. They start with 0 on the arrays and move up from there, thus confusing everybody else down the line, but they're really fucking smug about it, and they should all eat crow forever. But anyway, 0 is where the arrays start. 1 is where the pins start. They decided to label pin 0. They decided to label a pin 0, which I think is bad. That breaks nomenclature and all kinds of stuff like that. But we can live with that. We can live with that because we're electrical engineers. We're better than everybody else, and we can do their jobs. So yeah, that's what we're going to do. All right. So anyway, latch, first latch, not pin 0, because we're going to avoid TX and RX. When we program the Arduino, it uses the TX and RX, and so we'll get weird behavior on those pins. We can use these pins. You know, sky's the limit. It doesn't matter. It doesn't matter if we use these pins. We just have to be cognizant that if we upload code to the Arduino, these pins are gonna flutter around in their logic states, and that might cause weird behavior out of our device. So if we're pressed, we can use these, but I'm not going to. We're going to go 2 through 9 on this filthy board. How gross that is. Anyway. Pin 2. That's our first pin. Look at that. Beautiful. Pin 2. Pin number 3. Oh, I'm going to try to alternate the wire colors just so that we don't get too confused here. That might be a little bit unavoidable, but... 2, 3, and 4 are 3 digits. And then we have, let's go backwards order. So 8. This one is 4. Let's double check which one is 4. We go back to our data sheet. Data sheet is king. So pin input 4 is pin 2. Sorry, we're 8, 4, 2, 1. Oh wait, I did that wrong. So yeah, did that wrong. Well, actually, we'll go 1, 2, 4, 8 then. So this one goes to pin 1. So we're going third, second, first. 1, 2, 4, 8. Okay, 1. So we got 1. 2 is pin 1. 4. See what I'm talking about with these wires? Can't stand it. Pin 8. You can see the effect of using these things versus a microcontroller that will staple directly to your board. Anybody can do electrical engineering. I don't know, man. I keep it simple for you guys, but yeah. Do you like math, kids? Do you like the worst math? It's also very popular, which helps a lot, actually, and I love that. I love that there's enough help out there that people can get the tutelage they need in order to understand the concepts of love. One thing that I could do with this to clean it up is I could take these things over and then jump them to the wires. I could move them over so that we could still look at these digits. What do you guys, oh man, you guys just keep talking. All right, you believe what you want. Yeah, really. All right, so yeah, just trying to keep these wires out of the way so we can actually see what's going on here. All right, so, hooking this thing up. Oh boy. We got power, we got ground, but our power and ground isn't out to all the buses yet. So I need to do that now. So that's where our pinout comes in handy once again. So we're gonna look at the Arduino pinout over here. Oh, I need to get rid of these. This is just like a little memory prompt for me, basically. This is just like, hey, do you remember that we have to do this with 7400 series stuff in order to output a multiple DP? All right, close that. All right, so this pinout is very important. This is what I always do when I work on something like this. So, all right. My power supplies just made a noise. That's not good. What happened? I think some weird shit with the phase or something. It's like this unnerving buzzing that happens. Hey, I did architectural engineering. I did that for a little while. That was fun. You got to put this transformer 10 feet away from the wall so that the operator can use a fiberglass pole in order to turn it off. Because if they open that door while this thing is energized, electricity can arc 10 feet into them and kill them. Like, oh, neat. I guess I'll put that in the drawing then. All right. Hey, hardware doesn't need software. What are you talking about? We could do fully analog stuff. I just don't want to. I just don't want to today. All right, so we're hooking this thing up to power and ground. I want this thing to be powered off of USB. These LEDs are not going to take up a lot of current, and USB can provide like 2 amps. So we're good to go with hooking this thing up to USB power. So USB power, we're going to access through the Arduino. Now, if we actually wanted to power the Arduino independently on its own, we could do that as well. We could actually input to either, I don't know which one, 3 1/3, 5, I don't know, whichever, or ground or V in if we wanted to use its own voltage regulator in order to do that. But what we're going to do is we're going to hook up to 5 volts. Input voltage generator power when it is running from external power and not USB bus power. That's why are you pointing it that way? The arrow should be the other way around. Anyway, yeah, so we're going to plug into this 5-volt pin and ground in order to power up the rest of the board. Oh, look at that, you got the flatulent emote. There's the buzzing power supply again. Guys, if I lose power, that's the end of the stream. I can't stream without power. If you see all the other lights in here turn off, that means that I lost power. And then I've got like 2 or 3 minutes to close up before the internet dies. That's what happens when the neighborhood power goes out. The internet, whatever internet stuff happens external to this house, lasts like a couple minutes longer. But yeah, everything will cut off, and literally everything in here, well, minus the lights and stuff, is going to be powered by backup power supplies that I've had to put in because we get dodgy power out here. It's been better as of late, he says, as the power goes out. No? I hope that thing doesn't keep buzzing, because that buzzing noise is really concerning to me. It makes my hair stand on end. So anyway, 5 volts in ground is going to power our whole device. This thing is beautifully labeled, so we know that 5 volts and... Is that really 3 volts? No. Yeah, this one has 3 volts on it. I didn't know that. So 5 volts in ground. And now, is this thing compatible with 5-volt logic? I mean, it's not like we're getting signals, we're sending signals. So as long as 3 volts logic is enough for this thing. But anyway, 5 volts. We got to be careful of parallax here. 5 volts here. I can use a shorter line. I could use a shorter wire, although I may want to pick this thing up and take a look at it. I think this is a good length. Yeah, 5 volt and ground through that. All right, so 5 volts, follow it up, plug it in. And then 5 volts I'm putting to just the bus line. That can just go anywhere. I'm just leaving a little bit of extra cable so that I can pick this thing up and look at the pins. Do electronics wear out? Yeah. Takes a long damn time, though. And it depends on the environment they're in. The main thing that wears out electronics is heating and cooling cycles. So as you heat and cool stuff, it expands and contracts, even microscopically. And as it expands and contracts microscopically, it flexes things like traces and stuff like that and internal structures. And so eventually you'll form a break in the line. So yeah, and when a break forms in the line, if it's carrying a significant amount of current, that crack will perpetuate through the trace until there's a very small amount of trace left, and that very small amount of trace left will act like an igniter. So yeah, Arduino compatibility. Arduino Uno. Well, we'll just look up Arduino Uno and look at it on the website. So this is for the Rev 3, which is the surface mount version of this. No, it's actually the same Rev. Okay, so I think we can trust this. Operating voltage 5 volts, input voltage 6 to, that's for the input voltage. PWM digital, this is the number of pins, the amount of current that each pin can operate on. Because we're working with TTL logic, okay, I'm covering over chat because I'm going to get to all this stuff, and you guys are like 5. This is what chat does. They flip ahead in the textbook and go, I know this. That's not what this stream is about. I'm going to complain about it, but I'm also not going to police it because you guys can continue to try to backseat game. I'm going to try to resist it. It's my mental game today because it can't be helped. It can't be helped because people know this stuff and they want to be helpful. You know, it comes from a good place. I know it does. I will get frustrated at it, but don't take it personally, please. So anyway, we're looking at what compatibility the pins are. Some devices, the more evil devices out there, will only be compatible with 3.3 volt logic, and 3.3 volt logic is something of the past. 12 volt logic was where it all started. We moved down to 5 volt TTL logic in the 70s or something. And then down from there, we've moved to 3.3 volt logic. So a lot of the cooler chips you'll find out there, the really cool chips, the ones where you're like, damn, that chip is cool, those will be 3.3 volt logic. And then moving down from there, when you get into higher speeds and more cutting edge stuff, you get down into like 1 point something or other volt logic. We've moved on from there, and we've got like sub-volt logics and stuff like that going on now in sort of higher speed, lower power applications and stuff like that. But that's the onward march of technology. We are here in the past looking at a late 80s display device that uses TTL logic with an early 2000s invention with a Atmega 328 microcontroller on it that may or may not run 5 volt or 3 volt logic. It's around that borderline area. So we got to make sure that if we're running 5 volt stuff, first of all, that the voltage level that our device can assert is high enough to actually make that device respond. So if this is a 5 volt logic, it might only respond to stuff that gets really up towards the 5 volt level. In which case, if we've got a 3.3 volt device, we are up shit's creek and our paddle is non-existent. So what we need to do is make sure that this is outputting 5 volts and is 5 volt compatible, or that this can respond to voltage levels of around 3 volts. And because we're using TTL logic, we don't have to worry about the current output of the pins, because it's going to be high Z, high impedance. Basically, it senses the voltage on that pin, but it doesn't use a lot of that voltage. It's not lighting the LEDs with that voltage. It's lighting the LEDs with the 5 volts that we're sending it over the bus. The bus. 13-pin LED built in, 25 grams. The information we're looking for is not here. It says the operating voltage is 5 volts, but that's Atmega 328P. Blah blah schematics, board view, docs, facts, Control F 3.3. There we go. So it's in the text, which is typically what we ignore. Power pins, VIN, 5 volt, 3V3, IO ref. I think it is 5 volt compatible. I just want to be sure before we continue on. Set pin, blah 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 blah. So let's see. Rev 3. We could just add 5 volt. No, IO voltage. There we go. 5 volts. Okay, I just had to be sure. I'm pretty sure the early Arduinos are 5 volt compatible. The microcontroller that I love to use is the Teensy 3.2, and that's like a more advanced, super duper fast. It's actually a little bit obsolete nowadays. The Teensy series goes crazy, but they're super fast and they're super capable and they hold a shit ton of memory. They're like really, it's like the, I don't want to say the Cadillac because I really don't like Cadillacs. I don't like Cadillacs. It's the Cadillac of microcontrollers. It's not Cadillac. It's the Teensy 3.2 is like very nimble and has a lot of storage space in it. It can run really complicated code without breaking a sweat. They're expensive. They're like $20-something each. But they're a great development platform because they've got all that overhead. So whatever you're trying to do, they'll be able to do it. If you want to make it, if you want to spin off a cheaper version of the thing you're trying to build, then you can try to fit whatever you've gotten working in the Teensy into a smaller microcontroller, a cheaper microcontroller. But I use those, and those output 3.3 volts, which can work for TTL logic stuff sometimes. You got to check to be sure. Those pins are 5 volt compatible. So if I had TTL logic stuff or TTL level stuff, 5 volt level stuff, communicating with my microcontroller, it won't blow it the fuck up. That's what's important. It won't blow it the fuck up, because that'll happen. If you have like a GPS unit that's outputting 5 volts and you're using a microcontroller that's not 5 volt compatible, and you hook stuff up, it'll pop. It'll stop working forever. If you're lucky, it won't. But in the case of the Teensy, it will output 3 volts. But if you send 5 volts into the pin, it's okay with that. That's important to look at, especially when starting out. Trying to tell you guys about all the speed bumps along the way, because those are what kills projects. All right, I'm going to unblock chat. Yeah, that's why I blocked chat. So there's a lot of 1 volt and subvolt, 1.8, 1.5, 1.2, 1.0, 0.8, and 0.5. Man. Whew. Chat, I'm not inviting you to my parties. But anyway, yeah, this thing is 5 volt, so everything's fine with 5 volt. I don't know why there's even 3.3 volt there. I think 3v3 is there for the, like this stuff, the USB stuff. So, can bounce off the ESD diodes and not die immediately, but maybe the 3rd or 4th time. We don't need to go over these details. We don't need these details today. We're doing basics here, guys. This is 101. If you're not interested in a 101 class, this is 101. Okay, so we've got power hooked up. We know that we are able to communicate from the output of this to the input of these with the appropriate voltage levels. We have the binary number, the 4-bit binary number represented in the pins and bused to each device. We have the 3 enable pins running back to the Arduino. The decimal place pins are not hooked up. We don't care about those. We're not gonna complicate it. I mean, we've got enough pins that we could run it if we wanted to, but anywho, so we've got all that stuff hooked up. We're ready to test. We're ready to come up with code for this. So now I'm going into the second most irritating thing in the world, and that's coming up with software on Twitch. Now we need a USB connector for this, so I need my USB, what is it, B, to the other USB. So let me get that cable. I don't know. I had a short one. I don't know what I did with it. Shorty left, so that's not the one. But I need to find that short USB-B cable that I have. I guess I could use a long cable. It's just when you get longer and longer with the USB, when you get long in the USB, you start to risk signal degradation. And that signal degradation could mean like you run into those initial problems running your Hello World program. By the way, guys, there's no embarrassment in running a Hello World program. This is Ripabop. Thank you for following. This is an Arduino Basics stream. We're going to do these on Tuesday. Not fairly regularly, but I'd like to do more of these. Arduino Basics, we're not going to necessarily go all the way back to 101, but if you want to start out with this stuff and you buy a kit, you buy your Arduino kit that comes with a little breadboard, it comes with a couple jumpers, a couple sensors, and the Arduino. You put that all together and you plug it into your computer and you go, I'm going to run a GPS. Well, you might get to know every facet of that project and still not be able to do it. The reason you're not going to be able to do it is because you never went back to do the Hello World. Nobody, and I mean nobody, is above running a Hello World program. Hello World is not just a basic intro to programming. Hello World vets out your entire programming chain. Everything, every single person, every day, everyone. It vets out your whole chain from your programming, whatever you're writing the programming in, to the connection to the programmer, to the connection to the microcontroller, to the power of the microcontroller, to the powers of B. You're basically looking at every single individual thing that goes into programming that microcontroller. So running that Hello World is more than just getting a light to blink. Everybody goes, oh, add an Arduino so that you can blink a light. Well, that's just bitter, annoying people. Those people aren't worth talking to. All right, nobody's above Hello World. All right, I'm gonna get that cable. I'm gonna get that cable. I'm gonna get those beans. Thinking about those beans. I'm stuck on the stool. Damn it. That's all right. I'll still get to my wires. All right, let's see. What do we got in here? Oh, you know what I did with the USB-B? It's on the 3D printer. That's where that went. I'm not gonna get it out of there, though. I swear I had a bunch of them sitting around here. I'm just not seeing them. Oh, great. Do I not have the right cable? That would be annoying. I would get very annoyed. Hold on. Hold for cable searching. I know I've got one around here. Maybe I kept it with the Arduino. What about in this bin? No, I've got some like epically long USB-Bs, but those aren't good. I'm not going to use those. Is there one at the desk? I think there is. I think I have one stashed away somewhere back here. Software dev is its own Twitch category. I know, I was told that earlier. I don't know. I don't think I want people who are looking for software development streams. I want people who are specifically looking for Arduino basic stuff. And they can see that, I mean, we're still in the realm of basics, right? I'm not getting too advanced today. We're going to do a very basic program in order to get this thing running. By the way, speaking of binary coded stuff, this is a pair of Nixie tube drivers with a Nixie tube voltage regulator that makes the 60 volts for the neon tubes and an Arduino on it. It's a knockoff Arduino, but we gotta work on this. Because if I get this all hooked up to Nixie tubes, which I might want to just spin off a circuit board for that, but if I get it hooked up to Nixie tubes, that means that I will be able to have a current display on Nixie tubes, but that's coded. That's binary. That's BCD. Is that what it's called? BCD? I think so. Yeah, BCD to 7 segment. Yeah. All right, so yeah, it's binary coded. It's BCD to Nixie, basically, which is pretty cool. So we'll be using the same level of technology in order to get ancient Soviet displays up and running. Where did that USB-B cable go? I wonder. I'm looking around for it. I thought it was like in this corner. What is that one? That's not it. That's not it. Where is it? What is it? It could be anything. I don't know. I'm gonna have to really hunt down this cable, huh? That's what it is. It's BCD. It's binary coded decimal. This actually needs to go in here. 50%. 50% of this is finding the hey, there's where my laser went. I'll have to put that on the bug assault. 5 tier 1 subs from Anonymous. Dude, thank you, Anon. I appreciate that, Anonymous. I don't know who you is, but I'll find you, and I'll thank you. I appreciate that, man. That's really nice of you. All those names are going up on the board in just a second here. I'm gonna wait until I hear the board moving because I really want to find that cable. I don't know what happened to it. Where did my cable go? I think there's one by the steering wheel, so I could grab that when we go to burn these 5 gifted subs. Elon Snusk, no code 3738, Aurelia 999, S Herman 873, and APO all going up on the board right now. I'm gonna find that cable. What happened to my friggin' USB cables, you know? I had all the USB cables that I could ever need in this bin, and now it's just like this discombobulated mess. That's what happens to everything around here. Discombobulated messes. Anonymous, thank you so much for the gift subs. Let's put all these up on the board. Yeah, I'll steal the steering wheel cable. Unless it's like attached to everything. Oh, it kind of is. Oh, dear God, I need to organize this. Okay, let's get the camera over here. Who would have thought a whole stream would get taken down by a missing USB cable? Oh, I see a cable over there. Maybe that's the right one. Fat chance, old man. That ain't the right cable. That's the wrong cable. Ah, my face is right near that. Aurelian999, welcome to the board. I like USB-B because it's strong. It's a very strong cable. Sir Finley, thank you for the Prime. And move the camera a little closer. Yeah, USB-B is extremely strong. I mean, USB-C has kind of taken its place since then. But I like B. I think it's a good cable. But yeah, it really isn't used in anything, so there's no point. Ah! It's just what the Uno's got. It's what the Uno has, and it's what my 3D printer has. A little Dutch angle on this one. It is. Nobody uses it. Yeah, exactly. Elon Snusk. Welcome. Ah! Dinsdale Piranha, 29 months. Damn, dude. Thank you. AP0, welcome to the board. We're going to get to Dins eventually. We got to do Sir Finley first, who subbed with a Prime. Spiny Norman says hello. What do I make of this? What does that even mean? All right, Norman. All right, we're jogging back to get the 0 point again. We're gonna jog back to 0, pop against those little limit switches, which actually, to be honest, I think those limit switches might be the cause of why the board has a little bit of a drift on it. Oh, Monty Python referenced the name Dinsdale. Yeah, they use sarcasm. Onomatopoeia. Similes. Ah! Damn it. I forgot Spiny Norman in that sketch. I gotta watch that again then. That means I need to binge Flying Circus again, which takes about 10 minutes. The camera falling like that is just because of the way, the mount works. Sir Finley, thank you so much for the sub. I really appreciate the primes. Oh, there's Dinsdale. Going below Pig Squad. Hermit's so hard to sub with a tier number 1. With a tier 0, according to the fucking programmers. They've subscribed for 4 months on a 2-month streak. 5 more months until they're sub baby. I can't wait. Dinsdale Piranha, welcome to the board. Thank you so much. You're by Deadly Hemorrhoids. Which aren't we all? Aren't we all right nearby Deadly Hemorrhoids? All right. We're going to 0 again, just because of the way this thing processes batches of names. And then we are going to burn Hermit's So Hard. Hermit's So Hard. Kermit the Frog. Notes and Volts. Yes, he's on the board. Yeah, Notes and Volts is awesome. If you guys are interested in somebody that does electrical-y kind of stuff as well as music. Because, I have to have talents in all... I'm on Twitch, I have to be musical. Everybody is so musically talented. I hate it. Anyway, Notes and Volts does music and electrical engineering stuff. He's really cool. He runs a really cool stream. Oh my god. All right, Anonymous is not about to be outdone by Anonymous and has gifted 5 subs. Holy crap. Anonymous, thank you for the 5 gifted subs. This is sudden and unexpected. This is a big gifty day. A lot of subs today. I appreciate it. It's really nice of you guys. As it is right now, gift subs do interrupt me, so we will get back to Arduino basic stuff. You can't do music. It's not that I can't do music. I have a limited amount of talent. Time for coffee. Add time. Time for coffee. Thank you for the prime. Yeah, we'll go back to the Arduino basics and you know, once we get these names up on the board. Yes, I am going to need a new board pretty soon, and as I promised chat, we basically drop everything. I get a live edge board. I can either get one from Home Depot and then feel bad about you know, contributing to the capitalist devil, or I can get it from a local place that has live edge boards sitting outside of it. The thing is, like, if I go to that local place, it seems like the kind of place where if you walk in there, they'll be like, what the fuck do you want? Like, I don't see any cars outside of it. I don't see anybody parked. Every now and then there's a person there, but they're like, we sell live edge boards. And it's like, I'll need to measure and then and figure out. What do I do with the old board? Well, the current old board is just leaning up against, it's just leaning up against a spot where I've got the board. Live edge means there's bark on the outside, so it'll be a little bit more of a, it'll be more interesting of a display to burn the names on. I mean, I could make coffee tables out of these. I don't think they'd make good coffee tables, though. I could stain them. I could do all kinds of stuff. But right now, I'm just holding on to them until I can figure out what exactly I want to do with it. The thing is, I could actually burn another... All I have to do is load the database up and mark all the names as unburnt, and I could burn another board. It would take like a year for it to burn, but... Red unlocked! Thanks to Anonymous. An anonymous gifter giving 5 more subs. That's 10 subs to 1 or 2 anonymous gifters. Sorry, 0 or 1 anonymous gifters have gifted subs. 0 or 1 anonymous gifters. Because apparently my chat can't conceptualize the physical and software worlds differently. Dale, welcome to the board. We got Havian 2050. Actually, we got a bunch of names still left to go. That's all right, though. All the way down we go. Down, down, down. All the way down. You guys, like, seriously, stuff like this helps really keep me going. This stuff fills me with determination. This stuff keeps me going. Chat pause due to scroll. I can assure you, Twitch, that I did not scroll chat in any way whatsoever. And you just randomly decided that it would be time to pause. Kind of looks like a storm's a-coming. Storm's a-brewing. Got a lot of cricket noises outside, though. That must smell nice. It smells like somebody lit a match with a little less sulfur. It's maple, after all. Demethyl Havian 2015, welcome to the board. Demethyl was already there. So I've got this strut that's been sitting below the board right now, and I was thinking of making it into something that deploys a flap that'll cover over chat. Makotronics, 36 months. Damn, 3 years of wood smoke. I got the 3-year people coming out of the woodwork, I guess? I don't know. Who just went in? Freddo Frog. Thanks to an anonymous gifter gifting 5 subs. Where are we headed to now? See, I've got these struts here that were for my big RC helicopter. That's these things. They're landing struts. This is before I had a milling machine, so this is like a disaster of a part. What these do is they get a servo signal in, and they just go 90 degrees, right, with a little geared motor. And I was thinking I could adapt one of those in order to cover over chat. So I'd flip a switch, and a big comical cover would come in and cover half of my monitor. Level 3 hype train. Holy crap, guys. That's uncalled for. Time for coffee. Welcome to the board. You're by the great Carmelino and Smoke Sucker. and VW Insanity. Now I got makotronics going up. Man, thank you guys so much. Level 3 hype train, that's nuts. We haven't had one of those in a while. Good to see. It's very encouraging. So the Arduino basic stuff is the kind of stuff that I can kind of like do in an afternoon without screwing everything up. Or if I screw up, I can at least show you guys that and correct my mistakes. So I want to do a couple more of these. And they really are completely off of the cuff. Like I was, what was it, 10, 15 minutes before the stream, I was using the bathroom and I was like, you know, I got those displays. I could do something cool with that. And then I could explain BCD decoders and a little bit of 7400 series logic to everybody. And that's really where this came from. So, I mean, displays are one thing, but we can grab any number of different types of sensors and just do an Arduino 101 with that. Yeah, having like a deployable chat cover. A deployable chat cover. Makotronics, 3 years. Holy crap. That's amazing. Hereby, ABCDFGHIJKLMNOP, QRS2WTUV WXZ. I don't know why the Y is missing. I don't care. And also, do you do? Oh, I'm not allowed to ask you that. I don't think I'm allowed to ask you that. That's not really a question that we should be asking around here. Let's just move on from that. Right. So that was a bunch of names going in, just as we're on the cusp of doing the hardware. So we've got our circuit hooked up. One thing that I would advocate here that I'm not going to do today, one thing that I would really strongly, I would really strongly advocate is that you make a schematic. Because if you make the schematic, you can refer to the schematic. You don't have to do what I'm about to do, which is poke around with the wires in order to get everything in the right place. I still need to find that cable though. I got a USB-B cable around here somewhere. I know it's somewhere. I'm gonna find it. I'll find it. Rest assured, I will find it. Maybe, and then we'll be able to actually program this thing. Having the right cable for your microcontroller, that's kind of an important thing to do too. So there was a USB-B cable that was kind of like kicking around somewhere, and I ended up tossing it somewhere. And hopefully I didn't toss it in a garbage can. I don't think I did though. I might have ended up using it somewhere. So I just need to poke around just a little bit. I think it's on the other side of the shop though. I think it's with those bins. I had like 1 or 2 of those things kicking around. I had retractable ones at one point, and I don't know what happened to those. So we'll just put you guys to face cam while I root around. See, it would have been perfect if I had Burn the Subs 3, because then I would be able to walk away while it did all the filming of the stuff, which would be so much better. But I don't, unfortunately, have that done. So, so here we are. I'm just going to end up poking around the shop a little bit, looking for a USB-B cable. USB-B. I got one right there that I can get out of that, but I don't want to have to. I don't want to have to like root it out. Wait, what's this one in between the bins? Damn it! It's not the right one. That's a USB mini, not micro. Yeah, I'll just get it from the steering wheel project, which is going to be annoying when I actually go to use the steering wheel project, and I'm like, where the fuck is the cable? And I will never find it, and I will get angry at the world once again. The world. Okay, let me go get the cable right here. I bundled up these cables and then I zip tied them. So, oh my god, and they're under everything. Ah, okay. So much stuff is in the way. With any luck, I'm done with the 3D printing on the Bug Assault. I'll be able to get that together tonight. And I think I get circuit boards in the mail. I think. Where did the USB cable go? Why is it? Oh god, it's caught on everything. I got like dowel rods over here and stuff. This is for like the chop saw miter project. And so, oh god, this is a mess. I need to break down this area of the shop and like rebuild it. just to make sure things are in the right places, because I'm going to trip over this stuff. Okay, there. I got the cable. That was easy. Actually, that was probably the hardest part of this whole day, finding this stupid cable. I'm not going to order more of these. I have principles. I think I'm going to stoop to that low of ordering USB-B cables. We've got integrity here. We're not going to do that. I don't know if any of that would count as a drop. But so here's the deal. I'm going to plug this into the Arduino and then plug it into this valve controller, steam controller adapter port that's plugged into this old mouse cable that goes back and around the back of things to this USB 3 hub. That was by the way, that was a piece of cardboard that I would block chat with in the past. That goes to this USB 3 hub that also has the face cam on it and my keyboard and mouse and a shit ton of other accessories that sit around here. That goes up and along the back of the bench. There's a bundle of cables back there that goes by Space Cop and then goes down near the Furby and plugs into the NXZT case on its own USB card. And that's how we're going to program the Arduino. That's kind of weird shit that's got to go on here in order to... So in order to bridge the gap between here and 2 feet to the right, it's got to go like 30 feet. And it'll do it through a long cable. So it takes quite a bit for the signal to degrade to the point where we're not going to be able to run the Arduino. We're not really going to be running it very fast anyway, so that should be fine. So I'll plug this thing in. It's going to proceed to do whatever the hell it was doing before. There's no light coming from the other stuff. I have no idea what code is running in this. Here's the deal with the Arduino, and actually we should power this down before bad things happen in Philadelphia. So I've got this powered down. Well, actually let's fully power it down. No power, no ground, right? No power, no ground. So whatever's coming out of these pins doesn't have any reference to be compared to. So there's no voltage level there, right? Just until we can get some code running in this thing. If I did plug it in, whatever code was in here before would attempt to run. I have no idea what I was doing before this. Whatever code was in here would attempt to run, and that could have weird effects on these. It would have been fun if they started displaying weird stuff, but you know, I probably didn't use that many pins when I programmed whatever was there first. I don't remember what we were doing with that thing last time it came out. Okay, so we're all hooked up. We're ready to program this thing. I am going to start up Arduino. Just give me 1 sec here. Where are all these coming from? Oh. Bop, 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 bop. Okay, sorry. I just had to deal with stuff there. Go back to here. And all right, so I'm going to open up Arduino. Arduino. We can run a hello world. I mean, I just got done saying that we're not better than hello world, right? I just got done saying that. So it would be kind of bad for me not to run a hello world with this Arduino, right? I should probably do that just to display to you guys how to do it. I'll write it from scratch, but truth be told, all of the stuff that a lot of the stuff that you're ever going to need is already included in Arduino programmer. By the way, I loaded a dark theme on this. There's a way to load a dark theme into the Arduino IDE. A lot of people move on to other IDEs. Let me just put this out there right now so that you guys understand, because I have to say this a lot. Whenever we go into programming, a lot of these things are said over and over again, and it's just Twitch. It's just how Twitch works. I use the basic Arduino IDE that you download from arduino.cc. Arduino.cc is the website for all these microcontrollers that I like to use. I like using the Arduino because it's fairly easy to come up with code quickly. It's so well known that you can find software for literally everything you want to do. I'm not going to update right now. We'll save that for a minute. I don't need to update my libraries and boards for a 1981 display. Anyway, Arduino is so universal that you can find almost... Arduino is so universal that we found a device from 1980 something that somebody has already tried to control with an Arduino. That's how universal this thing is. You can pull anything off of the shelf and say, how do I use this with an Arduino? It'll be like a light bulb, and you'll get projects, right? It could be anything. You know, how do I use a lint roller with Arduino? Look, I'm serious. Like lint roller Arduino. Damn it. All right, so maybe somebody could come up with that. There's no Arduino in here. All right. But I mean, that's practically, you could just take 2 words that are randomly generated and come up with an Arduino project. Are Arduinos more useful than a Raspberry Pi? Because I bought like 3 of those and never did anything with remotely interesting with them. Yes. All right, listen, cassette deck Arduino is like, that's not even, that's cheating. That's cheating. That's too easy. Yeah, Arash the viewer. So the Raspberry Pi is a computer. The Arduino is a microcontroller, and there's a distinct difference between those two in my mind. The Raspberry Pi does run Python, and so you get into it and you program it, you put the whole operating system in it, you learn how to use it, you get in the console, you go in there, you run your code that you've written, and it'll run that code. And it'll be able to do physical computing kind of stuff that we're going to do anyway, but there's so much more to the Raspberry Pi. It is a whole computer. We don't need a whole computer. We just need a microcontroller. We need a couple pins to do their boopity boop little thing. And they do their little thing, and then a display goes, and then it lights up. And we're like, yeah, that's cool. So a microcontroller is more of a bare bones system, and it will run, I don't want to say reliably, because then everybody's going to jump down my throat. Because that's what chat does. They jump down my throat whenever I say something definitive. But for what I understand, it will run things more reliably than a Raspberry Pi. It's not going to generate all that heat. Might have a little bit better environmental tolerance. It's not really going to function faster necessarily, but if you are using Python 3, it might run things faster. You can do more bit level stuff faster maybe, but that's really shaving. We're really kind of like splitting hairs here. But if you're looking to do something like, I want a current measuring display on some other device, you're going to be looking at a microcontroller for that, because you don't want to go through the boot sequence and everything of a full-blown computer, or even a full unblown computer. Thank you for the follow. That was Doug, version 71. Oh man, it took 71 versions to get here. But yeah, that's sort of the differentiation between them. A microcontroller I more think of as something that you load code onto, and then you fire it off into space and you never talk to it again. Whereas the Raspberry Pi is going to do much more complicated things. Our Raspberry Pi is getting on the Twitch API, and it's doing a bunch of like image processing in order to convert text to code. A microcontroller could do that, but we're talking about the limits of what a microcontroller would be able to do, and it would be able to do all of the logging and stuff like that we want it to, but it would be a huge struggle to get it to do that, whereas in the Raspberry Pi, it's a couple lines of Python. Whereas if I want to get this display to put out numbers and view it and see what it does, I don't want to go through the whole boot sequence of a Raspberry Pi and have to deal with all the extra current and the 3-volt tolerance and all the blah, 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 blah. So that's essentially, I mean, that's in my mind the differentiation. Yeah, I'm not really concerned with the low power consumption, but those things exist. Again, like I'm saying, splitting hairs. But in this case, this will be easier and more. It's more suited to the task. Whereas a Raspberry Pi can do that. I would associate the Raspberry Pi with much more complex structures of functionality that can still be done with a microcontroller. It's like the lines are blurred at this point. It's hard to say which one is which. But in my experience, I've bought Raspberry Pis and then I just don't know what to do with them. I don't know what to do with them because there's so much that you can do with them. Yeah, Home Assistant is a cool project to look into for the Pi. Node-RED. I run Node-RED and then Tasmota stuff. So what I can do is I can hit setup and lights toggle, and all the lights in the shop will turn off. We didn't lose power. I intentionally turned off the lights. But then I can hit it again, and all of my Wi-Fi sockets will fire up, and everything turns back on. It's part of how I automate my my setup for the stream. The setup for the stream. setup for the stream requires quite a lot of calibrations. These cameras, these Logitech cameras, work really well. They make great video images. However, you have to go through a procedure in order to get them to look good. And so in order to get permanent settings from the shitty Logitech drivers, as well as pull them through the procedure, I use Node Red. That has all the numbers in it, as well as the sequence of events that, well, actually the Stream Deck has a lot of the numbers. I should probably move it all to Node Red. It should probably all be Node Red through the OBS API. Anyway, point is, those numbers are hard-coded into other devices, and then this will pull it through. Eric Charneski, thank you for the raid. 8 people. We're doing like basics of Arduinos today, and so we're just getting to the point where I'm going to program a hello world. We'll take a look at the light blinking and go ooh ah, and then from there, we will program these 7-segment displays to count up. Happy Tuesday. Happy Tuesday to you too. Here's some canned raspberry sparkling water. Cheers. I don't like these. They taste a little chemically. It's like too much raspberry flavor. Anyway, what do we got here? So our pins are plugged in. We should have a schematic, all that stuff. But what I want is a hello world. Hello world. So here's what we do. In our setup, what we're going to do... I see your sparkling water and raising my quad shot mocha. Damn, I want one of those. I want one of those. I wasn't able to get to the store today. I had a leftover bacon sandwich, which was actually really goddamn good. I got barbecue like 4 days ago, and they got smoked bacon there, which was amazing. I just put it on a sandwich. Setup. All right, so here's the deal. We've got a setup and we've got a loop in our program. This is the typical structure of an Arduino or a microcontroller program in general. The way that I structure my stuff is a little bit off from how everybody else does it. You'll see the way that I space things is a little bit different. People may or may not like it. It's how I read a program. I do what they basically do. Bracket, space. Some people do the bracket like that so that they can view those groups. And I understand why that would be that way, but the way that I got used to seeing it is like this. I've got to in this IDE, in the dark mode IDE, I've got to like make that highlighting a little bit less prominent. But yeah, anyway, so I structure it like in Arduino because that's where I learned to program. So we've got basic C++ stuff going on here. We're going to run setup once, loop runs infinitely. We can use a delay because we're only doing one thing with our microcontroller. If we have multiple tasks that need to run at different times, things get a little bit more complicated. Our programming gets a little bit more complicated. Most of chat is lost, and it's me and 3 people writing the program. So in this case, we're not doing anything crazy. But you can think of a microcontroller as going line for line down these instructions and performing them as they occur, line for line. And that's part of code review, is reading it line for line to figure out where your program's jumping to. It'll jump back line for line. That's how you look at this, right? Because that's what the microcontroller does. It's like a piece of very complicated clockwork. And as that clock is ticking, you have one singular instruction thread that will look at addresses, load them up into things that do calculations, and move numbers around. And that's what this boils down to when the compiler gets a hold of it. So think about it that way. It just runs line for line for line for line for line. So what we're going to do here, first of all, I'm going to put in characters that'll tell the programmer to ignore what's going on. I did it wrong. I inverted it. I haven't programmed in a little while. So what that does is that basically tells the programmer, hey, you ignore this. The IDE, they ignore this. So this is a hello world example. Okay. First thing I'm going to do, let's make, how do I want to do these? I need like little prompting reminders in order to do this. I've covered over chat, by the way. You guys are covered right now. So starting out with the program, I mean, I've done all this before. I've just got to remember how I want to do this. I can use defines, or I can just do constant integers. those end up boiling down to the same thing. The compiler is a little smarter than we give it credit for. But what we're basically going to do is we are going to define our pin with the LED on it. We need to tell the Arduino that that is, in terms of general purpose inputs and outputs, that it's an output, because we're going to output to it. We need to set that pin to a high voltage level, wait, set it to a low voltage level, wait again, and then we'll let the program loop. So it's important to have waits after each of those. Now, we are going to use, not sleep, what the, oh wow. Can I not even remember how to do delay? We're going to use delays. Delays stop your thread. So if you have a lot of complicated stuff going on, if you have people pushing buttons and you have interrupts and stuff like that, you need to be cognizant of what that thread is doing, because it will, if you put a delay of like 10 milliseconds in there, that's like multiple loops of your entire program that could occur in that 10 milliseconds. We're not worried about that because we're doing one thing. We're just blinking that LED. Because the entire purpose of this program is to make sure that my path from that IDE to that microcontroller is good. So anyway, we'll do constant int. So const int, the microcontroller will store variables in a variety of different structures. You know that that number that represents the numbers of the output right here, those are 4 binary digits. I think those exist in here, but there are different number structures that you can use in order to represent variables in this program. I'm doing a constant int. We're not worried about how much memory this thing is taking up. So that int, I believe, is positive and negative, and it has a very large range of values because it's represented by, you know, a bunch of groups of binary numbers. We're not worried about whether or not, you know, we are on a capable enough microcontroller that that int is not going to hold us back. When we start to work with much lighter and cheaper and weirder microcontrollers, that's when we can start to think about, well, do I want it to be an unsigned 16-bit int? Or if we start to actually work with binary numbers on sort of a fundamental level, that's when it kind of helps to redefine these things. But constant ints are fine. So we have an integer here, and that's going to be LED pin. Now, I think, well, I'll just call it LED pin. So in the background of this program, there's a lot of helper stuff. And one of the helper things that exists within this program, within the programmer, is like defines like constant things. Like, for instance, that LED pin is actually defined on all the different microcontroller platforms. So if you wanted this to be able to be moved from one microcontroller to another, like one Arduino to another, you could use things like I think it's like output LED or something like that, or no, built-in LED. LED built-in, yeah, there it is. So that, because that highlighted in blue, that means that it's a thing. It's a thing. It's a thing within the program. It means that that tells the IDE that whichever microcontroller board I select, that variable is, wherever I use that text, is to be assigned to that number, whatever pin number that is. In our case, we're going to do it old school, so I'm going to define it as LED, capital LED, lowercase pin. It's my bastardization of camel case. In fact, let's use LED P underscore in now. We can name that anything we want, and usually I like to make them a little bit cursed. I like to go between camel case and underscores, because when you do defines, it's like the same thing. Like define, not at. What the hell does at do? Define LED pin, and you do underscore pin, and it would be on all caps as 5, and then you wouldn't put any syntax behind that. But we're not going to do that. That's the traditional way. So is this. Constant int LED pin is equal to 5. Well, in our case, 13, because the LED pin is pin 13. So constant int LED pin is 13, semicolon at the end of every line. So that tells the program that that line is done. Some people think that's antiquated. Maybe it is. Maybe they're Python programmers and they should be shamed, because Python uses white space, like tab space, in order to define all its stuff, and they don't have end line. Some people think it's completely obsolete. I don't care. but we need to make sure that that's there for all of our stuff. So right now we've defined the pins. Sometimes this pre-programmed stuff gets so complicated that I'll break it down into categories. And the reason that we put this up here is so that if we have to come back and alter this, if, oh, wait, I'm changing the pin to another pin, we're actually going to output the LED on pin 5, then all of our numbers are at the top of the program where we can find them. In fact, you should be cringing if you find regular numbers below the top block of your program. You should cringe until you die. Your face should turn into a crumpled paper bag with all the cringe that you find. If you find numbers, if you get numbers down there in those parts of the programs, you can write, bro, that's cringe, and send it back to the waiter. All right, so in setup, what we're gonna do is stuff that runs once. So what do we wanna run once? Well, we wanna define that pin. So pin mode, jeez. There's a lot of cobwebs that I gotta get out of my brain in order to program this stuff properly. So pin mode is how we define our pins. LED pin, output, done. Easy as that. So that just takes output and input. There's additional stipulations to this though, because they've added features to microcontrollers that are very useful. They've added features to microcontrollers that help us out a lot. So let's say we have a pin mode and it's our butt pin. And our butt pin, since it's our butt, is an input. Uh-oh, this is gonna get gone sexual. Input pull up or pull down. Well, pull down doesn't work in this one, but input pull up. What that does is that tells the microcontroller that our butt pin needs to have a resistor going to positive power on it, because whatever is controlling that pin is simply going to switch a ground line to it. It might be a button, right? It might be a button for our butt. Our butt pin input pull up might be a button. Whew. So that button shorts to ground. In order to keep that from shorting out our entire microcontroller, but also giving us a legitimate input, we need to have an input pull-up on it. These microcontrollers nowadays have said, well, all right, what we can do is we can add a bunch of transistors on those pins, and if you want, you can say that in your code, and we will activate those transistors, and now you've got a pull-up on your pin. So that's a cool thing that we got going on there, but we don't have to worry about that right now. So our LED pin is an output, right? This right here is where I would potentially write an initial state on that pin. If I want it to start off as high or low, if 5 volts or 0, I can say digital write LED pin, comma, high. I don't have to do that here. It's just an LED. We don't really have to worry about it that much. But I could put that in the code, and I've done that in the past for more complicated systems. So we have a pin mode, LED pin as an output, and then we've got our loop. Our loop's going to run constantly. So setup, we fly through setup. Now we go through loop, and we loop around, and we do it again and again and again and again and again. I've seen some programs that don't even use a loop. They just use a setup in order to get you into a bunch of different like weird looping blocks and stuff like that. Like the sky's the limit. People get really clever with programming, and if you happen to share program with Schmide, he really loves all of these really eclectic, these strange tricks with microcontrollers that work. They work great. They're just impossible for me to understand because I'm a big dumb guy. I'm big dumb, and he doesn't have the big dumb. So, but yeah, that's something that I've run into in the past. He's like, here, do it like this. I'm like, what do these symbols mean? There's nothing here. What is this? Anyway, in our loop, we're just gonna run that over and over again. So the first thing we want to do, digital write, digital read, digital write. Now here's the thing, we could use like booleans and binary and all kinds of other stuff in order to toggle the pin high and low. There's even registers that help you toggle pins. There's all kinds of ridiculously complicated stuff. There are many ways to get at this problem. For us, for the basics, we're just gonna digital write. So we're gonna do the LED pin, and I'm gonna write that high, just like we did before. Bam, all right, so our LED is on, and then our loop is going to occur, and then our LED is on, and then our loop is going to occur, and then our LED is on, and then the loop is gonna, nothing is gonna happen now. So we need to digital write our LED pin low. Let's test that out. So in order to program the microcontroller, chat's gonna go absolutely nuts. I would assume that you guys should ignore them. In order to program this into the microcontroller, in order to get our LED to go high and then low, what we need to do is we need to select what our microcontroller is. The program, this program at least, doesn't like auto detect it for you. So one thing that we need to do is we need to select which board we are programming to. So we are in the Arduino AVR boards, and we are the Arduino Uno. It's the second choice on this whole thing. This is why it's good to get the most basic Arduino. Have one sitting around, because if you want to go all the way back to basics, this stuff is really easy. So we're going to select our Arduino Uno, but now it knows the board, so that means it knows how to compile the software for it and upload it, but it doesn't know where to put that. So we got to select our port. Oh, look at that. It tells us in parentheses. I got our fart box over there at the IP address. But we got COM4, COM5, and COM8. Those lower COM numbers are taken up by stuff. I don't even know what the hell they are. I think we did at one point know what they were. They might be like stuff for the motherboard. They might be some random peripheral that I've got plugged into the computer. We don't know what they are. One thing that we can do, though, we just simply unplug the... If we didn't have those parentheses there, we could unplug the Arduino, take a look at what ports are available. Now I've got COM4 and COM5. This is a memory exercise. 4 and 5. COM4 and 5. I shall remember this. So I'll plug it in. And now I can select the port as COM8, the one that just showed up, because I just plugged it in. So now we're connected to our board, COM8. We could get the board info if you really want to. It doesn't really matter. The programmer doesn't matter. We're not burning a bootloader to this thing. If we were to burn a bootloader, it would treat this as a... it would need something as a programmer to like get into the what's called the ISP header. We are burning with a... We're sending code to it with a bootloader. We don't need to add a new bootloader. That's a little bit more advanced, and we do a lot of that stuff around here. But so that's our code. So now I can just hit upload, and it'll check over my code. Oh, it'll make sure that I save it. Arduino basics folder. Hello world. Okay, so our code is ready to go. It's getting checked over to see if there are any mistakes, if I forgot any semicolons. It's going to get uploaded, the microcontroller gets reset, and then it immediately starts running that code. And what we're looking for when it starts running that code, hold on, I'm going to focus the camera to where it needed to be. So AVR is done, and then it thanks you, the little pretentious asshole that it is. What we're looking for is the pin 13, the internal LED pin. We're looking to see whether or not it's flashing. I think that's L, because that's on or no, depending on what direction you read it in. Although that should be what it looks like. The internal LED pin, there it is. Yeah, you can see it, and it looks very, very dim. There's a reason behind that. So what we've done here, and remember, the microcontroller is going to run exactly what you program to the T. So what we've told it is that you're going to start up, LED pin's going to be number 13, which in the background of the code is programmed as like pin bank B location of a binary number here is going to be that pin, right? It'll do some binary shifting in order to define that properly, right? So that's what that, there's like a memory address associated with that pin that's going to be asserted as LED pin 13. So we say, okay, that's the LED pin. That's the pin we put the LED on. Great. So when you go into setup, we're going to set up that LED pin as an output. All right, cool, cool. So I'm not going to run that again. We're done that. We go into the loop, and it's going to go at 16 megahertz. It's going to go through this very lightweight instruction to set that pin as high. We go, okay, 5 volts out on there. Send it to the transistor. Then in what I think is about 4 picoseconds is what we measured. About 4 picoseconds later, it's going to go and it's going to write that LED pin low. Then it's going to finish the loop where there may or may not be a couple housekeeping things that it does in the background. Probably not with the lightness of this code, but there might be a couple like bootloadery or library kind of things that it wants to do in the background. It's not going to take it a ton of time. It'll take microseconds or something. Microseconds would actually be a very long time for it to take to do that kind of stuff. And especially since we're not running anything else in this program, I think maybe nothing will happen. It'll almost instantly go back to this top of the loop. We'll run that again. LED high, couple picoseconds later, LED low. Well, that's not very good. We can't see that. And we can see it as a very, very dim light. Even though it's got a 50% duty cycle, it's very, very lightly illuminated. So what we do is we hold on to that high LED pin level. We can build timers in here if we really want to complicate our code, but I can just hit a delay of like 30 milliseconds. So delay is default default milliseconds. I could say delay microseconds if I want to, but since we're doing basic stuff, we're going to delay 30 milliseconds. That's a third of a second. We're going to delay another third of a second here. So it'll write it high, wait, write it low, wait, come back around on the loop. If we don't put that second wait in there, well, let's not put the second wait in there. We can just see what the result of that is. No, or I could even comment it out. That's something that we will show as part of basic. See it? Double slash. It says, don't do whatever's on this line. I decided not to. And the compiler's like, okie dokie, and it just does. So, okay. So if I upload that, it's going to upload very quickly. Very, very, very quickly. There it goes. And so now our LED looks solid on. There's no evidence of it flashing, even if I move it around. No evidence of it flashing. Well, we want a flashing LED because this is Hello World after all. Although we do know that our programming sequence is now fully vetted because we saw an appropriate change in the behavior of the LED, which technically is a Hello World. But if I upload this code, we're going to be on for a third of a second, off for a third of a second. So we should get a pretty manic flashing out of this. Ta-da! Manic flashing! Now, the traditional Hello World, I think, is 1 second. So we got 100 microseconds on each end. Oh, wait. It's 1,000 microseconds to a second. So that was a that was a way small increment there. Yeah, it's 1,000 microseconds to a second. So yeah, here's your 1/10 of a second flashing. So if we do 1 second on, 1 second off, that's what that's going to look like. I got that wrong. I'm sure there's a whole string of people correcting me. 1 second on, 1 second off. Now, this is really where chat should chime in and say, that's not actually a second. They're off by a couple picoseconds, which is true. It's not actually a second on and off. It's near enough as makes no difference to humans. But in terms of like computing, that's not exactly going to be correct because it's warm in here. There's all kinds of other factors that affect the microcontroller's crystal clock. If you really want to get into super accurate clocks, you can get into like temperature corrected oscillators and stuff like that, but it's not worth it for these. So anyway, that's 1 second on, 1 second off. That's the very basic form of our program. I'm going to start up a new program. Save it as, and we're going to call this one, we're going to put in Arduino Basics. What was the name of that chip again? I'll come back to chat. Hold on, let me just get the name of the chip. 5802-7300. 5802. 5802-70. Can I put dashes in that? I guess so. I'll put an underscore. Driver. That's what it's going to be. It's just going to be a thing to simply drive it. All right, let me take a look at what you guys are saying here. I just got here? What are you talking about? Nah, everybody's complaining about white space. Comments, comments, comments. Okay. I'm just catching up to you guys. All right, cool. So yeah, anyway. What this is. So what it is. What is it? What it is. We are a 5802 7300 HP alphanumeric display running code thingy. This is 9/7. Actually, it's 2021 7/9 4:57 and 45 seconds. Okay. It's the most cursed date format that I could come up with. 9/7/2021. People will be triggered about that too, but that's just how we say the date in this country. I don't care. I don't care about everybody's complaints about date formats. All right, running a HP BCD to 7-segment type all-in-one LED display, the kind with the flat red clear front and a visible chip. I'm breaking up the lines like that because sometimes my code windows are narrower than this. Okay, so pin out. 1 is, oh God, all right, I'm just gonna copy these from the data sheet. I just wanna know what pins are going where, and I like to put that in the top of my code just so that I don't have to mess around with it. Generally, this would be the domain of a schematic, but oh well. 1, input 2, 2, input 4, 4, decimal, 5 is latch, 6 is ground, G&D, and then 7 VCC, 8 input 1. Okay, so now that I've done that, I need to put it to what the Arduino is connected to. Disp pin name Arduino pin. Okay, and then we'll do input 1, sorry, pin 1, input 2. Now we need to actually look at this thing and figure out what I plugged into where. So pin number 1, input 2, number 1. Pin 6. It looks like pin 6. Double check. Double check, double check, double check. Pin 6. Yeah. 6. Pin 2. 7. Pin 4. X. 5 is latch. 5 is up on the other side. Latch is connected to pin. Oh boy, this color scheme is not helping me. Pin 3. Pin 3. Wait, how's that pin 3? It should be 3, 4. Ah, shit. Everybody moves over 1. Everybody moves 1 pin over. Crap. Okay, hold on. I gotta move the pins over. I used pin... No, wait. No. They don't. Pin 2 is fine. 0 indexed. What can I say? Never mind. Everybody go back to where they were. All right, everybody back to where they were. Pin 2 is latch. No, which one is latch? Pin 5 is latch. Yeah, pin 2. So pin... Latch is pin 2, 3, and 4. Yeah, latch is pin 2, 3, and 4. Which would be pin 2 is the pin that goes to the least significant digit. So 4, 3, 2. Ground, VCC. Input 1 goes to pin. What pin are you going to? That would be the white wire. What? Pin 4. Okay, all right. The pinouts get more convoluted. That's not the right. No. It's this one. It's the blue wire, which is pin 5. Pin 6. Wait a minute. The fuck? Hold on. Yeah, that is pin 5. Okay, input 1 is pin 5. So 5, 6, 7. 1, 2, 4. Oh, wait, I missed one. Shit. What did I do? It's all messed up. Pin 3. Oh, I just straight up skipped pin 3. All right, pin 3. Input 8. And then the pin is pin 8. So yeah, 6, 7, 8. No connection. 4, 3, 2 in the order of digits. And decimal. Ground VCC, and then input 1 is on pin 5. So 5, 6, 7, 8 are our binary digits, and then latch is what's gonna lock it in. Now we're not gonna do like crazy binary stuff with this code. I don't think I want to do shifts of binary digits and stuff. What I'd like to do is just count up numbers. Can you do soldering hackery and use the pin for the LED for something else? No, 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 it's pin 13. Oh my God, really? Chat. I dyslexied the number. It's not that big of a deal. Jeez, all right. Control S, close it. My God, you got it wrong. Oh my God. Where did this one go? It might be in my documents. Documents, Arduino. Yeah, it's up here. So yeah, oh my God, what a transgression I've made. Oh, you guys really make this fun. No, I didn't mean to open it. Waiting. Yes, you failed to, oh God, you opened it anyway. You guys okay with that? Can I use that? Can I use that? Because the name matters so much about what I make this program into. Is that all right with the chat? Can I move on now? Are we allowed to actually move on? Or are you guys going to say something else about something that I should do differently? Should I not call it driver? Because technically it's not a driver and that might confuse somebody. Fucking A. All right. So anyway, getting back to this. What I want to do is just in the very basic sense, I want to count up in binary on these pins as a number increment. So what we need is a function that's going to achieve that. Let me set up some of the initial stuff so that we know what's going to what, and we can kind of start off our program on the right foot. But then I'm actually going to skip the loop, and I'm going to go down and make a function. So let's start off. Chats put themselves back in jail. Just set off a fart if something important happens. All right, so constant int. We're going to use constant ints because it doesn't matter. Constant int. What are we going to call this? No. Out 246. It's going to be annoying. I mean, MSB and LSB is one way to do it, or you could even reference an array. But I think what I need to do this in the most basic way, we'll just do like a constant int. I'll do this right now. Can we not? Let's do like. Nah. Damn it. All right, fine. Just out 1. Out 1, out 2. Out 4. Out 8. Latch 1. 4 is the first digit, second digit, third digit. First digit going in this direction. is on this wire, and that one goes to 3. Sorry, 2. What are the first digits? 2. Yeah, that's right. Okay. So latch 1 is 2. I just saw something on screen. What happened? No, nothing happened. All right. Do that. There we go. Position my window just right. So constant int latch 2 is equal to pin number 3, center digit. Latch 3, 4. Done. Okay, those are our latches. We need nothing else. We don't need anything else. We don't have decimal places programmed in. And those are the inputs. So assuming that we get 5 volts out of this thing, and that these components still work, that's the important part. That should be all we need in terms of pinout. One other thing that we want is a constant integer. That would be the delayer. We can't use delay because that's reserved, so we call it the delayer, and that's going to be 300 milliseconds between numbers. Let's do that. That's 1/3 of a second per number. We got 3 digits. I guess that's all right. Setup. Pin mode. Jesus. Pin mode. And we are going to choose out 1. And that's going to be an output. And we got to do this for all of these. So what I got to do? Yeah, oh, that's great. No, that's perfect. Yeah, Control Z. Nope. Take that without spaces. Because every time we hit enter, it's going to repeat the stuff. So out 1, 2, 4, 8. Nope. 1, 2, 4, 8, and then our 3 latches. So latch 1, latch 2, and then a latch 3. Now here's the deal. In Arduino, we got a lot of functions that allow us to do stuff very easily. So instead of using direct bitwise shifts and stuff, which I think will get a little confusing for newbies, what I'll do is I'll bit read directly on a binary number, and I can count up that number until it gets to a digit that I, want to overdo. So our maximum number on this is FFF. So what does FFF represent in decimal? Oh, come on. All right, we'll just do a hexadecimal. So what we'll do is we'll just take the decimal representation of this number, or we could say if the number is equal to FFF, reset the variable to 0. And then at the end of our loop, we'll take that variable and we'll just increment it. So we'll have a non-constant int. Technically, it should probably be a uint, but I'm not gonna bother with that. So I'm just gonna call it. Actually, maybe it should be. What that means is that it's an unsigned integer with only 8 bits in it. So that means it doesn't have negative numbers. It goes from 0 to 255, and then it wraps around back to 0. So unsigned integer 8-bit T. I don't know what the T is for. I actually don't know. If anybody knows, you're welcome to say. But we're not putting constant in front of it. So the compiler knows that this is a global variable. So that means we can work on it anywhere in our code. It used to be frowned upon. I used to be taught that you should not use global variables in your code, and that your functions should be able to be pulled from one piece of code to another without using global variables. We're in a microcontroller, so who cares? T designates it as a type. So unsigned integer 8-bit underscore type. Okay, so it's just cosmetic. All right, that makes sense. Yeah. So uint is equal to 0, right? It doesn't have a name. We need a name for our variable. So counter. All right, so there's our counter. And set equal to 0. So every loop, what we're going to do, I guess we're going to latch the 3 digits on their own and then we're going to update our counter. So all we need to do is run our function. So we need our counter plus plus, and that's literally the whole line. When you type plus plus like that, I mean the famous C++ line, basically your counter is incremented by 1. You could do plus equals, and then you could say like 8, and then it'll count up 8 every time it counts up. But what we're doing is we're just incrementing it by 1. So our counter is plus 1, and that's it. That's what the plus plus designates. It saves you typing 2 characters. I can't make this shit up. This is what programmers love. They get hard off of this. I don't understand it. It fills them with determination. So we're going to count plus plus, and then if that counter is greater than... Oh, and we should actually have constant int max count. Then I can comment that this is the max number that can be displayed, and I should spell it correctly. Comma FF, and I actually don't need to calculate what the FF is, or sorry, FFF. I don't need to calculate what FFF is in hex, because I could just go 0x FFF, and now that integer, the maximum is 0x FFF. So if the counter is greater than the max count, do the following. And that following is just going to send the counter is equal to 0. So now every single loop, we will increment that number. And when it goes over the number that we're incrementing it to, it'll go back to 0 and then start over. The next thing we want to do is we basically want to display the number. So disp num, and then the count. And that's it. Well, that ain't doing anything. Nothing's happening there, right? Absolutely nothing will happen. We're just going to count up a number until we get to our maximum value and then start over. So we need to make a function for this. So display number is going to have an integer that goes into it, and we'll just abbreviate it here, because I don't feel like using the same variable everywhere. And actually, that's already defined as an int. This we're defining within the scope of this program as an int. So everywhere I use CNT, that is going to only be usable within this function. So if I decided like down here that I wanted to like, if CNT is equal to, I can't do that. It's not technically defined in there. This variable gets defined in memory every time this program runs. Which, you know, maybe it's not terribly efficient. I don't know. It's probably fine. But anyway, that's going to be given space once that is actually run. And if it's a UNT, I might as well keep it as the same type. Not that it really matters all that much, but it's probably okay. So anyway, the display number is UNT count. And keeping it, by the way, keeping it unsigned means that I can go into the binary much more easily, because with signed numbers, you need to know whether or not the number is positive or negative. And so they take one of the digits, the most significant digit, and they turn that into an indicator about whether or not the number is positive or negative, which means the total number of numbers that you can put in that number is halved. So it's just something to think about. Yeah, I think you're right. Yeah, I need to go to 16T. You're right. 3 Fs is too many digits for a an 8-bit number, because each F is represented as 4 ones. So we've got 8 ones. Now I've got 12 ones. So I mean, I could go to uint 16 and it would be a little larger than the number, but that's fine. So yeah, we'll do that. The constant int would be fine with that. I guess a constant uint 16t, I guess, would work. I don't know. That's not really necessary. I don't know. Constant int would be fine. I think the compiler might pull it down to the size that it needs to be or something. I don't know. There's a lot of like weird black magic that happens with the compiler. So yeah, we'll take that to 16 just because we need the extra values. Now you counters in chat counting the amount, you guys counting with me and counting the fact that it wouldn't fit. I have words that are specifically designed for you people because that would have become apparent when I tried to compile or when the program tried to run and get up to FFF. So now nobody is going to benefit from the fact that that's going to fail. We're not going to be able to see what troubleshooting looks like on that because of you counters. Anyway, moving on. Display the number that's given to us by the counter. So what we need to do is first, let's see. I mean, we should unlatch. Everybody's unlatched. We latch 1, 2, 3 with a number in it. I could probably break this down into smaller parts. We're going to have to, instead of doing bit shifts, which annoy me, I would like to, what we're going to do, and there's no shame in doing this, chat. It's going to arduino.cc, and I'm going to pull the digits that we need out of the number and then put them to the 4 outputs. So in order to remind myself of how to do that, I'm going to go to the documentation and go to the reference. And by the way, there's like 5 different ways that you can do this. I'm going to do it in the most basic way. This is not the advanced C++ embedded programming way to do it. If you're curious about how to do that, ask any of the counters. Now let's get rid of that because I need to ask any of the counters, the maximum counters in chat about how to do it because they will tell you whether or not you want them to. They are definitely maximum counters in the chat that love to tell you how to do this in the most weird fucking way that'll confuse every single new person and discourage people from learning how to use this software. So anyway, we can do it in an easy way, in an easy, friendly way. We can use these things: bit write, high byte, low byte, bit clear. These guys over here. So what I'd like to do is just use bit read. What bit read does is it tells you to read a specific binary digit. The only thing that we could get wrong is what direction it goes in. Which one is defined as what's called the least significant and the most significant. Basically what that means is that as your binary number gets longer, the numbers that are added the latest, I guess you could say, the ones that have the highest order of multiplication on them, your later digits of a binary number. 1, 0, 0, 1, right? I think that's 9. 1, 0, 0, 1. Well, the 1 on one end, if you get rid of it, your number drops by half. If you get rid of the 1 on the other one, your number drops by 1. So 1 is a lot larger than the other. Most significant, least significant. That's how that's defined. So, the number from which to read. Which bit to read starting at 0 for the least significant rightmost bit. So least significant is 0. That'll help us out a lot. So we're going to read 0 to 4. So I guess what I can do is, well, we don't have the variables in an array. So we can't numerically iterate through an array. We could just do this manually. I mean, with a program that's this simple, it's okay to bit bang. It's okay to break stuff out into longer procedures so that you can take a look at it when you're more skilled and go, I could make this into a loop. We don't have to start at that level. We can start just manually punching numbers into other numbers. I'll manually punch the max counter in there, everybody. All right, so in order to display the number, what do we need to do? And also, you know, hey, never stray away from writing comments. So, I mean, while we could iterate through this thing in very clever ways, and it would be fun to sit here and come up with it instantly, I'm just going to write it out. And it's going to be a sequence of 3-digit representer thingies that'll go through the 16-bit number count that we've put into this. So I'm going to move my video window over. Chat's not being obnoxious for once, so I can actually look at chat. I kind of berated them for a little while, and I think they stopped being annoying. So display number uint16 count. That uint16 count is passed into here. What we're going to do is we're going to go piece by piece, and we're just going to figure it out. So first things first, I think we want all of our latches set to 0. Or maybe we do that at the end. If we do that at the end, that means they're going to remain at 0 for the rest of the program to run. So let's set latches to 0, or unset latches. There we go. Because we're going to have to come back to that periodically. So digital write, and this is me getting ahead of myself. This is the last step of the program that I'm putting in right now. Digital write latch 1 low. I'm going to use high and low instead of 1 and 0. I like using 1 and 0, but I guess what we'll do is we'll read the 1s and 0s, and those will be represented as highs and lows. Hopefully there's no inversion going in there. Digital write latch 2 low. Digital write latch 3 low. Okay, so that's all the latches. And we won't put any timing delays in here because I think these things can handle full speed. So what we'll do is we'll start off by representing the least, so least sig numbers. And so that would be the, sorry, last digit maybe. Hold on a minute. Yeah, these are hexadecimal, so that'll go directly. Okay, good. I was gonna say if we were trying to do decimal representation, that's a little bit more difficult, and we might want to look up how to do that a little bit because decimal numbers are not going to line up precisely with binary, but hexadecimal do line up with binary. So we can, our all ones is F, so that'll help us out. That's why we use hexadecimal when we're in microcontroller land, because that will allow us to directly work with the binary, and it really simplifies things because quadruple F is a 16-bit integer, right? 16-bit of whatever variable. Okay, last digit. So that's 0 through F. What we're going to do is we're going to set, so digital write. Now we could involve like a Boolean variable in this in order to open up the code a little bit and spread it out so we can see exactly what's happening. But what I'm going to do is I'm going to put a function inside of a function, which is something that we do a lot. It just means that the microcontroller goes, oh, I'm going to set this to, oh, whatever the output of this is, and it'll run a little cascade of code and then come back to where we are. So digital write, and this one's going to be out 1, and then in here, and actually what's interesting is that if we wanted to make this into a loop, we could actually make this into a loop by having like a counter that would do like 1, 2, and 3, and then it would use math in order to create the numbers that it. Okay, we're not gonna do that right now. I need a sip. I need a sippy of my sippy cup. Hold on. I need a sippy cup and I need uppies. All right, out 1 is going to be the least of the least significant bits. Let's get rid of this. We don't need this. It's going to be the least of the least significant bits. So it's going to be bit read of our counter of 0. And that's going to come back as a 1 or a 2, which is also interpreted, sorry, 1 or a 2. What the hell number system am I in? I'm in ternary. I got float, high, and low. No, bit read of 0 is going to come in as a 0 or a 1, and if it comes in as a 0, that means low. That's interpreted as low by the controller, by the IDE. It's interpreted as a low voltage value. Comes in as a 1. It's a high voltage value, which really works out because we could just do this. We don't even need to invert it, and there we go. We're going to get a display out of that. So out 1 is 0. Digital write. Out 2, bit read count 1. Digital write out 3. Bit read count 2. And then digital out 4. Bit read count 3. 0, 1, 2, and 3, and then latch that ish. So instead of writing just one of them at a time, I need to make sure that the others are not set. So while it is redundant, because we are unsetting all the latches at the end of this, it is redundant, but we're going to do it again. Even though we know these are already low, we're writing them low again. That's fine. So latch 1 is our least significant least significant dish, high. Now the question is, how long does that have to be set for? So we go back to our data sheet. Now we get to look at the really exciting parts of the data sheet, the parts that I hate, which are these guys. These little timing diagrams. Data level input, low level, setup, hold, enable input, TW. Oh, good, they're not using numbers, thanks. What is TW? TW. Display applications requiring a ±1 or decimal. Decimal point on off, enable blanking. Decimal point input pertains only to blah blah blah. Really? You're just gonna scroll on by without saying TW? T hold, T blank, T setup, nanoseconds. Jeez. We'll delay for 1 microsecond. If it's going to take 500 microseconds or 500 nanoseconds to blank, that's yeah, that ain't nothing. So yeah, this is the power of logic, of 7400 style logic, is that it's fast. Those things, man, they work quick. I'm gonna delay for 1 millisecond, which is like an eternity for this thing. So once we latch it, well, I guess setup. Here, wait, setup. Const int setup del is equal to 1. Const int latch del is equal to 1. I'm gonna set those up there just in case we need to tweak that. So setup delay and then latch delay. I over-comment code, by the way. Setup del. Delay for latch. Delay, latch, del. And again, our microcontroller is only doing this, so it doesn't matter. But anyway, latch 1 goes high here. And I guess we have to unlatch. So just like that. So now I'm going to take that big old block of code. I'm going to repeat it 3 times. So this would be the center digit. And actually, you know what? The way that I should do this is I should actually put these in their own functions, because it'll split out the code a little bit more easily, because there's definitely a tree of function here. So don't even start with me, Dion Starfire. I'll jump down your throat so quickly you won't even know you're pooping out. Wait, what does that even mean? That's a weird thing to say. That's really, what? Oh my God, ew. No, like don't, we're doing this, we're taking up the binary number and we're pulling out numbers and we're setting the pins as those numbers, 1s and 0s. This is easy and lazy as it goes, right? We're not gonna complicate this by doing advanced binary functions. we could take those numbers and increment through them and set them to the memory location that represents the pinouts of the numbers. I'm not going to do that with this. We can go to that level, but the title is Arduino Basics, so we're keeping it basic. We're doing a lot of repeating structures here of the same stuff. Well, repeating of the same stuff is kind of redundant for me to say, right? We're repeating the stuff over and over again because that's simple. We're what's called bit banging it, and it's easily accessible and people can understand what's going on. We don't have to get too complicated with this yet. We could go through and revise the code and make it a lot more complicated if we want to, but I can't be asked to do that. So location 0, 1, 2, 3, well, for the next number, that's going to be 4, 5, 6, 7 in that binary number. And now we're digital writing latch number 2. Wait a minute. Not there. We're digital writing latch number 2. I could actually just have it count 1, 2, 3 and use weird variable stuff. And then we're doing the same thing down here. So I could use more of a separator between these, and that's why I was thinking, like, I could make a function for each one, but yeah. 8. Not 80. No. 9, 10, and 11. And now this one, low, this one, high, and then latch number 3 set back to low, just to make sure we set them all to low. This is not really needed here because it kind of cleans up after itself. I figured that latch should probably be unset for when the binary numbers are set for the next digit, right? So we are bit reading our count 0, 1, 2, 3, out 1, which is input 1, out 2, input 2, out 3, input 4, out 4, input 8. And they said LSB to MSB, bit 8 being the MSB. So we got that order. That should be right. And we're writing 2, 3, and pins 2, 3, and 4. So pin 2 is our first latch, latch 1, which is connected to the lowest number of this thing. God, I hope these units actually work, because we've done all that work for nothing. But anyway, that should bring us through that. Our delay between numbers, well, let me take that delay down. So there's a counter, and then we need a delay loop time. Actually, num time. Num time. So that's the amount of time that full number is going to be on the display. So we'll put it down here. Oh wait, delayer was the one. Whoopsies. So num time. $300 milliseconds. That's a pop, 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 pop. Those numbers are going to fly by pretty quickly. I was generally trying to understand, not judging. I don't know, Jack about writing code, can sort of read some simple stuff, but that's it. It really seemed like, that's okay, man. No, don't be sorry. But it seemed like that was a lead-in to you telling me how to do the advanced binary stuff that I'm trying to avoid. So I just wanted to make sure that you knew that that was the method that we did it, and I did it by being mean, which is funny, and it's nothing personal. Okay? I don't mean to, I don't mean to put any of it down personally. I'm glad a lot of you guys come back. So, all right, yeah. This is a very simple way to do it. This is a very simple way to do it. The advanced way to do it would be to iterate through these things, or store them in arrays, or, take the binary number and shift it in order to output this stuff specifically to the pins, or just move the parts of the binary register into whatever register sets the pins. So you would just be moving a memory location around. That's super light and snappy, but it's really advanced for what we're doing. Look, Arduinos are for engineers and artists. And artists aren't going to learn all of these nuances about how to move bits around. You don't need to know that. You need to know that your variable is stored as a bunch of bits, and if you want to get them out, you can use a command to get them from specific locations. So yeah, I get spicy when coding because people don't see the trees for the forest, and the people that do don't comment. People that don't comment, and then it snowballs. All right, so let's see if I upload this, is anything going to happen? Well, first of all, we haven't connected power yet, but also we have all kinds of errors. So I'm missing a semicolon, and I will fix that. So our number display, all the way down here, we got this guy. That guy's going all the way up to that guy. Oh, I need a void. Okay, so this is, since this doesn't have any outputs when I run this function, I run it as a void. That's the thing that I forgot. So this guy right here is a void. I spent 2 days trying to learn how to read an image buffer. I was getting frustrated. Oh my God. I think that's what programming is, an image buffer. God, those are rough. So, yeah, so void, what does that mean? Well, that means when I run that function, there's no return. If I wanted to have this thing do a calculation and spit that back out on the main code, I could set that as like an int or something of that nature. It can return stuff from your functions. In our case, this is physical computing. This is physical computing. So we don't care what it spits out. It doesn't matter what it spits out because we're digital writing pins as a result of running that function. It doesn't need to do anything with the rest of the code. All right, so this is our very basic program. Let's just verify it. I should have uploaded it. Whatever. Disnum. Oh my God. What did I misspell? Disnumber. Well, guess what? Bam. Ha! Now the error is not in line 57. The error was in line 63. So you think you're all fucking smart, compiler, telling me what to do and shit? You don't know nothing. God damn it. Oh, I called it out. 1248. God damn it. Oh, that's everything. 1248. I could rename the other ones, but I'll keep this naming convention. It's only 3 digits. 1248. These are the little errors, and you got to know one of the skills in programming is being able to figure out what the compiler is trying to tell you. It's trying to tell you what you fucked up, but it doesn't know how. It doesn't know how to communicate that properly. It only knows how to communicate it in its own weirdo programmer parlance. Did I not upload it? Yeah, I didn't upload it. All right, upload it to the microcontroller. So we've gotten through the checks. Everybody programs. It thanks me, and it's already started working, but my displays don't have power yet. So I need to connect 5 volts to 5 volts, hopefully on the right pin. 5 volts to 5 volts, ground to ground. And then we get numbers. No, they're not doing anything. Oh, they're kind of glitching a little bit. My numbers aren't doing anything. Do I need to keep them latched until the next number? I don't think that's the way it should work. Well, at least we know the units work. So what has happened here? Well, we could have all kinds of different things wrong with this. I don't have a decimal display. I don't know what the state of the pins are. I could add LEDs to them if I really want. That one goes there, that one goes there. Latch is on pin 5, right? You think latch is low and not high and I'm confusing them? Let's check. If that latch pin is inverted, they could have put a line over it for me, but... Latch enable, number 5. Let's look at the diagram, and this would be low for TW. Yeah, I think I need to invert them. Okay, invert the latches. They weren't clear about that. Usually enable should have a line over it, if that was the case. It did change it to 1? They all went to 1. What happened? Yeah, number displays that don't flicker on camera. Ollie, shut the fuck up! Stop it! All right, let's take a look here. 5.5, logic voltage 0 state, minimum 0, max 0.8. So no, you're wrong. It's actually not inverted. The 1 state is 0 to 5.25. Latch enable voltage, data being entered, 0. Data not being entered, 5. So that's all I need to do. I just need to reverse the latch. Supple Stiltspeden. Thank you for the follow. Also, Ollie123492. Thank you for the follow. And Surovi. Ollie probably immediately unfollowed though. All right, so let's invert our latches. That's what's going on. I don't know what weird stuff is getting by, but basically I'm just gonna turn my highs into lows. Highs into lows. Wait. Oh. Unset all the latches. Oh, there might be an error too. Wait, how did that get through my steel trap of a... All right, so we're setting them all to high. And high as well. Latch 3, unset it by going high. Latch 3, set it by going low. This one high. I'm doing this by spelling it out, but I mean, I could like put an exclamation point in front of them if I wanted to. Unset that by going high. Unset that by going high. This one go low. This one go high. Almost done. Almost done. Hello. 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 Goodbye. Okay. There we go. Oh, there might be high. No! It's getting through the day by making weird voices that entertain me. Okay, that should probably work, right? Could you create aliases for the low and high latch and unlatch and just... Yeah, I mean, you could do that. You could do that up in the top of the code. Anything is possible. You can reset things to be, you know, other things, but I don't know. It's not really worth it. I mean, I could latch and unlatch. I could make a function for latch and unlatch that would set it properly. No, it's not. No, it's not. This is basically... I named this variable after chat. All right, let's upload this. One, 2, 3, 4, 5, 6. I can count numbers. Oh, God! Oh, it went into symbols at the end. A, B, C, D, E, F is not exactly... It's not actually represented in here. Wait, I think that has to do with the state of the decimal, doesn't it? Let's go down to that table for the decimals. We got it working, though. That's pretty cool. What do you guys think? So Arduino basics. Anything is possible with Zombocom. Oh, the 7304 is the one that does it. I see. Blank, blank, dash, blank, blank. All right. So yeah, that's unfortunate. So I guess if we get to 8 as the least significant bit, we can jump it up as 1, 2, 3, 4, 5. Add 5. Because, yeah, A is 8. Wait, 8, 9, and then boxy 8. So we can undo the boxy 8. And then we can jump 6 places. Yeah, it's not actually a hex display because of the part number. Luckily, I didn't see chat telling me that, because I'm sure somebody would have sounded the emergency alarm and said, bother, if you don't know this right now, everything is going to be ruined. But in this case, it's not. And that's what I like to show you guys. So let's get it to count like reliably and faster. I'm going to make it go a lot faster now. So when we reach 9, huh? 1001. Let's see if let me think about that, because that's for all 3 displays. That's for all 3 displays that would need to do that. Ooh, that's a little bit more complicated, isn't it? I think I might need to like read the location of the register and see if it equals to high, low, and then if it does, increment it beyond there somehow. How would I do that? Yeah, modulo, you'd have to get into the more complicated bit maths, right? I mean, I could do the bit reads and the bit writes, but that's stupid. If I look at that specific binary number, like check all the digits to see if the binary number is there, and then if it is, set it. And then the plus plus operation would still add 1 to it. That'd be a really weird thing to do, right? I could write a giant nested if statement, but that would be stupid too. If I shift it and see if it's greater than I'd have to blank out both sections. So for the least significant, I need to blank out everything else and see if it's above 9, and if it is, add 4. Yeah, it's a little harder to do. It's a little harder to do. Thinking about how I can do that. If I take the decimal number and I do something that will... Oh man, this is more complicated. Let's see. Hexadecimal representation. I'm trying to get my thoughts straight on this, because there's a couple different ways that I can go about this. Setting these to just be... Yeah, what's modulo going to do for me in this case? If I set it, divide it evenly into the number... I'm going to look up modulo. Let's do it on Arduino.cc. Because I can convert like decimal numbers and stuff like that, and there's plenty of things that are already like that already exist. There's plenty of code snippets that already exist, right? Print to string, extract 0 from each character. Yeah, I guess you could put it like that, but would it would go to, yeah. All right, let me just look up and see how that math would work out and see if I can figure it out on stream. The complicated on stream operation. So it would be like if I divide it by the particular number. Yeah, it'll just use the modulo and stuff anyway. Well. Algorithm 0, roller variable 2404. So if the modulo is 0, maybe I can find something that explains it better. Yeah, I know some of you guys are keeping quiet because I was mean earlier, which is fine. I can figure this out. So what would we do? Decimal to hex Arduino. There might even be a function for this. That's not what I wanted to do. Why does it matter? Oh, shut up. Shut up, system, you fucking asshole. All right. Hexadecimal is base 16. Yes, thank you. When you divide a decimal number by 16, the remainder is 1 hexadecimal digit. This is what we're getting at in chat. Remainder of 0 goes into the character 0. The remainder of 15 goes in the character F. Take the quotient of the division, perform the same process of the remainder. So people write over, oh, Jesus Christ. All right, that's a little too complicated. I don't want to look up the definition of all those math terms, right? All right, Ollie, calm down. Calm down, man. We're going to get through this. It might not be the way that you want us to. And I might go a completely circuitous route, but I got this, man. Fem from Mars. Thanks for the follow. Decimal to hexadecimal. Google for decimal to hexadecimal online converter. Thanks, Ted. I really appreciate you coming in here and being my chat. All right. I gotta just jog the memory and see if there's a good way for me to do this. I mean, like print hex. We're not printing to serial. That's an easy way to do that conversion. But it would be like BCD. The aliens are coming to critique the code. Yeah, right. All right, nobody's on the right thing here. Decimal to binary to hexadecimal. All right, so I don't need to convert it away from binary. I mean, decimal to binary, and there might be a function to that. Blah, blah, blah. Hey, look at my trolley. Okay, thanks. Size variable. Blah, 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 blah. Serial print. Everybody wants to go serial print for some reason. I mean, what if we go... Yeah, exactly. Put an Ethernet hat on, upload it to the cloud, pull it from the cloud, then date stamp it, add it to a database. All right, it would be, what would we be doing? We'd be doing like, if we do BCD Arduino, convert decimal to BCD. Well, there's the equation. Trying to convert a decimal value to BCD order, this seems not to be working at all. It gives us tens parts to use, such as 27. So 27 example, blah, blah, blah. Correct. This is kind of crude. Yes, it is. Stop is equal to 0, while x is less than 10. Stop is 0, value times 10. Upper byte, stop. Jesus Christ. A little bit more, doesn't quite do it. Put the two together. Lower byte, value, and 0, 0, blah, 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 blah. Decimal result is less than 10. Upper byte is x. Stop is equal to 1. Else is x. Blah, 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 blah. I'm thinking, so what I'm thinking of doing is just finding when that specific number in the sequence is above like 9, and then taking that and just incrementing beyond it, right? So that we don't get the anti-characters in there and the software just skips it. That's all I was thinking. So if I use bit shift, which I didn't want to do, I could do bit clears, but that would be dumb. Low byte, rightmost byte. All right, so that's all we need to do. Low byte X. So yeah. So what I need to do, I'm not going to look at chat. I'm not going to look at chat because I'm going to do this my own stupid way. I'm not going to do a chat stupid way. Because they're all stupid ways. So what we need to do is we need to detect whether or not that low byte is above 8. So if, first of all, we'll do count plus plus, and then I'll do like a byte check. Counter plus plus, that might be above the number. So we'll do a byte check here. Byte check of the counter. Right? So now we got another void down here. The void byte check int count. I guess I'll use double N. I don't fucking know. All right, do that. And then what we're going to do is we are going to first shift. No, we're going to first do if low bytes of count. Actually, the uint8t. uint8t of the count. If the low byte of count is greater than 8, I'm correct that that returns just like a number. A value of any type. So if it's greater than 8, which is oh, it does, no wait, it does display 9. So if it's greater than 9, then what we're gonna do is count plus equals, which means we're gonna add the count. We are gonna add how many to it? We want to get to 0. So what we're gonna do is we're gonna add. I mean, I could directly influence the bytes, but I think whatever. We'll just set it up. So that'll be we're at 9. 1, 2, 3, 4, 5, 6, 7. Well, if we do up to 6, then it'll equal F. Oh no, but F can't display. So will it ever be triple F? Yes, it will. It'll be able to go above that number, because it'll be able to go well above that number because it's 16-bit. So yeah. So anyway. All right, so we're at 9, and 1, 2, 3, 4, 5, 6. We add 7 to the number. It's really weird that we're adding 7. Is it really 7? 1, 2, 3, 4, 5, 6. We're gonna add 7, and if that breaks it, then whatever. Plus equals 7. If low byte of count, something or other 9, wrong bracket type. Oh bother. Do you even know how to code? Even though it's software is oh bother, how dare you? This is my show now. I'm gonna tell you what to do. We're gonna add 7 to the count. This is a very low-tech way to do this. Count greater than 9, add 7. If now what we need to do is if the low byte of count shifted 4 bits. I gotta look up bit shift to make sure I get that context correct. I don't want to get that wrong. So bit shift, yeah, jerks. Bit shift. What it do? Go back. Okay, bit shift to the right. I'll smash away the remaining 4 that we're not looking at anymore. Bit shift to the right, and then we take the low byte. So the low byte of the count bit shifted by 4. Is also greater than 9. I could use more variables in this, by the way. I probably should, but or I could probably even iterate through it and use something to do that. But count plus equals. Oh God, what are we adding to it if we're adding those numbers? Uh-oh, wait, what does that even mean? Maybe I do want to directly influence the bits. Maybe I want to actually shift that location of count to 0. I might want to do that. Because if I just adding numbers to it, yeah, that's not okay. Yeah, I'm gonna have to take direct control. How can I do that? This is where we get into logic now. We need to do an and, or do we need to do a? I mean, I could just blank them out too. I could just bit clear. I could bit clear, and that would be more direct, but it's also dumb. Using a bitwise or a, you know, an and or whatever would do it, because what we're talking about is logic gates, right? So what I could do is if I put an OR gate in there, that would mean, oh Jesus Christ, just show me the OR gate. That would mean that if I set it to a 1, that's not gonna work. No, not an OR. And nope. Maybe like a NAND? No. Nor. if I set the bit to a 1, I want it to blank it out. If I set it to a 0, it doesn't matter. That inverts it. Probably am I crazy? Did I want an OR gate? Set it to 0, it doesn't harm it. Set it to a 1, it sets it to a 1. See, that's wrong. It's not what I wanted. I wanted to set it back to 0. What would that do with everything else, though? That wouldn't increment beyond that. That would get stuck. Damn it! Ah! Okay, hold on. Let me think about this for a second here. So what do I need to do? My brain hurts, everybody. I'm trying to take control of the bits directly so that I can skip sections, right? I just enjoy the headbanging. Yeah. What am I doing? I'm struggling. That's what I'm doing. All right, so what do we want? We want for those 4 bits to set to 0, and then the next bit down the line would have to go to the next digit. So that would have to increment on its own. Ah, damn it. How do we do this? What are the... That's too many detections. It's great if you're in the least significant digit, but if you're above that, I mean, I guess I can shift it and then do the work on it and shift it back, but that's silly. We need BCD counting. That's what we need. So how do you do BCD counting? BCD counting. Let's just put Arduino on that. BCD counting, 2-digit timer counting, blah, blah, blah. Arduino 8-digit 7-segment BCD counter using a max 219, but that might not actually count the, have weird values that we need to skip, right? I put his email on that. Yeah, mydisplay.setDigit. No. That's annoying. Brief convert hex to BCD. This function converts hex to BCD. What the fuck is that? Okay. Unsigned character I while number. What the fuck? There's that equation again. Number is equal to number over 10. I plus plus return K. Jesus Christ. So while we have a what the fuck? Hold on a second. What is this guy? Jesus. Unsigned int number. All right, so we got an int. That's our number. Character I is equal to 0. K is equal to 0. 0 is equal to 0, or number modulo of 10 is less than I times 4. But I is equal to 0 while number, we're I plus plusing. So we set that to 1 on the second loop. Number is equal to number over 10. Yeah, it's left shifting it, sorry. Sorry. I'm so sorry I misspoke. All right, guys, come on. So that's shifting it left 0 to 4. Dividing it by 10. I think I kind of understand what's going on. I was just treating the number as a decimal. That's true. I don't know how the Arduino does that. Arduino hex to decimal. If I go hex to decimal and then I just put that into the bytes. That's probably when they converted to strings and then back. That was the other suggestion from earlier. I was hoping it would be easier to do with bit math, but it turns out you got to use modulo and shifting, and I guess they're using they're scooting it over 4 times. Right? I think so. Yeah, the wall is an OR. Yep, that's what it is. It's a bitwise OR. K is equal to 0, though. So I guess it's just a system of masking. I mean, this isn't bad. I don't understand why number is in this while loop, though. While the number... But that has to equal a value until it gets to 0. Something over 10 would be 0. So if number is 0... What is making number? What are number? Unsigned int number... What number are number? Number over 10. We're dividing it by 10 until it's 0? What else is influencing number? Yeah, the number you want to convert. Divided by 10 until it's nothing. Alright, well, I mean, you know, hey. Maybe we could just take this. Hex to BCD. Unsigned int number. Yeah, okay, so 10 hundreds of thousands. It checks each one. And this is close to, I guess, what I want. Keeps divided by 10 until the number's 0. So it knows it's done all the digits. Is that not how that's not how division works. I guess in bit math, that is how division works. Yeah. Modular arithmetic is too glowy brain for me. Yeah. It's one of the bit twiddling tricks. By the way, this is not a pornographic search. Bit twiddling hacks from Stanford Computer Labs. This is a good resource. It looks like Windows 94, which totally existed and I totally used, I swear. But yeah, bit twiddling hacks are ways to go about doing a lot of these functions that we're just looking up. Yeah, that's what I know. When you do divisions operations and stuff in a microcontroller, it's a little bit different because it's binary. So it's not even bit twiddling tricks, it's hacks, bit twiddling hacks. Counting bits set, counting bits in rank. Yeah. Cool stuff. All right, well, let's steal this guy's code. Let's make it our own. Unless there is one in here. Hold on. All right, I could get lost. I could get lost in this. I'm not going to do that. But yeah, these are some good hacks in here. All right, stealing code. So we're doing a byte check. And I guess what this is going to do is, what will this do? What is this supposed to do? It returns the BCD. So actually, our maximum number is 999 now. It's not hex. It's just straight up 999. So that's our 16-bit number. That's going to be the maximum count. So that when our counter gets above that, we reset to 0. And then what we'll do is we'll just take that number and we'll make sure that it goes hex to BCD before we operate on it. And we'll pass a different variable into our stuff. So uint16t count, and then uint, we'll do uint16t again, count is equal to, oh god, this guy had all kinds of capitalizations in his function. I'll clean it up in just a sec. Hex to BCD. We'll pass that count in. So when that gets passed into this program, we will convert it and then act upon it. I could do that earlier if I want to not really mess with that, but whatever. Because, I mean, I could come back up here and actually do that and then change these two variables. I'll do it here. I don't know. Whatever. So, yeah, we'll do that there, and then I'll take this and freaking clean it up. Jesus. This is weird. It looks weird to me. It's probably totally normal to other programmers, but it's a little bit strange to me. I guess that's the power of the internet, huh? I think there's all kinds of other mess up here, isn't there? We've got unsigned int, hex to BCD, and then this stuff, go in one. Where's that going? Yeah, that one's seems extraneous right now. I think that was left over from whatever was going on before. And then we got this stuff here going like this. Man, that function did not have to look so sloppy, did it? Cut the blue wire? Never. You guys can backseat. I've just been kind of mean to backseaters. Arduino basics, steal code, yeah. So, man, that's so confusing. While number, so that means while it's anything other than 0. K is equal to 0 outside of the loop, which, so, all right. K is equal to 0, character I is equal to 0. I is what increments through the while loop. So as that's counting up, we are shifting left to the number over and over. We're taking the modulo of that number. So whatever's left over when you divide, or however many that goes into evenly. I forget which one it is. Which one's modulo and which one's remainder. But anyway, whatever's left over from that, it is ORed with the number, which is equal to 0. I don't know why that's even in parentheses, but I guess just for formatting purposes. And then it's punched back into that number that's left over. Number is going to equal the number over 10. That's divided again. As long as it's not equal to 0, it'll keep running, right? The function's idea of unsigned int is 32. Arduino uses 16 bits, 2 bytes. You need a full word of 32 bits. Why do I need a 32? Modulo is the remainder. Okay. Why do I need 32? To make up for 4? Can I lower that down? Can I make it 3? 999 is 3 bytes. Wait, what? What are you talking about? Does it need the number in hex here? Because I've defined it as a decimal, not as a hex. This is why I don't like backseating. No, this is fine. Uint 16T. The limit is 65,535. All right, let's just test our code, because that's the beauty of the Arduino. We're doing physical computing. We don't have to give a shit about what anybody says. We can just test it and see if it works. Let's see what happens with what's his name's code in here. Who's this person? This person who gave me this wonderful little hack. Where did they go? Where did they go? What window was it? This is from possibly Arduino engineer. Well, let's see what that does. It's gonna explode! You got something wrong! Oh my god, everything's going to explode. Byte check of my counter doesn't work. Oh, byte check is no longer a function. Rest in pepperonis. I'll always remember you. Upload. Random blog means it's not even his, it's just stolen somewhere, yeah. Flash verified. Why is it not programming? Done uploading. Oh. 4, 5, 6, 7, 8, 9, 4, 5. Oh, look at that. Well, whoop-de-poop. Good thing I don't understand anything about how that works. I need to sit down with a freaking calculator and figure out why that works. It has to do with the bits, so now the bits are moving and the blah, blah, blah. Yeah, I don't understand that absolutely at all whatsoever. This is a fairly simple thing. I'm wondering if Arduino has something that already does that. I mean, we did all that work and I didn't even properly look at the, what do you call it? Didn't even properly look at the Arduino CC. Like, I wonder if I can convert it. Loop setup, blah, 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 blah. Maybe it's in the math functions. Const scope static volatile. Array boolean byte character double. These are just the types. Int long byte float long word. I mean, maybe converting it to a string, but I don't know. It clears and reads and sets, randoms, tones and pulses, analog reads, alphanumeric, hexadecimal digit. Actually, we could shift it and see is hexadecimal digit. Nah. We're trying to figure out how many licks it takes to get the center of a Tootsie Roll Pop. And then OctaJ says 1,113. I was a bored child. That's a string function. Ah. All right, whatever. I thought they would have it. Bit twiddling might. Probably not. But it's common enough. Or at least maybe nobody's using 7400 series logic. I mean, it's 3 lines of math. 3 lines of math that take advantage of weirdo how much is remaining when you divide by 10. Because it's basically taking the number, then dividing it by 10, then dividing it by 10 to get a number left over. And when it gets that number left over, it determines whether or not it fits into decimal. And then, I don't know, it does some weird bullshit in order to poop it back out. I don't think there's BCD functionality in the Arduino library. There's nothing weird about that. There's probably a library that does it. Yeah. Maybe the math library does. You don't need to convert between number representations in code. You can do whatever you want. The compiler does it for you. Yeah. Okay. Anyway. Arduino, the #1 micro preferred by pirates. I don't know. They like C code a lot. They have a love for it. Anyway, yeah, our numbers are counting nicely. So there we go. Now we can make the bomb that this thing attaches to. Whatever else your code wants to do. Like if you want this to display like a current that's coming out of something, you can set it to have a decimal place if you want to. It's just you would manipulate that number. In our case, we were manipulating that number in order to make a count, but you could also use like constrain functions in order to make sure that it displays properly. And then sky's the limit. You can read an analog input. You can do all kinds of different stuff with that. So that's using an old vintage display on an Arduino. And I think we got pretty decent results out of this thing. I like the way these things look. I don't know if I'd really want to use them in a ton of stuff, but they do have a particular look about them, which is nice. Your bomb is counting up. It'll never go off. Oh, no. What is that wire that's in the way? What is that? It's in the way. Oh, that's the scope. That's the arm. Yeah, look at those little things. They're pretty cute. Pretty neat looking displays. I like how they look so electronic. Those were weird though. I expected us to have to find a 7400 series BCD to decimal decoder in order to run a segment display. And the segment displays are harder to run just because they're more difficult to connect to the breadboard. So like these pins can kind of fit sideways over this. But yeah, they've got weird pinouts that directly control the digits of that thing. So many blinkies, yeah. It's a shame that these aren't the better ones, the ones that can display like letters and stuff. They're not very bright, but neither am I. I should unplug it right now, so you guys will never know. There we go, we rolled over perfectly. My code works. My code works. My code works. La 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 la. So yeah, anyway, that's those displays, and that's the Tuesday's Arduino basics. I've pretty much gone overtime today, which is great. That means we actually had a lot to do today. I'm going to try to do Arduino basics on Tuesdays. Hopefully not too many of you guys are completely and utterly fucking triggered by it. I keep things simple. I program things simply. I am big dumb, but that allows other people to follow along with us. So, and then we can actually have streams that have conclusions, like a counter that actually works, you know? So that's always good. I'll try to do that at least until the board fills up. Other than that, I mean, you know, a lot of parts you probably have gotten here today. So I probably have RC car stuff that we can work on, like next stream, right? What's that? The hex to BCD function works as follows. Oh, okay, I'll read it. Let's say the number's 1, 2, 3. We get the first digit with the number modulo 10. That gives you 3 because the 3 divided by 10, the modulo is 3. Put the value of that digit in the first nibble of the k variable. So the 0, 0, 1, 1. Divide the number by 10, which gives you a 12. What? Put the variable first nibble of the k variable, divide by the number 10, which gives you 12. Get digit 2, place in the second nibble. K will have the hex value 0x123 when the loop ends. I don't understand any of that. Make it count minutes. I mean, that would just be... Counting minutes would just literally just be like, I'd have to change some of the numbers around, but it would be 60,000 milliseconds. That's it. That's how you count minutes. Not very accurately. You would probably want a clock module on the thing. All right, that's all I got on you guys. My head hurts. Let's see. I don't really think I want to do the rating today. What's Brett doing on a Tuesday? Atlas. He's probably in the middle of a D&D. I'm not gonna raid D&D because it's tough. Takahata's doing golf club. What's Rabaz up to? Tormented Souls, and then he has just boobies written on his title. Well, what does that mean? Tom's doing Cartoon Mess. Yeah, let's do Cartoon Mess. We're gonna raid Cartoon Mess live. It's Tom Thinks. He's doing live puppetry on Twitch. It's pretty cool stuff. 1, 2, 3, store 3, shift 1, 2, store 2, shift 1, store 1. Yeah, I think that's probably a better way of explaining it. Yeah, I know. Look, Twitch comments. You don't have a lot of text to run with. I was getting towards the conclusion, and then you explained it, and it just it was like stuffing the explanation that I carefully molded and tried to figure out and was almost there, stuffing it through a colander and having it squish out in little tiny hairs because it just totally destroyed any brain meat that I had running on it. It's basically you're shifting the number over and you're making sure that you're storing the right stuff. It's a little bit more complicated than that. I'm not going to sit down with a pen and paper and try to figure it out, but I sort of get the gist. It's just tough. Yeah, it's magic. Let's just go with magic. That's kind of what I was trying to do, is shift the number over and then see whether it was greater than what it needed to be. Whereas this one's using modulo and remainder to do the same thing. So modulo, remainder, and an incrementer to do it increments, modulo, and remainders in order to, oh my god, in order to do that. My brain, guys. All right, let's turn off our brains a little bit here. Let's raid Tom Thinks, and it should be a silly time. Tom is a wonderful show. You should definitely check him out. Tom Thonks. Oh, I'm just literally just typing his name. Raid. Oh yeah, the end card. Thank you so much, OctaJ. I appreciate that. Good to see you around. Next stream is in approximately 1 day, 18 hours, 18 minutes, and 40 seconds. Go. Well, that's just the raid start. Go, but we'll, you know, raid Tom Thinks. Ah, I got it right. The logo came up. Success. All right. All right, so we are going to raid in. Well, that's going the wrong way. When it reaches 40,